will be a star freelancer. Learn new skills. Set your goals. Increase your skills. Browse over 100 plus videos and ebooks. Jump to starfreelancer.eu.
Three.Js is a JavaScript library that allows you to create 3D scenes directly in the browser, ones that you can actually interact with and put HTML on top of to get to your next page. So how do we go about creating a scene like this? Well, we're going to need to do a few things. The very first is we're going to need to install Three.Js, and we're going to be doing so using a front-end framework called Vite. We're going to need to create a scene, a camera, and a render. Three things we'll go over that are part of the Three.Js framework. We're going to need to create a plane, and what I mean by plane is a plane geometry. This entire square right here is considered a plane in Three.Js, so we're going to need to be able to create that. And then if we look really closely, each individual vertex on this pane, we need to make sure that it moves individually and then interacts with our mouse as we actually move it across the plane. So you'll see right here, we're going to need to add that hover effect I just mentioned. We're also going to need to be able to modify this plane to our taste using something called dat.gui, which is this interface up here. Basically, if I go ahead and start editing this, you'll see the plane in the background begins to edit as well. This is super useful for debugging and making sure that you get the right look on your scene so that your end product looks exactly like you want it to. And then finally, we're going to need to be able to add HTML on top of this and make sure that it integrates with JavaScript so the HTML doesn't get in the way of our hover effect, and then we can go to the next page when we click something like a View Work button. To create this project, well, we're going to need a few files. So the first thing I'm going to do is I'm going to open up my Finder window, and I'm going to go to a directory where I'd like to create my Three.Js projects. So my home directory right here is Christopher Liss, simply my name. And if I begin to scroll down, there's going to be a folder in here called 3. This is one that I created specifically for any projects that relate to Three.Js. So if you don't have this folder right now, just go ahead and press Command-Shift-N if you're on Mac, and a new window will pop up. You can name this whatever you want. I recommend naming it 3, like I have right here. If you're on Windows, just go ahead and right-click in an empty area and click on Create New Folder, and you should be able to create a folder called 3. So we have this folder called 3. I have another folder inside of it called 3, and that is just for the finished version of this, so ignore that. But we want to create a new folder. This is going to be called My Portfolio. So if you see over here, this text, this super edgy text with my name on it and then some sort of description about me, this is an example of a portfolio site. It's about to introduce my work, so people, whether they be clients, whether they be a job opportunity, know what I am capable of in case I would like to pursue a job or a client. So we're making a portfolio site essentially, and this folder is called My Portfolio. My project makes sense. So we have a directory for our project, but now we need to open this up in a text editor of your choice. So the text editor I like using is always going to be Sublime Text. I know a lot of people like using VS Code. No matter which one you use, you should be able to grab this directory and then drag it on top of your text editor, and it should open up directly in your text editor, as you'll see right here. But now we need a few files. We're going to need an index.html file, which basically houses this whole project, and then we're going to need a JavaScript file, which houses all the code for the background scene. So the first thing we want to create is some index.html. If I want to test some HTML in the browser, what I always like doing is just creating a simple h1 tag. And inside of this, just typing whatever text I think of. Hello is the first thing that comes to mind. And if I go to File, Save with this text in here, and you'll see the new tab open. If I go to Save, I can now save this as a specific file. Where do I want to save this? Well, within my 3 directory, and then inside of the My Portfolio directory we just created. So this is going to be called index.html, and make sure you add the .html to the end of this, otherwise the browser won't recognize this as valid HTML, even though we have HTML inside of it. So we're going to go ahead and save this as index.html, and once I do that, you'll see my brackets light up, meaning we have valid HTML inside of here. So we want to make sure we save. I'm going to hit Command S, right click this over in Sublime Text, and then reveal in Finder. That's just going to open up our project exactly where we were. And now what we can do is we can double click index.html, and our HTML is in the browser. So we know our file is being read, which is perfect, but now we need to import Three.Js. Well, how do we do that? You'll see over on the Three.Js website, their installation page specifically, there are a few ways to install Three.Js. One of them is to install from npm, which is package manager, a little more difficult if you're new to JavaScript. And the second is to install from a CDN, and this is basically just copying in a URL that contains the library code and just placing it inside of your project. So you might think that this is probably the easiest way to do it, but let's go ahead and install it this way and see what happens. So we're going to install from a CDN, basically a URL that pulls in all the Three.Js code. What I'm going to do is I'm just going to copy these script tags. I'm going to go back over to Sublime Text in our project, and right at the bottom of this, I'm just going to paste in the script tag. So theoretically, we should be able to use all the content within this URL right here. Let's go ahead and see what content is within this URL first. If I go ahead and copy this URL, paste it in the browser, and try visiting it, you're going to see cannot find package 3 at version. That is because Three.Js expects you to add a version to this URL before you can actually pull it in. So I'm going to type 0.126.1, which is the latest release as of the time of this recording. And if I hit enter, you'll see this is all the code that Three.js consists of. It's a huge file, but this is everything we need to create 3D scenes in the browser. So we want to make sure we're pulling this into our project. We can copy the URL right here, go back to Sublime Text, and make sure we are replacing this version that just has the version inside of the carriage. We want to go ahead and replace this URL with the one that specifies that we want to use version 126.1. So now on save, if we go back to index.html and refresh, nothing happening. Well, let's go ahead and check out our console. We can check out our console by right-clicking and clicking inspect. If I look inside of our console and refresh, still not getting anything just yet. But if I go on over here to our code and then console log out the scene that we are creating with Three.js and then refresh in our browser, you'll see that we are actually console logging it out. So we successfully imported Three.js. We can actually write all of our code directly here within this script module. Now, typically, I like having all my JavaScript in a separate file because it makes things a little cleaner for when I want to bounce between what's HTML and what is actually JavaScript, what is in the 3D environment. So what we're going to do is we are going to create a new file by going to File, New File. It's going to open up a new file over here in Sublime Text, and this is going to be where all of our JavaScript goes. So we want to make sure that we are saving this as simply index.js. That is going to be our main JavaScript file. So we hit save. We now have a JavaScript file in place. If we go back to index.html, we want to make sure that we are taking this JavaScript code over here, going inside of index.js, pasting it in, and then we need to make sure that we are referencing index.js from our HTML file. So to reference this, we can add in a source attribute, and we want to make sure we're going inside of our My Portfolio directory, which we have right here, and that we are referencing index.js, our JavaScript file. So save, refresh in our browser, and you're going to notice something. We are getting an error. Access to script at this URL from origin null has been blocked by core's policy. Now, cross-origin requests is a whole nother beast. That's probably its own tutorial in itself. But basically what's happening here is since I'm trying to pull in this package directly from a separate index.js file rather than within the script tags from index.html. We're getting this error. We can't actually pull in the scene that we want from Three.js. Now, a quick and easy way to fix this is to set up a local server. Right now, we're simply running the HTML file in the browser, but if we set up a web server, something that's there for the purpose of serving up web files to the browser, this error is going to go away, and you're going to see that shortly. So what is the quickest way to set up a front-end web server? Well, in my opinion, it's using a framework called Vite. Vite is essentially a front-end server created by the same guy who made Vue.js, and whenever you save a file within the server, it's going to automatically update your page with all of your new code, so it's super helpful when you're developing. You don't have to save, go back and refresh. This is going to refresh everything automatically. So this is what we're going to be using for our server to make sure we don't get that weird CORS error whenever we are importing Three.js. So how do we install Vite? Well, we're going to open up a new tab, and we're going to visit vitejs.dev. We're going to click the Get Started button, and we're going to start scrolling down. And right here where it says scaffolding your first Vite project, this is what's going to help us create a Vite project. So we want to use what is called NPM, Node Package Manager. If you're unfamiliar with it, basically it's a Node.js app that allows you to download external packages from other authors, such as Three.js, Vite, Vue.js. You can install all of those using npm. And the useful thing about downloading packages with npm is you're always going to have a list of all the packages that you're using within your project and what versions they are, so that if another developer were to come in and use your project, they'll know exactly what the project is using. So two things here. One is Vite requires Node.js version 12 or over. And two, we need to make sure that we run this directly within our terminal with npm. So you also need npm installed. Well, what happens if I don't have either of those? If you don't have Node or npm, or your Node version is under 12, what you want to do is just type in Node.js. The very first result is going to be the Node.js official website. You can go ahead and click the download option right here. And then you want to find the installer of your choice, whether or not you're on Windows or Mac. I'm on Mac, so I would click this one. And it's just going to download this package that will allow me to install Node.js, specifically version 14.16. You'll see if I were to go through this whole thing, I would install that version directly. I already have it installed, so I'm not going to go through. But if you don't have it installed, make sure you are installing it with the Windows or Mac installer. And once you get through all of those prompts, you should have Node.js installed in your system, the correct version, because this is version 14.16 as of this date. And also, whenever you install Node.js, you also by default install npm. So npm should work for you by default as soon as you install Node.js as well. So once you have Node installed, let's also install Vite, because we now have npm as well. So to run this command, we're going to need to open up a terminal window. Well, how do we open up terminal on Mac? We're just going to click this little magnifying glass right here, spotlight search, and type in terminal. And you're going to see we get the terminal result. We're going to click it, and it's going to open up a new window. This is the project currently running in the background, so I could show you guys, but for you guys, it should open up a new window, and yours is going to look white. Mine only looks black because I have a little bit of customization put in here. It's going to start you off directly on the home directory right here, which is a little squiggly. But before I continue, for you Windows users out there, you're not going to be opening up terminal. You're going to be opening up something called PowerShell. It's basically the Windows equivalent to what we have right here, and it's pretty easy to navigate for the most part. Maybe not as nice in my opinion, but it'll still get you going where you need to go, and you should be able to input these commands as well. So we're starting off at our home directory, which is notified by the squiggly. And if I ls, which means to list the contents of this directory, you'll notice our home directory is 1-to-1 with our home directory over here in the Finder. If I start scrolling down to the visible folders, you'll see all of these match up with what we have in the terminal, which is pretty cool. So we want to make sure in the terminal that we're going inside of the current project we're working on. So let's do this the easy way by finding it in Finder first. We're going to scroll down to 3, and inside of here is our My Portfolio project. So if I want to go to this directory directly within my terminal, what I can do is type in cd, which stands for change directory, and I want to change directory into My Portfolio. So I'm just going to grab this directly from Finder, drop it into the terminal, and it's going to give me the exact pathing I need to go to in order to dive into this within terminal. So if I cd directly into this and hit enter, you'll now see we are inside of My Portfolio. We can list out the results of this folder, and you'll see we have index.html, index.js. This is perfect. This is exactly where we want to run npm init vite.js/app. So we're going to go ahead and copy this, and remember, make sure you have a Node version over 12 and that you have npm installed, which comes with Node, so just make sure you have Node. We're going to run this command and hit enter. So what is the name of our project? Well, it's not Vite project, it's going to be My Portfolio. It's going to give you a little prompt that we need to select. What kind of JavaScript do we want to use? Do we want to use any template associated with this Vite project? Well, for our purposes, we want to focus on just Three.Js. We don't need any of this other stuff right now, so we're going to select vanilla, which is just basic JavaScript, and that's all we need to do. So if I go back to Finder, we're going to see what that command just did. We don't see anything here just yet, but if I click My Portfolio, well, we just scaffolded a whole new directory called My Portfolio. And inside of here are going to be a few files that Vite just created for us so we can set up that front-end web server. So we have two instances of My Portfolio, but really we want to use the one that we just created. So what I'm going to do is our initial My Portfolio, I'm going to call it -old. I'm going to drag the new Vite My Portfolio into our root 3 directory, and then I want to make sure that I am cding inside of that Vite My Portfolio. So here in terminal, I can type in cd, just drag my folder on over here, hit enter, and now I'm just going to follow the commands that we see right here outputted by Vite, specifically these bottom two, npm install and npm run dev. So if I copy these and paste, hit enter, we're going to see a few commands taking place. npm install, what does that do? Well, if we go ahead and open up my portfolio in Sublime Text, which you might need to do again since this is a new Vite project, if I look inside of package.json, npm install is going to install all the dependencies listed out within this file and their specific versions. So npm install just installed Vite version 2.1.0 because it is listed out as a dev dependency within this file. And then when I run npm run dev, well, it's telling terminal to run this command right here. So we're running a Vite command. It's basically just an alias or another word that says run this command. So all we're doing when we run npm install is installing Vite, and then we are running it when we run npm run dev, which you see right here. So when those commands run, you're going to see that we are now presented with a Vite dev server is running at localhost 3001 for my instance. For you, it's probably 3000. I just have another server running in the background. But now what we can do is if we go back to our project, you'll see here, we're just opening up the file in the browser. If I go ahead and open up a new tab and then paste in localhost 3001, which was presented to us over here, and hit enter, well, we now have a Vite app in place. And like I said, the very cool thing about Vite is if we go ahead and start editing some of the contents within our project now, such as going into main.js, you'll see that this is where we are rendering out Hello Vite in the documentation on the page. If I begin editing this to something else, edit, and hit save, watch what happens. No manual refresh required. Everything is just instant, so it's going to be very helpful for when we are working with on this Three.Js project. So let's get back to the focus of Three.Js. Get all this weird server npm stuff out of the way for the time being. If we go back to Finder and open up our old My Portfolio project in Sublime Text again, go back to index.html, you'll see that we were importing index.js, which just wasn't working for us before. But if I go ahead and copy the contents of this and paste them into our Vite app, we can get rid of everything that we see right here. And then I hit save and open up my console in the browser. You'll see that our scene is now showing as expected once more. So now we can have a separate JavaScript file that loads Three.Js without that CORS issue taking place. So now if we go back to our to-do, we can go ahead and check off install Three.Js using Vite. Perfect. So the very next thing we want to do is create a scene. We want to create a camera, and then we also want to create a renderer. These are all things that are required to get to some sort of interface on the screen. So we already have a scene in place. If you look right here with the default boilerplate code provided by Three.Js, we are creating a new 3 scene, and we are storing it inside of a scene constant. So we created one of the 3 things that we need. We have a scene, but now we also need to create a camera. So to create a camera, I'm going to create a constant called camera. And this is going to be equal to a new 3 perspective camera. And a perspective camera takes 4 arguments. The very first one is going to be the field of view, which is a value in degrees. So it's kind of like whether or not you would like your camera to be a wide angle lens, which shows a lot of the scene altogether, or whether or not you'd like it to be a telephoto lens, which only shows a small portion of the screen. So the degrees we want to put in here for our field of view is going to be 75. That should show a ample amount of screen. This is the default Three.Js usually uses. So we're just going to go with that. The second argument for perspective camera is going to be the aspect ratio of our scene. So if we look back at our initial project, you'll see that our scene takes up the entire width and the entire height of our browser window. So the aspect ratio that I want is going to be our window's inner width divided by our window's inner height, and that is going to give us the exact ratio we need so that when this camera is looking for objects on the scene, it's going to know to size them to the correct dimensions relative to our browser window, specifically its inner width and its inner height. The next 2 arguments are going to be clipping planes. What is a clipping plane? Well, a near clipping plane, which is the third argument, is going to state how close does an object need to be to the camera before it actually gets clipped out of the scene altogether. Clipped out of the scene just means it doesn't show on the scene. This is all going to make a lot more sense as we go through it. These 2 aren't that important to explain right now. So for the near clipping plane, we're going to be putting 0.1, and for the far clipping plane, we're going to be putting 1000, so we can see all the objects from a distance of 0.1 from the camera, very close, all the way down to 1000 units out there in our scene in 3 dimensions. Anything past 1000, we're not going to be able to see. So we have our camera, but what do we need next? Well, now we need a render, something to combine the scene and camera together to put something in 3 dimensions on the screen. So to create a render, we're going to create a new constant called render, and this is going to be equal to a new 3.webgl renderer object. And now, just to make sure that these are all instantiated correctly, what we can do is we can console log each one out individually. So we already have our scene. We'll go ahead and console log out our camera as well. We'll console log out our renderer too, and we don't even have to refresh because Vite does it for us automatically, and you'll see each of these was created successfully because we see their individual objects being outputted in the console. If you're not seeing this over here in the console right now, just double check your code and syntax to make sure you have 4 arguments within a perspective camera object and that you are typing out WebGL render correctly over here when you create the renderer. So we have these 3 objects, but we're not seeing anything on the screen just yet because all we're doing is storing these within constants. We actually need to make use of them now. So our renderer is basically a canvas HTML element that runs WebGL, which is basically the framework that's required to run 3D on the web. So what we need to do is we need to put this canvas object directly within our HTML, and to do that we're going to be using JavaScript. We're going to be injecting it into our HTML. So to inject it into our HTML, we can select our document object, specifically our body, which if we look in our elements tab over here, we're going to be injecting it directly within this body tag. We want to append a child element. What child element do we want to append? Well, our renders DOM element. And just by doing that, you'll see over here we now have a black box, and this is what's going to be representing our scene where we can edit 3D objects. If I go ahead and inspect this, you'll see we just appended in a canvas object, and this canvas object is what's going to be running WebGL, which allows us to run 3D stuff in the browser. So cool. Now, one issue we have here is obviously this canvas element isn't the full width and height of the browser. So what we can do is, before we append our renderer's DOM element, we can go ahead and select a renderer and use a set size function to say what size should our renderer element actually be before we append it onto the browser. Well, the first argument here is going to be the width we want this element to be. So what width do we want? We want the Windows inner width. And if you're wondering where this variable is coming from, well, this is the exact same thing as window.innerWidth. The thing is, whenever you're referencing the window object within your code, you don't actually need the window object. If you reference a property directly from the window object, it's going to know what you're talking about automatically. So therefore, we can use inner width and inner height by themselves. It just makes our code a little cleaner. So our width is going to be equal to the inner width of our browser, and then our height is going to be equal to the inner height of our browser, the full width and height. So now if I save, you'll see now it's taking up pretty much the full width and height, but we still have some padding up here. Where's this padding coming from? If I go ahead and inspect our page and look at our body element, you're going to notice by default it has a margin of 8 pixels. Every website you create, the browser is automatically going to be adding on 8 pixels to the margin of your body element if you don't specify otherwise. So we don't want this margin there at all. What we can do is go to index.html, and within our head tags, we're going to be creating a style tag, and this is where we can add some CSS to take away this default margin. So what I can do is I can select our body element by typing in body, and then what CSS do I want to alter? Well, simply its margin. And instead of 8 pixels, I want this to be equal to 0. We don't want any margin at all. So if I save this, we get an auto refresh and that margin goes away. And now I can't really scroll to the left or right. There are no scroll bars in place, which means that our Three.Js canvas is indeed taking up the full width and height of the browser. So that will take care of that. So if we go back to our to-do list, we created a scene, we created a camera and a render. And now we actually put our renderer on the screen, and this is going to be acting as a canvas in which we inject 3D objects onto this, and we can interact with them in a 3D space. So technically we can go ahead and check off create a scene, camera, and render from our to-do list, but now we need to actually get some sort of geometry, some sort of mesh within this screen so we can start interacting with it. So the very next step we're going to do is create a plane. But to make this as easy on you guys as possible, I'm going to start with the most basic object, which is actually going to be a box. So whenever you want to put some sort of element within your Three.Js scene, you're going to need two things. One is going to be you need a geometry. A geometry is basically the wireframe of your object. It contains data relating to all of that object's vertices, which actually start piecing together the object, such as a box. So we'll have a vertex here, 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 has data related to all those vertices that connects them into a box shape. The second thing we need is a material. The material is what goes on top of this geometry to actually fill in everything in between. Vertices are just points that really create some sort of wireframe, but to fill in that wireframe, we need some sort of material in place, which is basically just painting up the faces of the box. So if you have a geometry and you have a material, together you can create a mesh, which you can then put into your Three.Js scene and it'll render correctly, which you'll see very shortly. So to create a box geometry, what we're going to do is we're going to create a new constant. We're just going to call this box geometry. Makes sense. This is going to be equal to a new 3.boxGeometry, and make sure your casing is correct over here. So this takes 3 arguments specifically for the box geometry. Three.js has a lot of different geometries that you can go ahead and use within your project. Box geometry is just the most simple one to start with. If you'd like the full list of which ones you can use, you can simply head over to the Three.js docs, and there it'll give you a comprehensive list of all the geometries you can actually use. But let's focus on box geometry. What arguments does a box geometry take? Well, it takes a width, it takes a length, and then it takes a height. So the 3 things we actually need to build a box in 3D space. So the width of our box we're going to declare as 1 unit. You can kind of think of this as feet. I'm not sure what the exact units are actually within Three.js, but we'll go ahead and say that this is going to be 1 foot for the width, 1 foot for the length, and then we're going to use 1 foot for the height. So if I save this and then console log this out just to make sure that we instantiated this correctly, go over to our console, you're going to see now we have a box geometry object. And if I look inside of this, specifically within this attributes property, well, inside of here is going to be all the data related to our vertices, everything that is actually required to get this on our screen. Why are we still not seeing anything even with all this data related to a box and its vertices? Well, simply because we don't see anything until we create a mesh, which remember requires a geometry object and also requires a material object. So that's going to be the second thing we create, is a material object. So we'll go ahead and say const material is equal to a new 3.mesh basic material. And this takes an argument of an object, and inside of this object we can specify a color, and this color is in hexadecimal value. So if I want to go ahead and create a color of green to start, that's pretty basic. What I'll do is I'll type a 0x to declare we want a hexadecimal value in here, and then I can write out that exact hexadecimal. So 00 means our red value is going to be 0 out of 255 if you're used to using RGB values. The second 2 numbers here are going to declare how green should this object be. If I want these to be as green as possible, well, we don't want to use 0. We want to go all the way up the hexadecimal scale from 0 to 9 to A to F, which is going to be the brightest version of that color. So our green value here is set to the brightest color it can be. And then our blue value, which is the last 2 numbers, is going to be nothing at all. And if you don't want any value there for that kind of color, you just add in 0, 0. So we save. It's going to refresh for us automatically. But now we want to console log out our material, and it looks like our material was created successfully. So now that we have a geometry, we also have a material. We can use the 2 in tandem together to create a mesh. So I'll create a constant called mesh, and this is going to be equal to a new 3 mesh. And what arguments does a 3 mesh take? Well, simply a geometry and then a material. So we want to make sure we're using box geometry here. Our material is already called material, and if we console log out mesh, now we have a mesh successfully created. So looking in good shape, but how do we finally get this mesh into our render? Well, we want to take our scene object and then call its add function. This is what's going to add meshes into our scene. What mesh do we want to add? Well, the box mesh that we just created. Now, still not seeing anything even when adding the mesh to our scene. And that is simply because although we put our render within our HTML over in the browser, we're not actually calling any render function, which is going to render out our scene. And to actually render out all the objects on our scene, well, we need to call our renderer and call its render function, which takes two things. It's going to be the scene we want to render out, and then the camera we want to use to be able to actually navigate and move around in our scene. You'll notice we didn't actually use camera anywhere just yet. This is where it's going to come in handy to actually display what we want to show directly within the scene. So if we go ahead and select our camera constant, copy it, and then paste it into this render function down here, it's being called off of our render, and hit save. So I'm not seeing anything. I know it's probably getting frustrating at this point, but it's there now, I promise. How do we actually see the box that we just created? Well, we want to select our camera, and we want to select its position property, specifically where it is on the z-axis, so going forward or backwards. And we want to make sure that it's not located in the center, because everything by default is going to be spawned in the center unless you specify otherwise. So we're basically going to be moving our camera from the center of the screen, where a box is also spawned. We're going to be moving it backwards so we can actually see what's right in front of it. So if we set it equal to 5 feet, 5 units within Three.Js, and hit save, finally going to see our box, although it kind of just looks like a square at the moment. To start seeing this in 3D, what I want to do is add in some animation. So to create animation, we're going to be doing exactly what we do within our Canvas games if you've ever watched any of those tutorials. We're going to be creating a function called animate, and inside of here we're going to be calling Windows request animation frame function, which in return calls another function. So what we're doing here is, if we were to call animate, it's going to run request animation frame, which in return calls an animate function, which is declared right here, which just means it's going to run the code again. And it's basically just going to put us into this loop specifically so we can start animating values as we need to as we begin coding our project. But in order to activate this animate function, at the very bottom, we need to actually call it so it begins the loop. So if I call animate, not going to see anything just yet, but if we go ahead and put render inside of this animate loop, so we're calling render over and over and over again, and select our mesh, specifically its rotation, start with the x-axis, and start adding on 1 over time as animate begins to call itself. We hit save. You're going to see that it's spinning very, very quickly along the x-axis, so it's probably spinning, I believe, forwards at the moment. Let's go ahead and slow this down. Instead of increasing by 1, we're going to increase by 0.01. And you'll see that spins a lot more smoothly. Let's go ahead and add on some rotation to our y-axis as well. And now you'll see the full 3D object in here as a cube as it begins to spin. So right off the bat, when we're looking at this, you'll know it's a little jagged on the edges. If it's looking jagged for you guys as well, it's probably due to the device monitor you're using. So right now, I'm on a MacBook Pro, which has a Retina display, and when I try rendering out this WebGL by default, it creates a little bit of jaggedness along with the actual rendering. To fix this, where we have our renderer created, and where we are setting its size, right after we set the size, what we can do is select our renderer and call set pixel ratio. And this is going to be equal to our window object, which we don't need to actually specify. It's going to be equal to our device's pixel ratio, device pixel ratio. So if I go ahead and save this, it's going to refresh automatically, and you're going to see the jaggedness is reduced significantly because we're telling Three.Js what the ratio of pixels are on our device from width and height, and it's going to make sure that it renders things clearly just because it knows that additional data. So we have a simple box on the screen, but if we go back to our piece over here, we don't want a box, we actually need a plane, just a nice flat square or rectangle. So how do we go about putting a plane within our project rather than just this simple box? Well, let's go ahead and focus over here. The first thing I'm going to do is start deleting out our console logs so we can go ahead and focus on the code at hand. So I'll delete these ones, and these ones, since everything is working, we know that. And we don't really need those additional consoles right now. So a new mesh, even if it's a plain mesh, requires two things. Well, it's going to be a geometry and a material. But this is just going to be a different kind of geometry. So you might be thinking, can't we just copy line 18? And instead of box geometry, can't we call this just plain geometry? And then set it equal to a plain geometry object. Well, yes, technically this is how we are going to be doing things, but what we don't know here is what arguments does a plain geometry object take. So if you don't know what arguments a certain geometry or material takes, the best thing to do is go to the docs. So I'm going to show you guys how to use the docs within Three.Js to create this plain piece for when you're creating new objects yourself. So what you want to do is open up a new window, and you're just going to type in Three.Js docs. And go ahead and full screen this. We're going to click the very first result. This is on Three.Js.org, and then we can go ahead and start scrolling down on the left hand side to see what is actually available to us. So when you're looking for what geometry you want to use, what kind of shape do you want to create, you want to scroll down to the geometry section. You'll see right here we have an option for box geometry, which we just used. We just created a box, but we used a more simple material than what you're seeing right here. You'll see this code looks exactly the same to what we just put in, or at least close to the same. But we want to use a plane geometry. So we'll go ahead and scroll down. We see plane geometry is here underneath the geometry section. We'll click it, scroll down. This is what a plane looks like. This is indeed what we want to create that background effect. And now we can look at the code example to see how this is made. So it looks like it takes 3 arguments. Well, what do these 3 arguments actually mean? If we go down to the constructor, we can see what they mean exactly. The first argument right here is the width. This is equal to a float data type. A float data type is just a decimal number, basically. What is the second argument it takes? Well, it takes a height, also a float, a decimal, and then it takes width segments and height segments. So how many segments should be put in between the full width and height of the plane? You'll see right here, it looks like we have 2. So let's go ahead and create our own plane geometry using this plane geometry constructor example. So we know that we need to put in a width. Let's go ahead and start with a width of 5 units. We'll also start with a height of 5 units as well. So we have a perfect square here. Width segments, it doesn't really matter what we put here since we're not using any segments just yet. We'll go ahead and start with 10. And we'll also specify our height segments, which is an integer, so a whole number should also be 10. We have our plane geometry. We can go ahead and console log it out to make sure that it was created successfully. Go back to our project, refresh, and it looks like indeed it was created successfully. So now we need some sort of material in place. We can just go ahead and use the same material that we created for our box geometry, but we're actually going to assign it a different color just so things don't blend together as we begin to test this. So I put this beneath plane geometry. I'm going to call this plane material. And then I'm going to specify our color for this should be red instead of green. So I'll get rid of the brightness values on the green value over here. Put those to 0, 0. The first 2 numbers here are going to be the brightness values for red. If I turn those up to F, which is the brightest value, we're going to have a red plane material. And whenever we have a geometry and material ready to go, well, we can go ahead and call this new 3 mesh code. So we want to create a new 3 mesh that uses our plane geometry, and that also uses our plane material. And we want to set this equal to our plane mesh. And whenever you have a mesh ready to go, all you need to do is add it to the scene with scene add plane mesh. And now you'll see our plane mesh was added to the scene successfully. And if you actually want to see this move in 3D, what you can do is you can select your mesh within your animate loop, so plane mesh, and start adding on to one of its values, such as rotation.x, add on 0.01. And you'll see now our plane is flipping, albeit very fast. That's a little better. Both of these spawned right in the center, so you can kind of get an idea of where these are located and what they look like as things begin to flip. Now, you'll notice as our plane begins to rotate, well, the other side of it just isn't visible at all. And this is by intention by the Three.Js authors. They want to make sure your scene is as performant as possible. So when you get to the other side of a plane, it's just not visible by default, but we can make sure that it is by declaring a property within our plane material. So we declared its color, but we can also declare a side property and set it equal to a 3 dot double side. Both D and S should be uppercase here. And if we do this, you'll see both sides of the plane are now visible. This is probably what we want to stick with while we develop, just so we don't get confused as we begin to move around our scene, whether we go under the plane or over the plane. We want to make sure that we can see both things here. So we have our plane in place. This box geometry isn't really serving a purpose anymore, and now that we kind of got our hands wet with geometry and materials, so what I'm going to do is I'm going to remove it from the scene altogether. We can just go ahead and delete the box geometry, the material, the mesh, and then the scene.add where we actually add the box mesh. And then we also want to make sure that we are deleting the mesh rotation down here, which is forcing it to turn and twist in those directions. So if I remove all of those, now we just have our plane We don't want our plane continuously rotating like we see right now, so I'm just going to go ahead and comment out this code. And now we basically just have a square that doesn't really have any dimension associated with it. So one thing we can do here is we can begin giving this a new type of material, one that actually interacts with light, so that when we begin moving the segments of our square in different directions, we're going to be able to see all the little segments associated with our plane. Right now they're all flat, we can't see anything, especially because we're using the mesh basic material object, which doesn't react to light. So if I want this to be able to react to light, I'm going to use a new type of material. Specifically, I'm going to use a mesh Phong material. And this can take the same arguments that we have within our mesh basic material. If I save this, we're just getting pitch black compared to the red we saw before. This is because in order to view this material, mesh Phong material, we need to make sure that we have a light on the scene, something to actually illuminate it. So the next thing we need to add to our project, our scene, is going to be a light. Let's go ahead and do that now. If I create a constant called light and set it equal to a new 3 directional light. This is going to take 2 arguments. 1, the color of the light, and 2, the intensity of the light. So for the color of our light, we can specify a hexadecimal value, which remember we do by declaring a 0x. Going to make sure it's in that hexadecimal format. And then what is the actual color and hexadecimal value? Well, I just want this light to be a pure white. So I'm going to make sure that we add in 6 Fs to declare RGB. Should all be as bright as possible, which when combined creates a white color. The second argument here is going to be the intensity of this light. I want it to be as bright as possible, or at least as bright as Three.Js allows, so I'm going to be setting it to 1 and not seeing anything yet, because remember, whenever we create a 3 object, we need to make sure that we position it correctly and that we actually add it to our scene so that it's rendered with everything else. So to position this, I'm going to select our light constant, select its position, and then I'm going to call a quick set function. So what does this set function take? Well, it takes 3 arguments, x, y, and z. Where do we want to put this relative to the center of where it is placed right now, the center of our scene? So I don't want to move it left or right, so I'm going to select 0 for the x. I don't want to move it up or down, at least not yet, so I'm going to put 0 for that as well. But I do know I want to move it towards me, because if I look right in front of me, that is where the plane is actually placed by default. So if I move that light back from our plane, basically putting the light right in front of it by putting its z value to 1, and then I add the light to our scene, you're going to see we have our light shining directly on our plane. This looks a little different than our mesh material. You'll see right here, we have a little bit of different color taking place here compared to everything just being the same value of red. It's a little lighter in the middle than it is on the edges of our plane, which is perfect for when we need to start editing the vertices to create that jagged-like effect we see over here within the example. So in order to add the jaggedness, we're going to want to be dealing with our plane mesh object. So what I'm going to do here is I'm going to console log out our plane mesh and see what's inside of it. If I console log this out, I can open up our mesh object and start looking around at all the properties that a mesh actually consists of. We're going to want to focus on our geometry object, which is actually the plane geometry that we created earlier. But this is what we're going to be editing to make sure that we get that mountain-like jagged effect. Inside of our attributes property within the geometry property, we're going to have another property called position. And this position property contains all the data related to each of our vertices within this plane geometry, specifically within this array. So if I go ahead and open up this array, let's focus on the first 3 values with an index of 0, 1, and 2. So these guys right here. These 3 values, when used together, represent one vertice within our plane. So if I look at the value negative 2.5, that is going to be the value for this vertice's x position. So where is this vertice of the plane on the x-axis from left to right? Well, negative 2.5 is probably going to be somewhere along the left-hand edge of the actual plane. The second value right here, 2.5, is going to be the y-coordinate of the vertice. So where is 2.5? Well, it's going to be somewhere up here along the top of our plane. And finally, this last one of the trio is going to represent the z value of this vertex, which is going to be 0 because our plane doesn't actually have any depth. If we look at the third value, for every single index in here, it's always going to be 0 simply because a plane has no depth. It's saying that the vertex's position on the z-axis should be equal to 0 within our scene space. So our vertices are stored in this group of 3 format specifically because it is better for performance when running them within the browser. It does make things a little harder to edit since we want to make sure we're editing these values to alter our vertices, move them around a bit, but to preserve performance, this is better than putting these in their own individual properties such as an X position, a Y position, and a Z position. It just wouldn't be as efficient otherwise. So basically what we need to do here is to create some sort of jagged effect, we need to start editing each individual vertice's positions within this array. So the very first thing we're going to do is we're going to select this specific array. So we're console logging out our plane mesh, starting right here. If we start diving into this, we want to get our geometry, so .geometry, and then we want to get the attributes. So we'll go ahead and select attributes like so. We'll go ahead and go in a little deeper. We want to select our position, the position of each individual vertice within this plane, and then we want to go into our array, which has all the values where our vertices are located. So .array. If I save this, we get that array specifically. And now we can begin editing the values inside of it to affect our piece over here. So to edit these values in groups of 3, I'm going to use a for loop. I'm going to declare a let called I, set it equal to 0, and then I'm going to specify how many times do I want to loop through this. Well, I want to loop through this for as many items we have within this array over here, which is 363. So if I go ahead and replace array length with our array and then call length on top of that array, we're basically saying we want to go through this for loop 363 times. Now, just looking at our for loop right now, this is kind of messy just because this value right here is so long. It makes our for loop a little hard to read. So something that we can do is we can take this, cut it out of there, cut it out of our for loop, and we're going to create a constant, and we're going to use 2 curly brackets, one opening, one closing, and put inside of here array. And what we're going to do is set it equal to that value that we just cut, paste it out right here, and we are going to delete the last portion of this .array.length. So this is called object destructuring. What we're doing is we are still selecting the position attribute of our geometry object, but we are creating a new constant called array that references that position attribute's array directly. So this right here is essentially getting transferred to this small constant over here, and by doing that, we can use the small constant within our for loop and reference its length like so. So we're still getting the length of our position array, we're just doing it in a cleaner manner within our for loop by using a little bit of object destructuring. So this should still loop 363 times. If I go ahead and console log out I, you'll see that we are still going through this 363 times. We're just not seeing 363 because this counts as 0 as 1. But this is working exactly like we would like it to. So if we start console logging out our array values, which we are going to access using this iLet we declared up here, we can select our array and say we want to console log out each value within it by placing I inside of here. You'll see all those are outputted into the console. So these first 3 values are related to one vertice. Let's say we only want to loop through the vertices, each little individual vertice related to our plane, rather than each of the values associated with that vertice, such as X, Y, Z. We don't want to loop through all of that, but just each individual vertice, so these 3 together. What we can do is instead of adding 1 onto I, we can add on 3 instead. So now we're only looping through every 3 values compared to every value within this array. And to make this a little easier to understand, we can start setting these values equal to their X, Y, Z counterparts using constants. So I'm going to create a constant called X, and that's going to be the very first value within our array. Very first value within our array is going to be equal to 0, which is what I is equal to. So X technically should be equal to negative 2.5. Then I'm going to create a constant called Y. This is going to be equal to the second value within the array. So when I is equal to 0, we know we get the first value, but if we add 1 onto I, well, we're going to get the second value, which is going to be equal to 2.5. And then finally, we have our Z, which is going to be the third value within the array. That is going to be equal to 0. And once we run through this first iteration, well, we're going to be adding 3 onto I. So if I, let's just say hypothetically, is equal to 3, well now if we put 3 inside of here, we're going to be selecting the 4th option within our array, which is going to be negative 0.2. We add 1 onto 3, that is going to be 4, so we're getting 2.5. And then finally, if we add 2 onto 3, well, that is going to be index number 5. So if we count 0, 1, 2, 3, 4, 5, we're going to get 0 for that. So this combination of x, y, z right here is going to be equal to the x, y, z position of each individual vertice. So using these x, y, z positions, what we can do is we can start altering these positions to start randomizing the geometry of our plane. So if I want to begin editing the x position of each of these individual vertices, what I want to do is I want to select our actual x position, which is going to be referenced from this array with a value of I, not x exactly, because this is going to be a new value that doesn't actually alter the original. We want to make sure that we are setting array I equal to array I or x. Here we're going to be using x because it makes a little more sense logic-wise. And we want to add on some sort of value. So let's say we want to move all the x vertices to the right by something like 3 units. You're going to see pretty much everything was moved to the right except for the very first vertice over here. Now, why wasn't that vertice moved? Well, simply because while I was explaining this, we changed I to 3, which means when we're editing the vertices in this loop, we're skipping over the indices 0, 1, 2, which is going to be that very first vertex. We want to make sure that we set I to 0, so we make sure we select it, and now everything was translated to the right. If we want to make sure that we're translating it to the left, we can just go ahead and subtract 3. Now everything on the x is moved by 3. But we want each individual vertice to have some sort of randomness associated with it, especially on the z-axis, because on the z-axis, that's what's going to make things really bulge out within the shape that we have right here. So let's go ahead and start with z. To go ahead and set the z position of one of our vertices, we're going to go ahead and add 2 onto I right here, because that is going to give us the third data value within our array. And we don't want to use the current x position, we want to use the current z position and start altering its value. So if we go ahead and add 3 onto z, it's just going to look a little bigger because we're moving it closer towards us. But what if we add a randomized value here? Instead of 3, what if I go ahead and add on math.random? Any value 0 to 1. Well, things are starting to look pretty crazy here once we save that, but we can't really see any of the depth of the inner vertices. You'll see that it's just still all flat. Well, why is that? By default, that is just the way a mesh Phong material interacts with light. So if we want to see all the little individual faces within this plane using a mesh Phong material, what we can do is we can add on a flat shading property and set it equal to a 3. Make sure that's all uppercase, flat shading property. And if I save this, you'll see that our plane is basically magically transformed into this nice geometrical object. So going back to our loop, if I comment this out, you're going to see we still get a flat plane, but when we start altering all the z coordinates, and we have this flat shading turned on, we can see all the depth associated with those z position translations. So now when we go back to our to-do list, we can successfully check off creating a plane. This is great for the basics. Obviously we're not completely there just yet, but we're moving in the right direction. So the next thing I want to do is be able to modify this plane to the exact dimensions that we would like until we get something that we're happy with. Now, in our code, we could do this simply by changing the dimensions within our plane geometry instantiation. So here, we can go ahead and change the width to something like 10, the height to something like 10, save, and refresh, and you're going to see it is quite bigger. And we can keep toying with these values until we get something that we like. The only issue with this is it's kind of slow. We're going to have to keep going back and forth, changing values over and over again, and it's just not as efficient as it could be if we were to use something called dat.gui. So if we look at the example, this little control panel right here is known as dat.gui. It's a graphical user interface to change different things within your screen. Here I've set it up to manage a few properties: the width of our plane, the length of our plane, how many segments are within this plane, both on the width and height section, and then I believe this controls the hover color. Yes, it looks like it does. I can turn this down, it changes to a different color when we hover over it. So you'll see dat.gui makes this really easy to edit and get to the exact dimensions that we would like to use within our actual piece, rather than having to play around with all these different values by hand within our code. So how do we begin using dat.gui within main.js? Well, one way to do it is you could go inside index.html and pull it in through a CDN link within a script tag's source attribute. But if we want to do things a little more professionally, we'll actually install dat.gui through npm, similar to what we did with Vite. So to install dat.gui into our project using npm, we can open up our terminal again. I'm going to open up a new terminal tab, and you'll see inside of here I'm already within our project directory. You'll see this is indeed our Vite My Portfolio project, and here is where I want to run npm install, and then the package name we want to install, which is going to be dat.gui, GUI. And then I want to put -- save at the end of that, and when I put the -- save at the end and hit enter, you're going to notice inside of package.json, dat.gui is now listed out as a dependency. So we can say our project depends on this one library to work. Technically, this could be listed as a dev dependency because it's something that will probably only show in development anyways. But for this instance, it doesn't really matter where you put it, whether it be dev dependency or dependency. We just want to make sure that it's in our project and downloaded. So after installing dat.gui, now you can use it within your project. So if I go over to main.js, I can scroll to the very top of this, and similar to what we did with Three.Js, installing that into our project so we can use it, we are going to import the whole library of dat.gui as dat from, and then what is the package name? Well, if we look within package.json, the package name is dat.gui. So we can copy this, go back to main.js, and say we want to import dat from dat.gui. We can test this by console logging out, dat, going back to our Vite app, and if I refresh, you're going to see we have a module here. If I open it, well, it looks like we have some GUI functions and methods inside of here, so we successfully imported dat.gui using npm, so we're on the right path here. So to start using dat.gui, we need to start adding in little individual property sections to start altering everything within our app. So the very first thing I'm going to do is I'm going to create a GUI object. I'm basically going to instantiate dat.gui. So I'm going to say a const of GUI is equal to a new dat.gui all uppercase object. And we want to make sure that this is working as well. So what I'm going to do is I'm just going to console log this out. Always make sure your code works as you go about it. And here you'll see we now have a GUI object. So now that we have a GUI object, what we can do is we can call GUI.add. And the first argument here is going to be another object. And this object is going to contain all of the properties we actually want to start editing within our actual Three.js piece. So in order to put an object here, we need to create one. Right below this constant GUI, I'm going to create a new object called world. This is going to be equal to an empty object to start, but we need to think, what kind of properties do we want to start editing within our world? Well, we want data related to our plane. So let's go ahead and add a plane object in here. Set it equal to an empty one to start as well. Now let's think, what kind of properties does our plane have? Well, if we look back to our plane instantiation, we know our plane has a width, it has a height, it has a width segment, and it has a height segment attribute associated with it. So let's start off with just the width of our plane. We know our plane has a width, and to start, we're declaring it equal to 10. So our default value for width is going to be equal to 10. And now that we have this object available to us, we can insert it within our GUI.add function. So the first argument here is going to be an object. We want to select our world, and specifically our plane object. Now, what property within this plane object do we want to have a slider associated with? Well, that is going to be our width property. This is going to be equal to a string width. So now, just by saving with this, you'll see that we have a number selector up here that we can start changing the value of. But let's say we want this to be an actual slider, not just a number value. Well, the third argument is going to be the minimum value you want the slider to be able to go to. So what is the minimum width our plane should have? Probably no less than 1. And what is the maximum value our width should have? This is going to be the fourth argument that GUI.add takes. We don't really know just yet how large we can go. Let's go ahead and just say 500 is going to be the max of our slider. And now you'll see our width by default is 10. Up here, when we refresh, it's equal to 10 by default. And we can start altering this value with a slider because we inserted this 1 and this 500 as the third and fourth arguments within GUI.add. So as I begin changing this, the value changes for our world plane width. So this value is changing, but now we need to actually integrate it within our code so that when this changes, we are basically recreating our geometry with this new value. So our plane geometry is only instantiated, only called once, and that is on load because it's not inside any event listener or any function that would actually call it. So what we can do is we could say whenever we change the value of width within our world.plane, we want to regenerate this geometry. So at the very end of GUI.add, I'm going to change on a function called onChange. And this is going to have one argument. It's going to be an arrow function, a callback function, so that whenever this value changes, we're going to be calling this function. We can see this in action by consoling out our world plane width. And now whenever we change the width up here, we should be able to see it be changed within the console. So if I begin to change things, you'll see that that value is indeed changed as I begin to move the slider up and down. So we know we're creating a plane mesh, but when we change the value of our GUI slider, we want to select this plane mesh, and specifically we want to select its geometry. So let's go ahead and console log this out to make sure that we are getting this correctly. Put it inside of console log. We get rid of the second console log. We don't need that anymore. Save. It's going to refresh. We begin altering our slider, and you're going to see we are indeed selecting our plane geometry. But what we want to do is we want to set this plane mesh geometry equal to something new that takes into account the new width of the world plane that we have going on with our GUI slider. So the very first thing we want to do is we want to select our plane mesh geometry, which we're already doing, and we want to dispose of it. This is just going to get rid of it from the scene altogether, get rid of it from the mesh. And then the second thing we want to do is assign it a new geometry. So what geometry do we want to assign it? Well, we can go ahead and grab our plane geometry instantiation right here, paste it into our onChange callback, and we're going to say plane mesh.geometry is equal to this new 3 plane geometry. But we don't want to set our plane geometry equal to a static value with a width of 10. We want to make sure that we're setting this equal to the value we are getting from world plane width. So instead we can put in here world plane width. We save and then we begin to edit our value, and you'll see our plane begins to change as we edit its width. Now as I go bigger and bigger, it just goes off the screen completely. Not something we really want. It kind of makes all the values above, it looks like 20, a little useless. So what I'm going to do is I'm going to change our slider max to 20. And now this gives us a little more breathing room to get different values with the slider directly. Looking pretty good, but you'll notice as I decrease and increase the width, it did away with all of our vertice manipulation that we just worked so hard to get. And it only comes back on refresh. So although we're creating a new plane mesh geometry with a new width, something we are not doing with this new geometry is setting the new positioning of all the individual vertices. We need to make sure we do this again whenever we assign a new geometry to our plane mesh. So where are we altering all of our vertices? If we scroll down, it's going to be this for loop right here. So we can go ahead and copy this, go to our onChange function and just paste it in there. And let's watch what happens now when we change our slider value. You'll see it gets smaller and smaller, but all the vertices are still being edited in real time as we begin to change. And all we're really doing here is setting the Z position of each vertice to be something random each time this width value actually changes. So looking pretty cool, and this is giving us the ability to get the exact value we might want within our plane object. But we might not want to tailor just the width, we might also want to tailor the height as well. So a quick challenge, I want to challenge you guys to add the height property to this dat.gui instance. Pause the video, do so now. Otherwise, let's keep going. So to change the height with dat.gui, pretty simple thing we can do here is we can just go ahead and copy gui.add, create a second instance of it. So we know we want to change a property related to our plane object. Well, we don't want to alter a width property, we want to alter a height property. This is also going to be equal to 10 by default because that's what we have it to at the moment. And now we can change width to height. We can keep our height value equal to 1 to 20. That seems reasonable. We're going to dispose of our geometry and set it equal to our dat.gui width, but also our world plane height. That's pretty much all we need to do to affect the height of our plane. Let's watch what happens. If I begin to decrease the height, well, the height of our plane gets smaller and smaller. Increase it, gets bigger. Same thing for width. Both of these are going to work in tandem, but you might have just noticed a bug. Even though my height was set to 4, as I begin to change the width, Well, the height goes back to something larger. Why is that? Well, you'll see right here, where we are changing width with our slider, we're creating a plane geometry set to the new width that we have up here, but we're still setting it equal to 10, which was the initial default value. We need to make sure we are setting it equal to the dynamic value we're setting within world plane height, so we can simply change this equal to world plane height, save, and now decrease our height, decrease our width, everything stays relative to each other, which is exactly what we want. Now looking at this code right here is quite duplicative. I don't think there's actually any difference between our onChange callback functions within height and also width. So if you have a large portion of code that's exactly the same, that's a pretty good indicator that you should probably abstract it and put it in its own function. So we're going to do exactly that. What I'm going to do is I'm just going to copy all of this code right here that generates a new geometry for our plane and sets its vertices, and I'm going to create a new function called generate plane. And inside of here, I'm going to call all of the same code. So now instead of using this empty arrow function right here, I can call generate plane whenever we change our height, and things still work exactly the same. Now we can delete all of the code with our onChange for our width, get rid of the empty arrow function, put in generate plane just like we did for our height, and now our width is edited just like our height is, and they work in tandem together because they both use the same function. The function edits the plane geometry based on the world plane width. It also edits the plane geometry based on the world plane height. So let's go ahead and finish this off for not just width and height, but also width segments and height segments for our plane, so we can get more geometry put in there in case we want it. So we know this value right here, the third argument within plane geometry, is our plane's width segment. So we'll know that we'll want to basically edit our world plane width segment. And this fourth argument right here, 10, that is going to be equal to not our width segments for our plane, but our height segments instead. Now these two properties don't exist just yet, so we're going to add them into our plane object up here. By default, we set our width segments equal to 10, and we also did the same thing for our height segments. That also is going to be equal to 10. So finally, we need a way to alter these. What we're going to do is copy GUI.add and say that we want to be able to alter our width segments property, and then we want to be able to alter our height segments property as well. Any value 1 to 20. So we save that. We now get the 2 extra sliders, and if we begin changing these, you'll notice the amount of segments begins to decrease as we begin to decrease this value. And same thing goes for height segments. If we go all the way down to 1 for both of these, we're just going to get basically a plain square with no segments inside of it. But if we go all the way up to 20 for both of these, we get something that's really, really geometrized. I don't know the right word for it. Something that has way more polygons compared to the amount that we had before. And we can definitely increase this value by a little bit. Let's go ahead and increase both the max values for these by 50. Increase these. We get something that just looks really wild, which we can always reset if we just refresh the page. So looking at our to-do list, we now know how to modify our plane with dat.gui. So we're going to check this off as well.
It's break time. Do you like this video? Don't forget to subscribe to get new videos. Share this video to open new premium videos and ebooks. We'll be a star freelancer.
Now, before we go on to hover effect, there's one more thing I want to include in here. You might have noticed within the original project, over on this side, that I can actually select a portion of the screen, and if I start dragging while I'm selecting it, you'll notice that the scene changes its orientation along with me. This is what's called orbit controls within Three.Js, and I want to show you guys how to add that to your project as well, especially as you begin to alter your scene over here using dat.gui. So one thing I'm going to include in this is add orbit controls. Let's go ahead and do that now. Adding orbit controls is actually relatively simple, but the thing is they don't come paired with the Three.Js library by default that we're already importing. This is actually something we're going to have to import separately. But thankfully, we can import it using a very similar URL compared to what we have right here with unpackage and Three.Js. So what we're going to want to do is we want to take this first portion of the URL, everything from HTTPS up to 3 at 0.126.1, we're going to copy this, and then we're going to try to visit it within the browser to make sure we are referencing the correct file. So we want to paste that in there. If we visit this right now, well, we are presented with some sort of version of Three.Js, but we want just the orbit controls because those come separately from Three.Js. To get the orbit controls from this URL that we just pasted, 3 at 0.261, at the very end of this, we're going to want to paste in or type the following URL. So if I full screen this, you'll see that this is /examples/JSM/controls/orbit controls. So basically we're going into the whole Three.Js repo that also contains examples. Within this examples folder, well, we're going into an importable module called orbit controls. If I go ahead and visit this, well, this is all of the code related to the orbit controls object. So now we know this is the correct URL to pull from. So we can go ahead and copy this. And then right below where we are importing 3, we want to import specifically the orbit controls object from that exact URL. So if we save, then console log out orbit controls like so, visit our app over here, we refresh, well, it looks like this function right here is everything we need to create orbit controls within our scene to begin moving around. And to instantiate orbit controls, all we need to do is include what camera do we want to be able to move around our scene, and then what is the DOM element of our render. So below where we created our camera and also our render, we'll go ahead and do this right here where we're currently altering our camera's position Z. We want to create a new orbit controls object, and the first argument here is going to be the camera you want to use. So it's going to be our perspective camera we are creating above, and then we want to select our render's DOM element. So we'll put that as the second argument. We save, and now when we begin to click and drag on our scene, you'll notice that it moves around in three-dimensional space. And as I begin to move this around, you'll notice even if I go to the backside, we're not seeing anything over there, even though we definitely turned on the double side rendering. Now, why isn't anything showing? It's simply because our light is only facing forward on this side of the screen. As we begin to move our camera to the other side of the mesh, you need to realize we're only moving the camera, we're not rotating the plane at all. But since we rotate the camera to the back side, there's no light over there, so we don't actually see the back side of our plane, even though technically it is right in front of us. So if you're wondering why you don't see anything on the other side, it's simply because there's no light over there. You can create a new light and push it to behind our plane, and let's go ahead and do that now, just to show you how this works. If we want to create a new light, we can simply copy these 3 lines of code. That creates a light, positions it, and adds it into our scene. This will be backlight. We're going to set our backlight's position to have a value of Z-1. And then we're going to add our backlight to the scene. So if we save this, and then start going to our backside now with that new backlight, we're going to see the backside of our plane simply because it's lit up. So if you're wondering why it's not there, you just need to make sure you add a light because of the material we're using. Only works if you have some sort of light on top of it. So now you are more than free to start editing your plane as needed while moving around your scene to ensure you get the exact look that you would like. So if we go back to our to-do, we now successfully added in orbit controls. So only a few more things to do. We need to add in our hover effect and then add in HTML. Let's get the hard one out of the way by adding in the hover effect. So when we're adding in a hover effect, it's useful to have some sort of pseudocode in place to know exactly what steps we need to take in order to get there. So I wrote a few out, and the very first thing we need to do is add some sort of mouse event listener so that whenever we move our mouse on the screen, we are tracking its coordinates. We want to use these coordinates so our scene knows where exactly is our mouse relative to the objects on it. So one piece at a time, let's go ahead and start with adding in a mouse move event listener, and then we're going to do something called normalizing mouse coordinates. So going back to our code, whenever I add in an event listener, I typically like doing it at the bottom of my code because that way I know this is where all of my events are, at least events related to the window. So to add in an event listener, I'm going to type add event listener, which takes a string for the first argument. This is going to be the event you want to listen for. I want to listen for a mouse move whenever our mouse moves across the browser window. And what happens whenever we move our mouse? Well, whatever is inside of this callback function. If I console log out something such as move, so we begin to move our mouse, you're going to see that it's logged out on the bottom left-hand corner of our console. So we're going to need to be able to grab the X and Y coordinates from this event. To get those coordinates, we can select our event object, which is always going to be passed through as the first argument within this callback function. So if I console log out event.clientX, we're going to get the X position of our mouse as it moves across the browser window. You'll see now, if I go far to the left, mouse is equal to 0. If I go far to the right, it's equal to about 640, which is what this browser width is set to. If I want the Y coordinate, all I have to do is change client X to client Y, save, refresh. Now the higher I go to the top, the closer we get to 0, and the further down I go, the larger this number gets. So we know we want to use client X and client Y outside of this mouse move function. So what I'm going to do is I'm going to create a mouse object. Mouse is going to be equal to an empty object with an X. It's going to be equal to undefined to start, an X coordinate, and then a Y coordinate, which is also going to be equal to undefined. These aren't going to be defined until we actually move our mouse across the screen. So here we can say our mouse X is equal to event.client X, wherever it is on the screen whenever we move the mouse. And then our mouse Y is going to be equal to event.client Y. Save, and then we console log out mouse and start moving. You'll see now we're getting the coordinates for both X and Y no matter where our mouse is on the screen. The closer we get to the top left hand corner, the closer we are to 0. Now the issue with this is if we want to use a raycaster, well, the raycaster uses what's known as normalized coordinates. The coordinates we're using right now are not normalized because the center of the axis is the top left hand corner of the screen, which is the default for browsers and websites, but the default for Three.Js, the center of the screen is right in the middle of the screen. So whenever our mouse is in the center over here, X and Y need to be equal to 0 so that the raycaster is actually positioned correctly to understand where our mouse is pointing relative to the plane we have on the screen. So basically we need a way so that the further we move from the center of our screen to the left, we get a value of X is equal to -1. As we begin moving to the right, we should be getting a value of 1. So we need to change our coordinate system from -1 to 1 within our mouse move function. So to start, what I'm going to do is I'm going to divide client X by our window's inner width. Let's go ahead and see what we get with that. If I begin moving further to the right hand side of the screen, it looks like this might actually work. The further and further I go to the right, you'll see X is getting closer and closer to 1, which is a good normalized coordinate from 0 to the right hand side of the screen. But as I start going to the left, as we get to the center, well, this should actually be equal to 0 for the X coordinate, not so much 0.5, and the further left I go, we need to make sure that the left-hand side is equal to -1, not something near 0. So to save you guys some headache in the math you need to do for this, what we can do here is we can put this inside of parentheses, multiply it by 2, and then subtract 1, and that is going to give us normalized coordinates for the X value. You'll see as I begin going near the center, X is equal to 0. As I begin going to the left, X is equal to -1, and the further I go to the right, X is equal to 1. So that's exactly what we need to start interacting with our mesh in 3D space. But we also need to do the same thing for client Y. So you might think we can simply take this code right here and paste it in and set mouse Y equal to it while changing client X to client Y and inner width to inner height. You might think this works. Let's go ahead and watch what happens to our Y value. As I begin to go down, you'll see that Y is getting closer to 1. And you might think, well, isn't that what's supposed to happen? Isn't it supposed to get closer to 1 as you go down? Within the coordinate system of Three.Js, the further you go down on the Y-axis, the more negative your number should be getting. So we shouldn't have a positive number for Y as we go downwards. We should actually have a negative number. Same thing for when we go upwards. Y should be equal to something positive here instead. So all I need to do here is instead of subtracting 1, we're going to add 1. And the value of client Y divided by inner height, we're going to set this equal to negative to basically reverse the direction in which our Y coordinate is being read. So if I save that and we start going down from the center of our Y axis, you're going to see our Y value is getting closer and closer to -1, which is perfect. And as we go closer towards the top, it's getting closer to 1. So now we have normalized mouse coordinates that we can use within our Three.Js scene, but we now need to use something called a raycaster. Let's look at our to-do list real quick. We added in the event listener, we normalized mouse coordinates. Let's go ahead and import that raycaster. So luckily for us, we don't have to import anything separate here like we did for orbit controls. All we have to do here is import the raycaster directly from the Three.Js library. So where we are importing our scene, camera, etc., I'm going to create a const called raycaster. This is going to be equal to a new 3 raycaster. So we can always console log this out to make sure it's working. Safe way to do things. There it is. We imported the correct object. Now let's go ahead and use this to test where our mouse is relative to the objects on the screen. But first, what is a raycaster? Whenever I think of raycaster, I always think of a little laser pointer that's always being pointed from wherever our mouse is on the screen directly into the 3D space. A raycaster is just an object that tells us where our little laser pointer dot is relative to the scene. So if I move my mouse off of our object over here, our raycaster is pointing its laser pointer over there. Therefore, it's saying our dot isn't touching anything. If I move it on top of our plane over here, well, our dot is touching the plane, so the raycaster object is going to say, red alert, our laser pointer is touching something. And it's going to be able to monitor touches for pretty much anything that we have on the scene. We only have one object right now, so this is all it's going to monitor. But if we had multiple objects, the raycaster has the ability to monitor whether or not it touches those objects as well. So within our animate function, this is where we want to check whether or not our raycaster is intersecting with our plane. So we're going to select our raycaster, and we're going to call its set from camera function. And this takes 2 arguments. One, it takes our mouse, our normalized mouse coordinates, which we already took care of within our event listener. And 2, it takes a camera as a second argument. So if we save this, you'll see we're getting an error, cannot access mouse before initialization. This is simply because we declared the mouse constant beneath the function we're using it at. So we just need to make sure that we are declaring it in a position above animate, which if we move it up there, you'll see we don't have that issue anymore. And we still get our mouse coordinates being logged as so. So now that our raycaster, our laser pointer, is being pointed from wherever our camera is pointed towards, since we use this set from camera function, what we can do is we can call raycaster.intersect object. What object do we want to test whether or not our laser pointer is touching? Well, that is going to be our plane mesh. We're going to store this in a constant called intersects. So now if I console log out intersects, you're going to see it's equal to an empty array. But as I begin to move our mouse, you'll see our coordinates are being logged. But if I begin to move over our plane, you're going to see we're logging out some sort of object within this array. And if we look a little deeper inside of here, well, it just so happens that this object is our plane mesh. So to make this a little more clear, let's go ahead and delete this console log mouse within our event listener. Refresh. Put our mouse over here, so nothing is intersected just yet, but if I begin to move over our plane, you'll see now it is tracking that we are indeed moused over it. And the cool thing is, since this is set from camera, if we begin to move our camera, well, the scene is automatically going to take that into account. If I start moving my mouse up here, where the plane would have been beforehand, we're not tracking any intersection just now, but as I begin to move my mouse onto the plane, you'll see we are indeed tracking it. If I move it off, well, it's no longer there. So that is how you're going to start tracking whether or not your mouse is over certain geometries within your scene. And to create a conditional in our code for this, what we can do is we can say if intersects.length is greater than 0, we could say that we are intersecting. We start moving, we're intersecting, we go off, we're no longer intersecting, and so forth. So this is where the code is going to go that changes the color of our plane as we begin to move our mouse over it. So looking at our to-do list, we imported our raycaster and we tested for intersects. So based off the intersected face, now all we need to do is change the surrounding vertex colors. Now, when we hover over our plane, we want to make sure that we're changing the colors of the faces that we hover over. So we have a way to test the hovering, But now we need to actually change the colors of the vertex, and it creates this nice little spotlight effect over your mouse as you begin to move across the plane. What we're really doing here is we're changing each individual vertex color, which actually spreads out and creates that nice spotlight effect, rather than changing each individual face. So how do we go about doing that? Well, let's go ahead and go back to our project, and we're going to want to focus on one of the attributes related to our plane. So back where our plane geometry is being created, we have two places in which this is being created in. One is going to be within this generate plane function, and if we look a little further, we're also by default creating a plane geometry whenever we load the page. So if we scroll a little bit further down within this load code, you'll see here we're already altering one of the attributes related to our plane mesh geometry, and that attribute is position. Well, let's go ahead and console log out our plane mesh geometry attributes and see what's available inside of there. If we go ahead and console log this out, this is going to be our plane mesh attributes, and we look inside, well, we have three attributes available to us. We have a normal, a position, and a UV. Now, normals and UVs, those are a whole nother topic. We don't need them for this video, but position is obviously where is the vertice in the 3D scene for the X, Y, and Z coordinate. Now, these are the three attributes that come with the geometry by default, but there is one that doesn't come with it by default, but actually one that we can add into this attribute object, and that attribute is going to be a color attribute. So if we want to add a new attribute into our geometry, well, the first thing we need to do is select that geometry. So we can reference our plane mesh geometry. We'll go ahead and paste it below. And then we want to call a function called setAttribute. The first argument for this function is going to be what attribute name do we want to set. Well, we already have one for normal, position, and UV. This one we want to set is going to be color. And what is an attribute within a geometry? Well, we can kind of get an idea for this by looking at the current attributes. Well, they are going to be a float32 buffer attribute, which if we actually look inside of one of these, it's basically an object full of all the data related to this array. And this array for position specifically contains all the data for the vertice positioning. They're just in groups of threes, which we went over a little earlier. So the second argument we want to put in here is what kind of attribute are we creating? Well, we're going to be creating a float32 buffer attribute. And to create a float32 buffer attribute, we want to reference a new 3 buffer attribute. And this buffer attribute takes a float32 array. So to create a float32 array, this is basically just a typed array with JavaScript. Typically you can just type an array in like this. This is an untyped array. Types are assumed. You can put different types in if you want, such as a string or a number. But with a float32 array, we actually need to create a new float32 array object. So basically inside of this, we're going to put an untyped array. And when we put an untyped array in here, well, it's going to make sure that all the numbers within this array are of the type float32. And that is just something that's required in order to get this buffer attribute working. Now, if I save this, there is another argument that we need to add to our buffer attribute instantiation. So right after float32 array, at the very first ending parentheses, we need to add a comma. And then what is this last argument? Well, it's going to be a grouping number. How many numbers within this array consist of a group? And we look inside of our array. We know that every 3 indices here represent one position, an X, a Y, and a Z. Basically this right here, this number, is the item size. It says how many of these data pieces right here consist of one grouping to represent one value. Position has an X, Y, and Z. 3 data types. So if we were to do position right here, it'd be 3. But if we think of what a color attribute consists of, it's an R, G, and a B. If you set those 3 values, then you're going to be able to set the color of whatever it is you want to affect. So since RGB is equal to 3, every 3 data pieces we have within our array is going to be one representation of one vertice color. So we can just add 3 here within our new buffer attribute creation, and we should be set to start altering our vertice colors. So into our float32 array, we're passing in 3 values. This first one is going to represent R, the redness of our actual vertex. And the values for this are anywhere from 0 to 1. It's not actually 0 to 255 like you might be used to for RGB values. So instead of using a 3, we need to make sure that we specify any value 0 to 1. Let's go ahead and make a specific vertex a different color. Let's go ahead and make it blue. If we want to make one specific vertex blue, we're going to give it a value of 0 for red, we're going to give it a value of 0 for green, and then we're also going to give it a value of 1 specifically for that blue data value. So if we save this, you might be expecting, since we're only altering one vertice right here because we only have one grouping of 3 RGB, that the very first vertice up here should have some sort of blue color associated with it, which it doesn't. The reason being, even though we have this color attribute, which our plane will read, we need to make sure that we go back to our plane material right here and declare that we want to use vertex colors. We're going to set this equal to true. And you'll see once we set that to true, well, our plane just disappears completely and we end up getting an error in the console. This is occurring because right now we're only supplying the color for one vertex. In order to actually get this working, we need to supply colors for every single vertex within our plane. So in order to ensure we are supplying a color for each vertice within our plane, we first need to know how many vertices does our plane have in the first place. Well, we can find this by looking within our plane mesh geometry attributes. If we look inside, we now have an attribute for color, which is great. You'll see we're only supplying just 3 pieces of data to our color attribute, when in reality, if we look within any of these other attributes, there should be 336 pieces of data. And when we group each piece of data within this array into 3, well, there are going to be 121 groupings of 3. We need to do the same thing for our color attribute. We need to make sure that this array right here is equal to 363, and that its count is equal to 121. Our item size is already 3, meaning that this grouping right here represents one value of RGB. We need to make sure that we extend this array. So how do we do that? Well, the first thing I'm going to do is I'm going to create a constant called colors, and this is going to be equal to an empty array. The second thing I'm going to do is I'm going to create a simple for loop, and we're going to be looping through our plane mesh geometry. We're going to select our attributes, which is everything we see right here, and then we want to dive into our position attribute. We can say we want to loop about 121 times. That's how many groupings of data we need in order for this to work successfully. So if we go ahead and console log out I within this for loop, it should go up to 121, which it does because remember 0 counts as 1, so that is working correctly. But now we need to push some colors into this array for each vertice. So if we select our colors array and then push in an R, a G, and a B, watch what happens. This is going to be affecting every single vertice because we're running it for every single vertice based off of our position attribute count. So if I save this, we're not going to see anything, but if we go ahead and console log out, our colors array should be filled up with 363 pieces of data. All of them are going to be blue because we set the R to 0, we set the G to 0, but the B value, blue, is going to be equal to 1. So how do we actually use this and set it equal to our plain colors attribute? Well, right now we're only passing through the simple 3 value array. We're going to go ahead and get rid of that, and we're going to push in our colors array, which we just populated with everything we need. We save and everything turns black. Now right now, since we just added in vertex colors, a color for every single vertice within our plane, what's happening is that color is interfering with the initial color we put within our mesh fog material. So when we're adding in vertex colors, what we can do is we can take out the initial color we assigned, and now our material is going to reflect the color we assigned with the vertice color instead. So now everything is blue. If I go ahead and change our vertices to something else, such as green by changing the values right here where we're pushing into our colors array, save, you're going to see everything is green, and then everything is going to be red initially if we set it equal to 1, 0, 0. So now that each individual vertice has a color associated with it, what we can do is when we hover over a piece of the mesh that is close to one of those vertices, we can change that one individual vertice color to be something else, and that's what's going to give us that trail effect as we move our mouse. So where are we actually tracking whether or not our mouse is hovering over the plane? It's going to be right here, where intersects length is equal to 0. So this is where we intersect, but this is also where we're going to be changing the color of each individual vertice. So here, if we look inside our intersects array, this is an array because you might be able to intersect multiple objects, we're going to want to select the very first item in the array. And of course we're going to have at least one item because we're testing that we have one item right here. And I hover over this and open this up, you're going to notice that this has a face property inside of it. This is the exact face that we're hovering over. If I zoom out a bit and hover over this very first face in the top left hand corner, and make sure I am opening up that object right here, you're going to see that face consists of 3 properties, A, B, and C, and A, B, and C are representative of a grouping of data. So for instance, let's go ahead and say our color attributes are equal to something like this, and of course we're going to have more data at the end of this. Let's go ahead and look at this. Well, if we hover over this top left hand corner and it gives us an index of 0, a grouping index of 0, well, it's going to be referring to these 3 values right here, this first grouping. If we look at C, that is going to be referring to basically the second grouping, because we're using indexes, which we always start at 0. So if we go to the second grouping, it's going to be these numbers right here. And if we were to go to 11, well, then we'd be referencing the 11th value within this iteration, which would be further down the line, something over here. So when you hover over a face, it's returning to you which group of data points make up the face that you're hovering over. One vertice here, one vertice there, and one vertice there create a face. This is the index associated with each of the groupings within your attributes array. So what we're going to want to do is we want to select this face attribute that we get whenever we hover over something, and we're going to be using the A, B, and C here. And one of the other things we want to select, let's go ahead and comment this out for now. One of the other things we want to select is going to be what we're hovering over, which is going to be the plane. We want to select the object, and specifically its geometry. If we go ahead and save this, hover over it, looks like I just spelled intersects wrong. Go ahead and make sure we spell that correctly. We hover over it. Well, now we're getting our plane geometry. And since we're accessing our plane geometry, we can get all the vertex attributes associated with it. We're going to go into our attributes object, and then we want to make sure we select our color attribute. We hover over this, and now we have our buffer attribute object, which contains all the color data related to each individual vertice. So let's say we stick with hovering over this top left-hand face over here. If we were to hover over that, we want to make sure that we're changing these 3 values within our color attribute array. So how do we do that? Well, we're going to want to select our color attribute, which we have right here, and it has a nice little function that we can add on to the end of this, such as set x. And the first argument here is what index grouping do we want to select? Well, we want to select this first index grouping right here, which is going to be 0. And then to what value do we want to set the X color of? So when we refer to X, it's going to be the very first value within this grouping. You can think of X as being R. What do we want to set the R attribute to? Well, we can go ahead and set it to 0 whenever we hover over it. And when we hover over our plane, zoom out, we're not seeing any color change in the top left-hand corner just yet. And that is because when you select your geometry attribute color, you need to make sure that it knows to update the color based off of the action that just happened. It needs to know that the data within its array changed. So what you can do is you can select that color attribute, give it a property of needs update, and set it equal to true. And once you do that, and then hover over your plane, scroll out, you're going to see that one vertex now has a color of black rather than red. We just set the R value, which right here is X, it's just a shorthand method. We just set the R value to 0 instead of 1. So if we look within our color attributes array at the very top, open this up, you'll see that we are giving the first vertice up here a value of red to start. And then when we set its X, its R, so these first 3 groupings, we set this one value equal to 0 because we're selecting the first grouping index, which is these 3 guys right here. And we want to say set X, the first value, equal to 0. We change this 1 to 0. That is what makes it black in the top left-hand corner. So instead of selecting just the very first vertice and altering that, we want to make sure that we are selecting all the vertices related to this face and altering all 3 of those instead. And thankfully, we can already get all the vertices related to the face we're hovering over by using intersect 0 face. If I console log that out, remember when we hover over this, we get each index related to the face we're hovering over. So using this, we can go ahead and copy intersect 0 face. Instead of setting our index at 0, we know the exact index we want to set by using this right here. So now if I save, refresh, and start hovering over, we're not seeing anything just yet. And if we put only face here, we're only getting the whole object of face, which is A, B, and C, all the indexes related to it. But we want just one vertice at a time, so we want to make sure we select the very first vertice of the face we're hovering over, which is going to be A. That's going to give us the grouping we need. And now, if we start hovering over this, you're going to see that, the very first vertice of whatever face we're hovering over is going to be turning black because we're setting its red attribute to 0, which is indeed what we want to create this effect. But right now it's a little janky because we're only setting the color of one vertice related to our face. You'll see right here where my mouse is, we only set this one vertex right here to be black, but the top right and the bottom vertices don't have their vertex colors changed. We want to make sure we're changing all the vertice colors for the face we're hovering over. So we only did one, which is the A value of face. We want to make sure we're doing the same for the B and the C values of our face as well. So all we need to do here is we copy this line of code, and we want to make sure that we change face.a to face.b to make sure we're changing the color for that vertice as well that we're hovering over. So now we have two vertices changing their vertex color, the bottom left, the bottom right. We just have one more to go, which is going to be the top one. We need to make sure that we're also referencing our face.c, and those are all the vertices related to that one face we're hovering over. So we save, and now all the vertices of this one polygon right here, this one face, should light up as black, darken as black. So we hover, and now all three vertices are indeed black, and it creates for a much smoother effect with everything lighting up as you would like it to. So looking at this over here, this code is pretty sloppy just because we're duplicating our code many times. This is a very long statement. It's hard to read. So something you can do to make this a little cleaner is object destructuring, which we went over a little bit, I believe, in this video already. What I'm going to do is, we know we need to select the color attribute related to our object geometry, which we're selecting using this long statement right here. So what we can do is we can just go ahead and cut this out of where it is and assign a const of color, which is going to reference the color associated with this attribute's object. If we do things like this, well, now we can easily read our code to say we want to set our color's X value, or R value, equal to whatever code we have right here within its argument. And we can go ahead and do the same thing by getting rid of all this extra code right here, because we're already referencing the geometry attribute's color. We do things like this, things are going to function exactly the same, but obviously this is a lot cleaner as before, because now we just have a small color constant instead of that long beefy statement with intersects object geometry and attributes. So right now we're only setting our red value equal to 0, which in return gives us a black hover effect. What if we want to change that to a different color? Well, we need to make sure we're not just setting the X value, the R value for our face vertex. We also want to make sure we're setting the G value, which is going to be Y. If we use the function set Y, we're going to be setting the middle piece of data within our array. Let's say our array consists of this. Right now to start, RGB. If we use set Y, we're going to be setting this middle value right here. So if we set this equal to 1, our green value is equal to 1, and we set red to 0, which we're already doing right here, well, now our hover effect should be green for the vertex we're hovering over. So let's go ahead and do that. We're going to set that middle value for our face A equal to 1. Let's watch what happens. We start hovering over things, and at least one of the vertices is turning green. The others are still turning black because we haven't taken into account the other vertices. To make this a little easier, we can comment out vertice 1, vertice 2 for this code, and then this last set X is going to be equal to vertice 3. So if we want to make sure we're not just changing vertice 2 equal to black, we need to make sure that we're also setting its Y value, its G value, on face B equal to 1. So now we only have one black vertice being set. Let's go ahead and change that as well. We want to set that vertice on face C so that its green value is equal to 1. And now everything is going to highlight green as we begin hovering over this. And you can go ahead and do the same thing for blue by setting the face A vertices Z, the third data value within the array, equal to a value of 1, and this is going to change it blue. You want to make sure you do this for every vertice within the face you're hovering over. So we set Z here for face B equal to 1. We change the green back to 0. We do the same exact thing for our last vertice. Change it equal to 0. We should get blue when we hover over this. And it looks like we do. And I just messed up a little bit here. Right now we're setting green equal to 1 for that one vertice. We're going to change that to 0. Make sure that blue is 1 instead. And now we get the hover effect we're looking for. So this is exactly what you want to get some sort of highlighted hover effect, is to add in your color attribute, make sure it's populated correctly, that your material has vertex colors turned on, and that you set the vertex color equal to a new one within your raycaster intersects conditional. I know it's a lot, guys, and I'm sorry if that's a little confusing. It's a lot to take in at once, but this is currently the easiest way that I'm aware of to get the effect you want to get. It's probably a little harder than Canvas, but hopefully I explained that in a way that makes a little more sense than it would have trying to learn that on your own. So if we look back at our to-do list, well, we successfully added in a hover effect, and we are changing the surrounding vertex colors based off the intersected face we're hovering over. So you might think, well, can't we just go on to HTML now? Well, not quite. There are still a few things that we want to do to make this look a little better and start matching up with what we have over here. The first obvious one is we want to change the color of this to match something over here. This looks like kind of like a river or ocean of some sort, which I really like. So I want to make sure that we're changing our color to match up exactly. So how do we change our color to match up with something along the lines of an ocean? Well, where are we changing the color by default for our plane? Within our material is created right here, mesh falling material. We took out the color attribute because it was interfering with our vertex colors attribute. So right now, the color of our plane is determined by our vertex colors, which if we scroll down, our vertex colors are determined right here. By default, they're going to be the R, G, and the B value we're pushing through into our colors array, and then setting as our color attribute for our geometry. So here we can give RGB values to be the exact color we want our plane to start out as. And to save you some time, to get the exact color we're looking for over here, those values are going to be 0 for R, 0.19 for G, and 0.4 for our blue. That's going to give us this nice ocean-like blue color. Hover over it. Well, we're still getting a neonish blue hovered over it because we haven't changed the color of our hover effect. So we scroll on down where we're changing each vertex color within our animation loop. These three values, RGB, are going to be represented of the color we want to add in whenever we hover over our plane. And to save you guys time here, to match up the color of this light blue, we want to make sure that we supply an R value of 0.1, a G value of 0.5, and then a B value of 1. And we want to make sure we're doing this for each vertex of the face we're hovering over. So it's going to be 0.1, 0.5, and 1, and then 0.1, 0.5, and 1 as well. We save this, we go back to our app, and now when we hover over this, you'll see it has that same light blue color that we have over here. The only difference is, when we hover over things, eventually the color changes back to normal. To do this, what's happening is each face we're hovering over, we're setting the color equal to the new color we set within vertices 1, 2, and 3. But as that is being set, we're also calling an animation function to fade the vertices back to their initial color. And we can do this using an animation library called GSAP if you haven't heard of it. So GSAP is the go-to for creating animations without much headache. To install GSAP, we're going to be using the terminal method the same way we installed Vite and dat.gui. So what we're going to want to do is open up our terminal, make sure that you're inside of your directory for your project, and then we're going to run npm install GSAP. Make sure that you save this so that it is installed as a dependency. Once it installs, you'll see that it should be listed out within your dependencies within package.json, and now you can import it into your main.js file. So if you want to import a library, it's typical to go to the very top and write import. For here, GSAP, we're going to be importing a GSAP object from the GSAP library. And remember, we can always test that it was imported correctly by console logging it out. We go back to our app, look within our console, scroll to the top. You'll see right here, this is actually the GSAP library that we can begin using. So now that it was imported correctly, we can go back to our intersect code, which is going to be down here. So we're going to be changing all the faces vertices equal to a light blue, but after that change happens, immediately after that change happens, we want to animate it back to its original color. So using GSAP, we can call a to function. This is going to be, what do we want to animate to? What do we want to animate in the first place? The first argument here is going to be an object. We need to create an object that consists of the RGB values of our initial color. So what was the R value of our initial color? If we forget, we can always scroll back to where we are setting our RGB values for each vertex, which is going to be right here. So R is going to be 0, G is going to be 0.19, and B is going to be 0.4. So let's go ahead and remember that. R is 0, G was 0.19, and B was 0.4. So we have an object for our initial color. We're also going to want an object for our hover color. This is what we want to change our value to. So if we look at our R is simply 0.1, our G is simply 0.5, and then our B is simply 1. And we want to make sure we're not calling this initial color, but hover color instead. So we know when we hover over this, we're changing the vertices equal to this color. So the vertice is currently equal to what hover color is right here. We want to animate these values down to our initial color instead. So what we can do is we can select our hover color object, and then for our second argument, we're going to be adding in 2 curly brackets to represent an object full of values. Well, what properties does hover color have? Well, it has an R, it has a G, and it has a B. These are the values we want to animate. But to what value do we want them to animate to? Well, we have those values right here within our initial color object. So we want to make sure we're bringing 0.1 down to 0. So what we can say is we want our hover color R to go down to our initial color R. We don't want it to stay at 0.1. We want to do the same thing for our G and B values. So hover color G is going to go down from 0.5 to 0.19, and then hover color B is going to go down from 1 to 0.4. So this is going to interpolate these numbers right here down to here, and we can see this in action by adding in an onUpdate property that is assigned to an arrow function within our second argument object right here. If we console log out, update to start, begin hovering over this, you're going to see update is called multiple times because this is running an animation. Let's go ahead and log out the values of our hover color. Hover over this, and you'll see that those values are slowly shrinking towards 0.19 and 4 over time. Even if we begin to hover off of this, this is still going to run. It doesn't matter if we're no longer intersecting the plane. But why isn't the color actually updating whenever we hover off of it? Well, although we are changing these values right here to go back to the initial color, we're not actually setting the values within our geometry. We need to make sure we're doing that. So all we really need to do here, we are going to select where we are setting our 3 vertices, which is right here, and we're going to be pasting that in to our onUpdate function. And now, since we are setting our vertice colors within here, we can reference the value that is being interpolated, which is going to be initial color R, initial color G, initial color B, and we want to do the exact same thing for these 3 guys right here. And if we save this and start hovering over, you're going to notice, not really working, and that's just because another mistake on my end, happens from time to time for sure, is remember, we're not animating the initial color, we're actually animating the hover color. So if we want to get that smooth interpolation, we need to make sure we're setting the vertice colors equal to our hover color for each frame this animation runs. So now if we save with the hover color and begin hovering over this, you're going to see it has that nice fade out effect over time and eventually goes back to our initial color, which we declared right here. So really cool thing to get that water trail effect. So looking good, one of the last things we want to do in order to get a good homepage is we want to make sure we tailor this to the exact dimensions we want when a user lands on it. So if I were to change my width or my height, you're going to notice that our background turns black and it doesn't have any hover effect associated with it. We also get a bug in the console. Now, why is this happening? Well, let's go ahead and inspect where we are setting the color for each individual vertice. Well, let's get rid of some console logs, clean up our code a little bit. You're going to notice that we are setting the color for each individual vertice right here. But whenever we affect our width or our height, well, we're calling that within our generate plane function, as you can see right here with GUI add. So we need to make sure we're also calling this code right here whenever we are generating a new plane to ensure that it has the new vertex colors. So one simple thing we can do is we can just copy this code right here, scroll on up to where we are generating a plane, get rid of any excess code we don't need, and after we are setting the new positioning of our vertices, we can go ahead and set the color of them as well. So now when we affect our width, we maintain that color. When we affect our height, we maintain that color. And we still have the hover effect. And the cool thing is this works no matter how many segments we have or what width or height we have as well. We still have the same exact hover effect occurring. So how would I tailor this piece right here to look something more like this on a refresh? Well, the very first thing I would do for sure is I would enlarge this to the correct width or height. So if we go ahead and enlarge this, well, that goes ahead and it reaches the edge of the screen, but now we don't have as much dimension here because we don't have as many segments. So if we begin turning our segments up for both width and height, let's go ahead and just find something we like. I personally like a little more segments than a little less. I think that looks good. We'll go ahead and call this 19, 19, 17, 17 for something that I personally like. You can set this to whatever you guys would like on your own. So if I want to change the default in which this plane is spawned at, well, where am I creating my plane geometry? It's going to be right here, new 3 plane geometry, and we have all these hard-coded values. So really, for our width, I'd want to put in 19. For our height, I'd want to put in 19 as well, matching them up with what we have in the top right-hand corner here. And then I'd also want to change my width segments to 17 and my height segments to 17 too. So if I save this, you're going to see that the plane spawns with these new attributes, which is perfect. But one issue is now the defaults for our dat.GUI object up here aren't the same. They are not matching up with what they actually are. So to fix this, what we can do is we can go back up to where we are setting our plane object, and we're going to change our default width to 19, our default height to 19. I believe width segments was 17, and same for height segments. And if you don't want to have to keep changing these in 2 places, you can go back down to where you are setting the attributes for plane geometry, and you can just reference the dat.GUI object directly. So it was world, plane, and then width. So this should maintain the width assigned for dat.GUI. You'll see we have a width of 19 still. That is perfect. We can do the exact same thing for our height, and then the exact same thing for our width segments, and then our height segments as well. So on save, now we are referencing all the data from that data object up top, and if we want to change the default value for both our plane and the values for the sliders right here, all we have to do is change the value within this plane object. You'll see the default changes, and the plane actually changes as well. So that's perfect. That's exactly what we want. We'll go ahead and maintain what we came up with, which is going to be 19, 19, 17, 17. So now if I go ahead and exit out of this, it's always good to test what this looks like in full screen as well, see if that's something you like. I think that's pretty good. Honestly, I might expand this just a little bit more. So what I can do is, if I want to expand my width and height, I can change the max value for our width to be something a little larger, something like 50. For both width and height. And now I can expand my width and height and play with this a little more. Let's go ahead and make it something like 24. And I want more segments. 24 and 25. 25 is probably something I'm pretty happy with. And now you can see, since we have the orbit controls in place, if I click and drag, well, we have this nice plane laid out. And you can always expand this more by playing with your width and your height attributes over here to make it a little larger based on whatever you'd like. And the very cool thing is with raycaster and the vertex effect, well, the hover works no matter which angle we move our object at. So really, really cool stuff right here to play around and create this geometric background. So we tailored this to the exact dimensions we want, but one thing I actually forgot to add in here, I'm going to add this in now, is add vertice movement. So if we look at the original, and we scroll in, you'll notice that these vertices are actually moving in randomized directions, but they're not actually going off the screen or affecting the plane in some way to where it just doesn't look good. They're just moving in a controlled motion around each other, and it creates for this really cool kind of wave-like effect. Here, we don't have that. You could technically get away with this if this is what you want, but if you want to add that movement effect, well, we're going to need to do a little bit of editing, specifically within our animation loop. If you want something to move in a controlled motion back and forth between a specific point, one, you're going to need to use sine or cosine functions. Those are 2 functions that are always going to return a value -1 to 1, and since they always pulse between -1 to 1, we can affect a certain position to pulse between 2 specific points. And 2, we need to be able to track the original position of the vertex. We always want to reference that when using math cosine and sine functions, because the actual position of the vertex is going to be changing. We need to make sure we're referencing the original position of the vertex to get some sort of pulsing effect. So that's going to be the very first thing we do, is we're going to store the original positioning of each individual vertice within a new array. So if we scroll on down to where we are setting our vertice positions, I'm just going to add that in here, vertice position randomization. And I'm going to add a quick label right here, color attribute addition. Just so I know what this code does, makes it a little easier to read. Here we are only setting the Z positioning for each individual vertice. If we'd like to randomize this a little more, we can change this so that we're also setting the X and Y to be a little more randomized. So let's say we want the X position of this vertice to be somewhere over here or over here. Just randomize things a little bit. Well, first we would have to select the X position, which is always going to be the first iteration of what we're looping through. You'll see right here, array I is equal to X. So we're going to be setting X equal to the current X value plus math random. Now math.random returns any value 0 to 1, any randomized value. But if we add that 0 to 1 onto this point right here, well, that's only going to push it in the right direction. We need to make sure that we're able to get a randomized negative value from this as well. So if you subtract 0.5 from math.random, well, let's think. If we subtract 0.5 from 0, well, we have a value of negative 0.5. But if we get the high end of math.random, which is going to be 1, we subtract 0.5, we're going to be getting a value of 0.5. So this is a good way to get a random value anywhere from negative 0.5 to 0.5. But it might not affect the vertice as much as we want it to. If you want to affect this a little more, you can always multiply it by a larger number, such as 2 or 3. And that's really going to alter the X position of your coordinate. I think 0.5 was fine, honestly. So we're just going to go ahead and stay with that. And let's go ahead and also alter the Y positioning as well. To select the Y positioning, what do we need to do? We need to select I plus 1, that is the Y coordinate. Make sure we are using the current Y coordinate and then adding on a math.random value minus 0.5, so we get a negative value as well, possibly. And that actually looks a lot cooler than we had it before. But remember, to add in that animation, we need to store the original position and then alter this position right here. These positions are what we need to alter within our animation loop, but we always need to reference some original position. So to create an original position, what we can do is we can select our plane mesh, get our geometry, go to our attributes since we want our position attributes, and it's always good to console log this stuff out to see what exactly are we dealing with. So if I were to console log this out and look in our console, you'll see that this is console logging out a float32 buffer attribute. Inside of here we have quite a few properties, including the array that we're going to be editing to affect the actual movement of this vertice. But what we can do is we can add an additional property in here that is just a duplicate of the array that is never going to change, but we're going to be referencing that duplicate to create that movement effect that goes back and forth. So what I'm going to do is I'm going to select our attributes.position, and I'm going to create a new property called original position. And all this is going to be is equal to our position attribute, and specifically the array inside of it. So now when we log this out after setting this, we can open up this object again, and now we have a new property, original position. It is the exact same thing as our array, which contains all the data properties for editing each individual vertice. So to start animating these, we want to go to our animate loop, which is going to be right here. And we want to make sure that we're looping through this array, which is our positions attribute array. So we're going to do this above our raycaster. This doesn't require any intersection or anything like that. We're going to create a for loop. And what is our array length? Well, what do we need to access? We need to access our plane mesh, its geometry, its attributes, specifically its position attribute, and then we want to access its array. This is how many times we're going to loop through this. And remember, whenever we have an array, we need to specify its length to get an actual number. So we're going to be looping through this about 2028 times. And if you want to clean up your for loop, remember, you can always take that long object property and use object destructuring to grab the array and set it to a new constant. So here, we can just reference the array directly with a small version of it and get its length. So right now we're looping through that giant array about 2028 times for every frame. To make this a little more performant, we can just select each data value as groups of 3 because we know each position has an X, a Y, and a Z. So same thing like we did earlier for one of the groups. Instead of adding 1 onto this for loop, we're going to be adding on 3. So now we're looping through substantially less times. And here we want to set our position for X, Y, and Z to be something different over time. So what we're going to do is we're going to be setting our array I. This is always going to be the X coordinate. And to get some sort of pulse effect, this is going to be equal to the original value. And remember, the original value is within this position object. So not only can we reference our array through object destructuring, we can also reference our original position. We're just pulling it out of this position object. So what we can do is we can set our array equal to the original position I. So basically the x coordinate of this is exactly the same as the x coordinate of this, but to create a pulse effect, we always need to alter the original value without actually altering the value that actually moves the freaking thing on the screen. So if I save this and refresh, nothing's going to happen, nothing's going to move. But if I add on to this original value over time, a math.cosine function, which takes an argument of radians, just a fancy version of degrees, if I begin to increase the value within this argument, this math cosine function is always going to return a value -1 to 1, and it's just going to pulse between -1 to 1 over time. And if we're continuously adding on -1 to 1 to our original position, we're going to get a movement effect on the x-axis for whatever vertice we're looping over. So if we want to change the value of this over time, we're going to go outside of our animate loop and create a let called frame. This is going to be equal to 0 to start, and then for every frame we actually loop through, we're going to be adding a small number onto frame over time. This is going to represent what frame we're on, how many times we've called this animate function. And now that this is increasing for each time we loop through animate, we can put it within our math cosine function. So we're going to put frame here. So if we add frame on in there, we're not going to see anything just yet. We can always test if this is working by only looking for the first iteration of this loop so we don't bug out the console. What we can say is if I is equal to 0, meaning it's the first iteration of this loop, let's go ahead and console log out math cosine frame to make sure that this is actually increasing and decreasing as we want to. You'll see it's going down, down, down till we hit -1, perfect, and then eventually it's going to go back up until we hit 1. So we know that's working, and we know that array should be affected. We can also console log this out to make sure that's working as well. Array I, and indeed that value is changing for the vertice we're looping over. So why isn't it actually being affected right here? Well, the reason is when we are updating our position right here and we're animating it, we need to make sure that we're telling our attribute that it needs an update. So if we set this equal to true, we save, you're going to see that it just immediately moves off the screen, and eventually it's going to come back. So we do have a pulse effect for each individual vertice, but they're all moving at the exact same time so that they go way off the screen and eventually they pulse back to the left side of the screen. So if this is happening, what you can do is you can set math cosine to be something a lot smaller. To make it a lot smaller, you can multiply it by a value 0 to 1. We're going to multiply it by something like 0.01. You're going to notice that the x value is moving left and right, but this isn't really the effect we want. We want each individual vertice to be moving in a random position independent from one another. So rather than each vertice have the same value produced by math cosine frame, we need to add some random value inside of this for each individual vertice. So where we are looping through our position right here, we can do all the work to add in a random position for each vertice as well. Right now we are looping through every 3 iterations, and each 3 iterations are going to have their own random value, but to access these random values in kind of like a buffer format where everything's stored in an array, well, we're going to want to create an array called random values. This is going to be equal to an empty array to start. And as we're looping through each vertice in this random values array, we're going to push in a new math.random value. So at the end of this, after we go through the whole for loop, if we console log out random values, we should see a list of random values. And to clean this up, let's go ahead and get rid of any additional console logs, make sure we're only looking at exactly what we need. I'm just going to Command F to make sure we're only logging out those random values. It looks like I got everything, deleted them. And these are all the random values. We have an array of 676, which should be how many vertices there are within this default plane. So now that we have this random values array, let's go ahead and attach it to our plane mesh position attribute, similar like we did right here with the original positioning. I'm going to reference random values onto this, set it equal to our random values array. So now when I console log out our positions attribute, console log plane mesh geometry attributes position, we should see those random values being stored in here, and there they are. You'll see we have a vertice count of 676. We also have 676 randomized values that we can now use to make sure that these are moving at different rates compared to before. So now that we have these random positions, we can begin to insert them within our math.cosine function here. So what I'm going to do is onto frame, I'm going to add on our random values array. And if we just want to reference random values exactly like this, we need to make sure we're pulling it in from our position attribute. So here where we are destructuring stuff, I'm going to make sure that I'm pulling in random values. And we can't add on an array to a frame. We need to make sure we are accessing the random value within the array. We are looping through. So to get that, simple enough, all we need to do is reference I. If we console log this out and look inside of our buffer attribute, you're going to see now we have this array full of random values. But there is one issue here. The array we're looping through to change all the positions is this array, which consists of 2028 values. We need to make sure that this random values array is equal to that, or else we're not going to have a randomized position for both x, y, and z. We're only going to have them for x. So what we can do is, within our for loop where we are populating this random values array, is we know we need 3 times as many random values. The reason we're not getting 3 times as many random values right now is because we're skipping over every 3 values within this loop. So what I'm going to do is I'm going to change I plus back to I plus plus, which means we're adding 1 onto I. We're looping through every value within array.length rather than every 3 values. But we know this code right here is dependent on looping through every 3 values. So if I want to make sure, even though this for loop is looping through every value, if I only want to activate this code for every 3 values, I can use a modulus operator. So I'm going to say if I divided by 3 has a remainder equal to 0, then I want to run this code. This is going to give us the same effect for everything we have right here. But at the same time, we're going to be able to push in a random value for every iteration of this loop. So basically we only have to call this for loop once, but we still get the best of both worlds because we can call this code and we can also call this code. So go ahead and save this and then look within our array again. And now random values does indeed have 2028 values, and our array positioning is still altered correctly because we're only calling this code for every 3 items within our position array. So that's looking good, but let's go ahead and start animating these correctly with our randomized value. So if I go ahead and scroll on down, we want to make sure that each vertex has a different value outputted by math.cosine. So we have frame, which means everything is going to be the same, but we want to add on that random value. So we need to access our random values array. And if we want to access this directly, we need to make sure we are destructuring from our position attributes object. So we'll make sure we add it in right here. And you can't add an array onto a frame. We need to make sure we are selecting the exact value we want to add onto this. So I'm going to put I right here, which is going to select the value we are iterating through. We'll put I there. And now you'll see the X values are much more randomized. Everything's not just pulsing back and forth, but they have their own little direction in place. So this looks like a lot of movement. I'm going to slow this down even further by multiplying this by a lower number. And even that might be a little too low, so I'll increase that a little bit. And just go to taste to something you like. I think for how big our plane is, I think 0.003 is going to do. But let's go ahead and make sure that this is also randomized in the Y direction. So a simple thing I can do is I can just copy this line of code that we just created. Above it, I'm going to comment Y. This is the Y coordinate that we're going to be altering. And to select the Y coordinate within our buffer array, I'm going to add 1 onto I. That is going to be where the Y coordinate is. I'm going to do the same thing for the original position because we want to make sure we're grabbing that initial value and then setting the new value equal to that. And then we're going to be calling math.sine instead of math.cosine. Cosine and sine work together to create full circular motion. So if we add sine onto this instead of cosine, we're going to get a much more randomized effect compared to if we were just using cosine for both. So if we change cosine to sine here, and then make sure we are referencing not just I, but the second value within our randomized array, we're going to get something that looks even more randomized. And you'll see now the Y coordinate is randomized as well. But there's still one little thing here, and it kind of looks like all of our vertices are moving in a circular motion in the same direction. If we want to randomize this even further, remember the trick I told you about getting a negative value with math.random as well? Well, when we're pushing in values into our random values array, what we can do is subtract 0.5 from math.random to make sure that things are going to be in a different direction. So I save this. So now you'll see we have a lot more randomized movement in the Y direction. So this is definitely something you can keep. If you want to get closer to the original like we have over here, you're going to want to copy these attributes. And I know I said I wouldn't come back to these, but just for the sake of completing this as close to what we have over here, let's go ahead and change these values to match up with what we have in the original piece. So we know our width right now is 24. We can change those at the top. where we have our data object for GUI. We're going to change our width equal to 400, which is what it was in the example piece. Same for height, that is also going to be 400. Go back to the example, reference what we have. Width segments is going to be 50, height segments is going to be 50. Change 25 right here to 50. Let's see what we get. Well, now we are just way too zoomed in. An easy way to fix this is to find your camera Z position and set it to whatever you would like to make sure that it's further away from your plane. I'm going to set it equal to 50. That's definitely going to pull it away a lot further. But now we don't have as much depth as we did before with this larger plane. So we want to go to where we are randomizing our vertice position. And you can see right here, this is where Z is randomized. Well, right now they're only being randomized where the Z vertices come closer to us. Remember, if we subtract 0.5 from math.random, well, now they can go further out or closer to us because we're getting any value negative 0.5 to 0.5. But there's still not a lot of depth. So if you want more depth in either direction, we can just multiply this by a larger number. And now we do indeed have a lot more depth. So we're looking pretty similar to the example piece over here, but you'll notice the example piece is a little darker. If we want to make this a little darker, well, it's going to be based on our light positioning. Over here, the light positioning is closer to us and above the plane. But if we look over here and we look at our light positioning, well, we're just setting it further to us and looking directly at the plane, but there's not really any angle in the Y or X axis. If we want to make sure that it's shooting at an angle, we're going to get more shadows, which gives it more depth. So what we can do is we can set its Y position equal to 1, which means we're going to be moving it upwards at a 45-degree angle rather than just facing the plane directly. If we save that, well, now we have that depth we're looking for. It looks very similar to what we have over here. Maybe it's just in a different direction. That takes care of the color, but there's still something just a little off. If we want to tailor this even further, let's go back to where we are randomizing our vertice position. And our X and our Y's are kind of lining up with each other right now. If I go across this, you'll see all of our vertices are almost creating a straight line, almost. And over here, they are just much more differentiated from each other. So if we want to differentiate the X and the Y a little more to create less of a more straight edge effect, what we can do is we can alter the set Y position to be a little larger than it was before. So we're going to multiply our Y by 3. We're also going to multiply the X for our vertices by 3 as well, randomize it a little bit more. And now that is pretty one-to-one what we have over here, maybe just a different direction, but you still get the same exact effect that we have in the example piece. Play around with these a little bit to really get different effects, and you can see just how much it really changes the landscape you're working with. I'm going to stick with these variables, and then I'm just going to make sure that our dat.GUI is fixed. So instead of limiting width to 50, I'm going to make sure that this can go all the way up to 500, and then I'm going to make sure our segments can go up to 100. Now we have the ability to alter this, but we're almost done with this plane thing completely. If I go ahead and alter this just a little bit, you're going to notice that our polygons are a little messed up, and we also get an error in the browser. This is due to the fact that things such as our random values and things such as our original position are only being created on load. We need to make sure that these are also being created whenever we change one of the sliders up here. So what I'm going to do is, where we are randomizing our position, I'm going to go ahead and take all of this code, go up to our generate plane function. I'm going to paste it in. We have duplicate code right here, which is our old randomization code. We can go ahead and get rid of that. If we save, we're not going to get anything right here because we're not calling this randomization code things that stores properties onto our position attribute array like we need it to. So what we need to do is we need to make sure that we call this generate plane function after we actually create our mesh. And you look inside of this function, we have all of our color setting done right here. Scroll a little further down, we have the exact same code right here. We can just go ahead and get rid of that because we're going to be calling it again using the generate plane function. So after we create our mesh, we're going to generate a plane which has all the randomization in it, and we still get the same effect, but now once we go ahead and change the value of height and width, things are randomized as before, our hover effect still works, and our colors are still taking place. Can change pretty much any value here to get the exact effect we want without anything breaking in the process. And one more thing to touch this up, I promise this is the last thing. If you notice you're getting too much of a circular movement here, what you can do is where you are populating your random values for this array, we're just going to look for random values. This seems to be where we are populating things. We're only pushing through any number 0 to 1 within this random values array. But math, sine, and cosine, if we want to extend the full random range of -1 to 1 we need to make sure that we're supplying cosine or sine with a value of 6.28 pi times 2. So really, instead of just any value 0 to 1, we want to make sure that we're supplying math random times math pi times 2, which is going to give us 6.28. We're going to be getting any number 0 to 6.28 instead within this random value array. Just make sure that you multiply that value right there, or else things will break. And now that is going to be a lot more randomized compared to what we have before. You can even test this. If we can't really see your movement too much, you can either zoom in, or you can go back to your animation loop, increase this factor right here by something larger, such as 0.1, and you should be able to see your animation a bit better. Do the same thing for Y. And now we're going to have true randomization for each vertex compared to what we would have had beforehand, where everything is just limited from 0 to 1.
It's break time. Do you like this video? Don't forget to subscribe to get new videos. Share this video to open new premium videos and ebooks. We'll be a Starfreelancer.
Okay, so finally, looking at our to-dos, we added in vertex movement. All we have to do now is add in HTML and integrate with JavaScript. This is the easiest part in my opinion. Apologies if this is a little hard to grasp, guys. It's a little hard for me to teach, to be honest. So to add in HTML, let's reference our beginning piece. We're going to go ahead and see that we have our name, we have this little headline, and then we have a button which is going to go to some other page on your website. So to add in HTML to this, we're going to go on over to index.html. And here we're going to start adding our markup. So you can do this within this default ID app, or you can do it without it. It doesn't really matter. We're going to go ahead and write our markup inside of this. What is our markup look like right now? Well, we have this one container that consists of, it looks like a headline, another headline, and a button. So let's go ahead and make another container. It's going to be a simple div. And then we have this main headline for our name. The first headline, in my opinion, should always be H1, even though it's smaller. So I'm going to go ahead and make this an H1 tag. And then pretty much anything under a headline, I by default make a paragraph tag. And then I need to make sure that I add a button to this as well. So I'm going to add this button markup. It's going to be called view work. And remember, this is the finished product. We need to make sure we're going back to the one we're working on. If we look at our HTML, this is what it's going to look like by default. We need to make sure that we alter it to look something like this, and that we can still interact with our background in the process. So to start styling this with CSS, the first thing we want to do is get this one div. If we inspect this div by clicking on this button in the console, inspect the div, we need to make sure we get this div laid on top of our canvas piece, or Three.Js piece. How do we do that? Well, if we want to take it out of the document flow, meaning we can overlay it on top of other things, we can give it a style of absolute. So what I'm going to do is within these style tags right here, I'm going to add an additional style called simply.absolute. And this is going to have a position of absolute. So now if I add this class to our div right here, it's going to take the style of position absolute. I'm going to add that on. And once we add on position absolute, you'll see it's taken out of the document flow and it's overlaid on top of things. Next up, let's change the color of the text so it's white and it contrasts a little better than what we see right now. So to make sure our text is white, I'm going to create a class called text white. This is going to have a color of white. So now I can pretty much just add this to our default div, and all the stuff inside of it, minus our button, is going to have the text of white. So text white, save. And now our text is white, which is perfect. So you'll notice the way I'm writing CSS, I'm writing these using utility classes. Basically, each class gets one style associated with it. And the reason for this is it just makes your HTML super easy to write. Rather than thinking of a name for a class, such as container wrapper or something along the lines of that, you don't have to think of a name, because all of these names I'm coming up with represent exactly the style that is inside of them. At the same time, these are all standardized using a framework called Tailwind CSS. Basically what I'm doing here is I'm replicating the style of Tailwind CSS, but eventually you're going to get to the point where writing all of these classes is super cumbersome and tiring. So rather than write all of these manually, what we can do is we can go ahead and visit tailwindcss.com, search for get started, click on read the docs, and we're going to do a command F for CDN. Tailwind CSS doesn't recommend you use a CDN, just pulling in the framework using a link, because there's a lot more customization available using their other installation method, but for our purpose of just getting this inner project and using it, this is totally viable. So what I'm going to do is I'm going to paste this link right above our style tag, And just like that, we now imported Tailwind CSS into our project, and we can use all of the styles associated with Tailwind CSS, including things like absolute and text white. We can get rid of these two classes right here, save. And now you'll see that our text is still taking on the styles of absolute and text white, with a few things even different because Tailwind CSS has a reset associated with it. It sets some default browser styles equal to their bare bones equivalent. So adding Tailwind CSS is pretty good in my opinion for giving you a full CSS reset while allowing you to use all the nice classes within the library. So I'm going to walk you through how to style this exactly with Tailwind CSS. So we know, looking at our example over here, our text is centered. So Tailwind CSS has a class of text center. What does this do? Well, it centers your text. Easy enough. If you're ever unsure of what class you should be using within Tailwind CSS, you can go on over to their docs, search for anything such as align, text align, and you're going to see the exact classes you can use. So we just went ahead and used text center, and now our text is centered. But next up, we want to make sure that this text, the whole container, is actually centered directly in the middle of our screen. So we're going to do this using position absolute. This is a little trick from the old days, but it's still relevant today. We want to make sure that within our div right here that we add a style of top. This is going to push the container down from the top of our page down 50% of our browser width, well, the container width. So it's down 50%, but you'll notice it's not exactly centered. If you want to exactly center this, you can add a style of transform, translate, y, -50%. And now this is going to be centered vertically perfect in the center. So we want to take these two styles that we just wrote in line within the browser and make sure that they're within our code so that they take effect permanently. So I'm going to add in a style tag, and I'm just going to add in two inline styles here. There's nothing wrong with using an inline style. Don't let anyone tell you otherwise. If you need to get some quick style code in there that's not in Tailwind CSS, this is how you're going to want to add in a style. You don't need to write a separate class or anything. In my opinion, it's just extra work. So if we add in this style right here, you'll see that now on refresh, everything is centered vertically. Perfect. But how do we center things horizontally? Well, if we set our left attribute equal to 50%, it's going to do the same thing. It's going to push it over 50% from the left-hand side, but we need to make sure that the center is within the center of our screen. So what we can do is, instead of translate y, we can just use translate, which takes an x value for its first argument. So x is going to be pushed to the left by -50%, and then the y value for its second argument. So we're going to push it back up by -50%. And now this is centered perfectly in the middle of our screen. And the cool thing is, if we inspect our div, it's only taking up the exact width of our content. So our hover effects are still going to work as we move our mouse around our actual object there. So it's starting to look pretty good, but if we look over at the piece, we have fonts that just look way better. Picking out the right font takes a little bit of experience in my opinion, but let's go ahead and use the two fonts that we already have in place. If I go ahead and inspect this piece, we can see what fonts those are. And you'll see that this is actually a font of XO2. So this is a Google font. If we want to add a Google font onto our page, we're going to go ahead and search Google Fonts. We're going to go to the Google Fonts website, and then we're going to search for that font exactly. So XO2, this is the font I was using. And I was using the italic variant. I'm pretty sure I was using regular. So if we want to select this font, I'm going to go ahead and select this style. And you'll see that it gives you a link in which you can use to import it into your project. So right above our Tailwind link, I'm going to paste in that Google Fonts link. And it gives you a little bit of code on how to use this within your project. If you'd like to use this within your project, well, you have to set your element to have a font family of XO2 sans serif. So Tailwind doesn't know we want to use this font. As a result, we're going to have to create our own font class. And the name of this font is XO. So I'm going to create a class called font XO and set it equal to font family XO2. So going back to our app, now if we assign our paragraph tag to have a font of XO, now we are using the same exact font we got from Google Fonts because we are pulling it through Google using a link tag, and then we are setting this font XO class equal to XO2, and then finally using it, setting our paragraph class equal to that font. So off to a good start. Looking back over here, you'll see up here we have some sort of monospace font where each character is the same length as the next one. It gives for a very techie feel because if you look at our text editor over here, this is using a monospace font as well. You don't want some sort of font that has different widths for your text editor because you want to make sure that you have some sort of standard in place for when you look at your code, everything is in the same spot, not based on some specific character width. So this is a monospace font. Let's go ahead and use a new Google font to get this in. We're going to go back over to Google Fonts. I'm going to exit out of this. I'm going to scroll up to the top, go back to the home page, and I'm going to search for mono. So a mono font that I really like actually is going to be the Space Mono font. It's something I've used on another project and I like it a lot. So I'm going to go ahead and select this. This is just going to be a regular version of it. So I'm going to select the style. If you don't see the little pop out on the right like before, you're going to want to scroll on to the top. Make sure you click this. And now we have two font families selected, XO2 and Space Mono. It's going to generate a new link for us that pulls in both of these at the same time. So what we can do is, back at our previous link, we can delete these two that were supplied to us by Google prior and paste in the new one. So now we have access to two fonts rather than one. And the nice thing about Google Fonts is it tells you how to use them. So we're going to create a new font called Space Mono, and this is going to be equal to font family Space Mono. Makes sense. So now that we have this font pulled in, we can set our H1 equal to font space mono, go back to our app, and now we have that mono font in place. So now we just have to set these fonts to the correct height, the correct font weights, and so forth to really get these looking good. So whenever you want some sort of subheadline, such as your name, and this should be the main focus, you want to make sure that subheadline is de-emphasized. A great way to de-emphasize text is to make it smaller. We can give this a class of text SM. That is going to be 14 pixels. You'll see that smaller, it's a little bit de-emphasized compared to this. Another way to de-emphasize text is to make the other text larger. So if we want to make this text larger, we're going to select our P tag right here and give it a size of text XL. So that's a little bigger. We can go ahead and make this even bigger by adding in a 2XL. And I think I like where that is at. So our text is de-emphasized at the top. This is obviously our focus. And you can keep this as is, that's totally fine. But something I like doing for my subheadlines is I like making them uppercase. I just feel like it looks a little better. So for my subheadline, I'm going to give this a class of uppercase. And whenever you have subheadline uppercase text, it's always good to give it letter spacing. Make sure that each character has breathing room from the one prior or after it. So what I'm going to do is add in a tracking wide class, which is going to increase the letter spacing between these letters. You'll see it increase very slightly, and this is something I really like. I'm definitely going to be keeping this. So I do want to differentiate this text down here a little more from the subheadline. So what I'm going to do is I'm going to go back to Google Fonts, and for XO2, right now we're using regular 400 italic. I want to make sure that I'm using the bold version of this instead. So I'm going to scroll down to the bold italic version, which is this right here. Need to exit out of this. Select the style, scroll up to the top. You'll see that this is where the regular 400 italic is. We can just go ahead and remove this because I don't want to use it anymore. So now we're pulling in the bold version of this font. How do we use the bold version of this font? Well, we simply pull in this new Google Fonts link, go back to our app, and now we're pulling in that bold version. So it's differentiating our text a little more from the text up here. Now, something about this just looks a little sloppy. And the reason it looks a little sloppy is because this text isn't anti-aliased. Anti-aliased means that the browser is going to apply some effects to make sure that the edges of your text are as crystal clear as possible. And you can see this in action. If I go to my body tag and just start typing in anti-aliased, we're going to get this style right here, WebKit font smoothing anti-aliased. You're going to see we get this bold, chunky, a little dirty text, but once I add it in, things are a lot more clear than they were before. So whenever you have any project, you want to make sure that you're adding this style to your body to make sure that all your text is as crystal clear as possible. So I'm going to go ahead and add that in there. Set this equal to anti-aliased, like so. And now that's going to take effect by default. So if we go ahead and compare our piece to the one over here, we're looking pretty similar. Let's go ahead and full screen it so we get the full view of things. Looking pretty similar. The only difference right now is our text is a little smaller compared to what we have right here. So that's something we can do is we can go ahead and increase the size of the text a little more. This is going to be text 3XL. Go ahead and compare that. Maybe we want to go one size higher, text 4XL. So if we go and check our example piece, go back and forth, this looks pretty close. It's not exact, but at the same time, our new one is looking just as good. All we really need to do now is style our button to look something like this. So let's go ahead and do that. On top of our button, we want to add a class. We're going to add in a border to our button using Tailwind. You'll see it automatically adds in a white border. How nice is that? Let's go ahead and give it some padding. If we select our x-axis padding and add in 1 rem of padding by using px4, you'll see it's going to expand it by a little bit. Let's go ahead and do the same thing for the top. Typically within a button, you want less padding on the top and bottom side than you would on the left and right side. So our vertical axis padding is going to be a little less, and that's looking pretty good as well. Let's round the edges of this button by using rounded, large, and then this button text just looks way too big for me. So what I'm going to do is I'm going to shrink it down to text SM. And to keep the font styles consistent, I can change the text of this to match my subheadline up here. So all I need to do that is select font space mono and add it on to our view work button. And remember, every time you have a monospace font, if you're using it as some sort of label or button, it's usually better to make it uppercase. Just looks a little better in my opinion. And that is looking pretty techy, looks very professional, something I like. The button is obviously too close to our headline up there. So what I'm going to do is add a margin top of 4. That's going to push it. We can push it up even further by adding on 8. And that looks pretty good. Maybe I'll even go to 12, just give it a little more breathing room. I think I did like it with 8 a little more. It's just kind of like a taste thing at that point. And this looks really cool, but right now we don't have a hover effect, so the user may not know that this is actually a button. So to add a hover effect, I'm going to use a Tailwind prefix called hover. This is a really nice way to add hover effects and stuff. Is you can just type in hover behind any class that you want to use within Tailwind, and whenever you hover over it, that new class is going to take effect. So let's see. When we hover over this, what class do we want our button to be? Well, we want to give it a background of white. So we just select the background white class from Tailwind, and now when we hover over this, the background is white. But now we can't see our text. So we'll add in another hover class. What color do we want our text to be on hover? Well, let's say text gray 800. So now when we hover over it, our text color changes and we can actually see it. And it's even cooler with our little background effect on the actual Three.Js piece because it lights up the button in the background as we hover over it because it always follows us at all times. So the very last thing I'm going to show you is how to link this button to another website. To make this button link to another website, we're actually going to change the button to an anchor tag. By changing button to A, we're going to give it an href attribute which specifies where do we want to link to. Well, if I want to link this to, let's just say, chriscourses.com, I can just go ahead and grab this URL, plug it within my href code, and now when I go back to my app, you're going to see, one, the styling's messed up, but now when I click on this, it goes to chriscourses.com. Why is the styling messed up? Well, the styling is messed up because by default, anchor tags have a class of inline, which means things like margin start messing up along the way. Our margin isn't taking effect because it has the class of inline by default. So instead, what we can do is we can assign it a class of inline block. And just by assigning an inline block, it's going to make sure that the margin takes effect and that it is positioned correctly. So now when I click view work, it goes to my new website or whatever page you would like to use, but we still have all the effects of being able to move this background. We can even zoom in and out if we would like because we have the orbit control still on it. We just have this really nice background effect compared to what we would have otherwise with just having text on there. This creates for something that really wows your visitor as they come and visit your website. So we have our 3D plane that we can interact with. We can rotate our scene and so forth. But how do we get what we have right here to look like this, creating a galaxy of stars that is slowly rotating towards us to make it look like we're on top of a planet observing the sky? Well, to do so, we are going to want to use something called 3 points. So let's go back to our version of the app on localhost 3000, and let's go ahead, open up our code, and scroll on down to our animation loop. So the final spot in which we are adding new materials, new meshes, and so forth onto our scene is going to be where we created this directional light to light up the backside of our mesh. We're going to be adding on an additional object here, and this is going to be a points object. You can think of a points object as a mesh. It's just that the vertices don't connect to each other. There's nothing filled in between them. We're just creating points and we're lighting those points up to create the galaxy. So to start, we're going to be creating one geometry, and it's just going to be a default buffer geometry. So I'm going to go ahead and create a constant. I'm going to call this star geometry. And this is going to be equal to a new 3 buffer geometry, like so. And now remember, anytime we want to add something onto the scene, any kind of mesh or object, we need to make sure that we have a material that goes with it so we can actually see what it is we're looking at. So we want to create a constant called star material, and this is going to be equal to a new 3 points material. And this is going to take an object for options, and the option I want to set is going to be the color. And this takes a hexadecimal value, so I'm going to create that with 0x FFF to make sure that we are getting white for our color. And just to make sure that these are actually being outputted correctly, like always, we want to make sure that we console log them out. So if we console log out star geometry, that should be just a basic buffer geometry. And if we console log out star material, we should see a 3 points material in our console. So we open this up and it looks like we have both, so we are indeed good to go. So we have this blank buffer geometry, and remember, our buffer geometry for our plane had attributes associated with it. A position attribute, a UV attribute, a color attribute, and a normal attribute. In the last episode, we only focused on the position and the color attributes, but to create stars, we only need one attribute out of those 4, and that attribute is going to be a positions attribute. Basically, within this positions attribute, we're going to have an array, and for every 3 items within that array, we're going to have an X, a Y, and a Z, and that X, Y, Z defines one vertex, which if you think about it, a star is really just a point, which is a vertex. So basically, we're just going to be filling up this array with the positions of all of our stars. So what I'm going to do is I'm going to create a constant called star vertices. This is going to be equal to an empty array. And then I'm going to create a for loop that says create 10,000 stars. So each star is going to have an X, a Y, and a Z position. We need to go ahead and create those randomly around our 3D space. So I'm going to create a constant called X, and this is going to be equal to math.random minus 0.5, so we always get a random number anywhere from negative 0.5 to 0.5. Make sure we get the negative values as well because we want to go to the left and to the right on the x-axis. I'm going to go ahead and wrap these in parentheses. And then what do I want to multiply this by? Well, if I want to make sure that we can get any range from negative 1,000 to 1,000, then I want to go ahead and multiply this by 2,000. So if we get the low end of the range, which is going to be negative 0.5, we multiply that by 2,000, we're going to get negative 1,000. If we get the high end of the range right here, which is going to be 0.5, we multiply that by 2,000, we're going to get 1,000. So this is how you can successfully get a range that goes anywhere from negative 1,000 to 1,000. Make sure your stars are all spread out along the x-axis. We want to do the exact same thing for y and z. This is just going to create a big star field all around us in all directions, making sure everything is randomized as we go. So simply what we can do is we can copy this line and paste it, and then just change x to y, and we want to do the same thing for z. So these points together, if we go ahead and console log them all out, x, y, z, this is going to occur 10,000 times once. You're going to see we're getting random coordinates for all the x, y, and z's that we're creating in here. So now that we have these random x, y's, and z's grouped together, what we can do is we can take our star vertices array and we can push in our x, our y, and our z. So if we go ahead and push all of those in as we're looping through this, and then we console log out our star vertices array, and we look inside of this, well, now we have an array of 30,000 values, which equates to 10,000 stars because each star has an X, a Y, and a Z. And these are perfect because we can go ahead and insert these into our star geometry position attribute. So to add these to our star geometry position attribute, what we're going to do is we're going to select our star geometry, and we want to set its attribute. What attribute do we want to set? Well, it's position attribute. And what are we actually going to populate this with? Well, a buffer attribute full of float32 values. So we need to basically translate this into float32s. And we also need to make sure that it is a 3 buffer attribute, something that can actually be read by the set attribute function. So Three.Js offers a nice function in which you can use to populate this second value with a buffer attribute and float32 values. So we're going to go ahead and call a new 3.float32 buffer attribute, and this goes ahead and takes two arguments. One is going to be the data values we actually want to push into this, the actual array we want to translate into float 32 values. That is going to be our star vertices array, so we're going to go ahead and put that in there. And then within this array, how many groupings of values make up one vertex? Well, that is going to be 3, because we have an X, a Y, and a Z. So for every 3 values within this array, we're going to know that is equal to 1 position grouping. So we're going to go ahead and save that. And now if we go ahead and look inside our buffer geometry, our attributes, position, array is now full. It has a count of 10,000 stars, which we populated right here. We have an item size of 3, which we called right here, and things are looking good, so we can begin rendering this on our actual scene. You'll see nothing just yet if I go ahead and look around, but we are getting there. Now that we have a star geometry populated with positions and a star material ready to go, we can go ahead and combine these into a points object. So what I'm going to do is create a const called stars, and this is going to be equal to a new 3 points object. And the first thing this takes, it's going to be the same as creating a mesh. It's going to be our star geometry, the geometry we want to use, full of all the positions. And then the second thing this takes is going to be the material. So star material, which is just going to color these points white. So we have our stars mesh, our points object per se. Now we just need to add this to our scene. So I'm going to select our scene and then just write add. And we're going to add in the stars points object. So if I go ahead and save that, and then I begin looking around, you'll see we just added all those stars to our scene. All those vertices are colored in as white, and they're all going to be randomized no matter where we look, because we set them equal to any range on every axis from -1000 to 1000. And make sure you guys can see this a little better. Let's go ahead and full screen this. You'll see now we have stars populated all around us, and as we begin to orbit around, there is no lacking of stars anywhere. So that is how you're going to create a star field. But how do we actually get that rotation effect that I showed you in the example? Well, this is going to be really easy. If you remember creating that cube that we created in the very beginning, we went into our animation loop and we just set its rotation to increase over time, and it began rotating towards us. We're just going to do the exact same thing for our points object because it consists of all the points, and we're just going to be rotating from the very center of them. So if we go to the bottom of our animation loop, which is going to be right about here, we can go ahead and begin rotating our stars object. So we're going to select stars, specifically its rotation on the x-axis, so that way it starts rotating towards us or away from us, either one. And we're just going to be adding on a value over time. And this is going to be a small value so things don't go too quickly. We don't want to get dizzy. But if I go ahead and do this, you'll already see this one in front of us is beginning to move. It's pretty quick already. And yeah, there's a kind of warp speed effect. This planet's moving really quickly. It's kind of giving me a headache personally. So I'm going to go ahead and decrease this to 0.001. It's going to refresh, and now if I go ahead and look down, you'll see that is a lot more manageable. It might even be a little too quick for you, and if it's too quick, you can just simply add on a 0 to the beginning of your number, and then start affecting the end number to your liking. So now, if I go ahead and look at that, I would say that is something that I am happy with. We're going to go ahead and take care of text animations on load next, so I'll see you there right now. So we have our stars in our galaxy, but now it's time to start animating our text, specifically when we load our page. So if we look at the example piece, you'll see over here, whenever I reload the page, we have some sort of animation taking place. We're going to do the exact same thing for our text over here, except we're going to do a little bit of a different animation from what we see on the example piece. We're just going to do a fade in and a translate upwards. So to begin this animation, what we're going to do is head on over to index.html, and we need to set the default state for this text. So what does this text look like before we actually animate it? Well, if we want to do a fade in effect, well, this text is not going to have any opacity. So to give this an opacity of 0, specifically each text element, what we're going to do is find that element within our HTML. So Christopher List equates to this over here, and we're going to give it a class of opacity 0, and just by doing that we set the default state for that text. As you see, it is no longer there. We're going to do the exact same thing for our other text as well that we'd like to animate, so our paragraph text and then also our button right here. All of those are going to have an opacity of 0. We can't see them, but If we inspect, they're still going to be on the screen. It's just that they are invisible with the opacity of 0. So how do we actually begin animating these? Well, we can do one of two things. We can either animate these in with CSS, or we can animate these in with JavaScript. So I am actually better at animating these in with JavaScript, so that's the method we're going to do. But if you'd like to take this and add in CSS animations instead, you're totally more than welcome to do that. But to add this in with JavaScript, we're going to go over to main.js, and we're going to be using GSAP, the de facto library for creating animations with JavaScript. So to make use of this and begin animating in our text, I'm going to go to the very bottom of our file, and here I am going to call GSAP2. So what element do I want to animate in? Well, if I look within index.html, the element I want to select is going to be an h1. So we'll go ahead and select the h1. And then for the second argument here, I need to add in an empty object that specifies what properties do I want to animate. Well, I want to animate our opacity property, and I want to send it back to 1. So with this, you'll see now our text is visible again, but we didn't really see any animation. And that is because the default duration of GSAP's 2 method is way too quick for us to actually see. So if we go ahead and add a duration of, let's say, 2 seconds instead of the default, which is around 0.75, you're going to see that it fades in very nicely. But one issue here is we are selecting an h1 tag with GSAP2, but there might be other h1 tags on the screen causing conflicts within this animation. So what we can do is within index.html, we can go ahead and add an ID to our h1 class to give it a little more specificity. So what is my ID going to be? Well, I know this text probably isn't going to change, so I'm just going to give it an ID of Christopher Liss, my name, the text inside of it. And now that I have an ID right here, I can select that ID within GSAP2 by indicating I want to select an ID with the pound sign and putting in the ID that I labeled the tag with. So if we go ahead and save this, we still get the same effect, but we have the specificity in place. We know that this is the only element that is going to be animated in. So let's go ahead and do the same thing for our paragraph tag. If I want to go ahead and animate this in, I'm going to give it an ID. I'm just going to start with the text inside of it, one with n. I'm going to save the file, go back to main.js, and then I can just duplicate this code. And instead of animating in an element with the ID of Christopher Liss, I'm going to animate in an element with an ID of one with n. We're going to get the same effect for a paragraph text. Now I want to challenge you to do the exact same thing with this button element right here. So pause the video and see if you can get it to animate inwards using GSAP. So to get this button to animate inwards, I'm going to go ahead and give it an ID of view work button. Now that I have an ID, I can go ahead and duplicate this code and just make sure I'm selecting the view work button. And that is going to fade in as well. Now this is looking good, but we can do a little more to make sure that this is looking as professional and clean as possible. So something I like doing to my animations is adding in a stagger effect. So the animations occur in sequence. We're going to be fading in our name first, the paragraph text second, and then the button third. Creates for a nice little waterfall effect. So to do that with GSAP, we know we want this animation to occur first, so we're going to leave it alone. The second animation, our paragraph text, if we want that to come after the first one, not at the same time, we're going to add in a delay property. How long do we want to delay this by? Well, to start, we'll do 0.3 seconds. You're going to see that comes in a little later than Christopher Liss up here. So that is looking good. But let's go ahead and add another delay to our view work button. We don't want this coming in at the same time as a paragraph text, so we're going to extend this to a delay of 0.6. Now you're going to see it fades in with that nice little waterfall effect, so looking good. Another animation we might want to add to this is a translate effect. When combining a translate effect, basically moving the element along with some sort of opacity, you can get for a really clean looking animation. So to add in a translate animation, we're going to go back to index.html, and we need to set the default translate for each of our tags. So the default translate for h1, I'm going to declare with a style tag. I'm going to set a transform property equal to translate y. How much do I want to translate the y value of Christopher Liss? Well, I'm going to start with 30 pixels, which is going to push it downwards. Make sure you don't include a semicolon within that. So if we push that down by 30 pixels, you can see our text is now overlaid on top of the paragraph text, which is actually perfect for the default state. So what we're going to do is we're going to translate this back to its initial state, which was up here. To do that, we're going to go over to main.js, and we know we are animating the opacity back to 1. But if we want to animate the y position of this back to 0, all we have to do is add in y, and then 0, and that's it. So hit save, you're going to see this translates back to its original position. Let's go ahead and do the same thing for our other two elements. We need to set their default state, so we're going to take the style attribute with transform translate y 30 pixels. We're going to paste it on to each of the elements we want to alter. So our paragraph and our button, it's going to push them down, but now we want to animate them back to y0. So over in main.js, we're going to take y0 for the first element, paste it within the second. That is going to animate the second element with a little bit of delay because we still have that on there. And then if we want to add it to the third one, now we have all three with a translate animation, so perfect. Now if we look at this animation, we have the core there, but it's not looking very professional. It's slow, and it just doesn't look natural to the eye. If you want something to look natural to the eye, you have to use what's known as easing. If you start off an animation very fast and begin to decelerate over time, that is what's known as an ease out. But if you start the animation off really slow and then end it while going really fast, that's what's known as an ease in. So if you ever have text appearing and translating, you want to make sure that it is decelerating over time to create something that is natural to the eye. So we're going to be using an ease out effect to achieve that. So within GSAP, we can simply add in an ease property. And this takes a list of different eases that GSAP provides. How do we find that list? Well, we're going to open up a new Chrome window and just search for GSAP ease. The very first result is going to be an ease visualizer. If we click that, we're going to get a list of eases that GSAP provides. So the one we're going to want to use is Expo, and it's just something that allows us to start off very fast and then slow down over time to create a large amount of deceleration, something that just looks very natural to the eye as our text appears and puts itself into place. So since we know we need to use Expo as our ease property, all we have to do is type Expo. So if we add that in, save. Now our first element is going to have an Expo ease, specifically an ease out, because every default ease that GSAP provides right here is going to start out with an out ease. If you would like to use an ease in, all you have to do is put .in at the end of your ease, and you're going to get an ease in animation instead, as you see right there. Just a little different effect. But it's pretty standard to go with an ease out for these scenarios, so we're going to keep it as Expo ease out. Let's go ahead and add an ease to our other elements, specifically Expo. We're going to add that on, and that is looking a little better in my opinion. You might not notice it, but the deceleration is definitely there. We can tweak this a little further to make it look better with the ease by affecting our duration property. So right now this is looking pretty slow, not that natural to the eye. If we want to go ahead and speed this up, we're just going to decrease our duration by something like 0.5 seconds. So if we go ahead and do that, add 1.5 for all of our durations, you're going to see that happens a lot quicker and it looks a lot more natural. And I think that this is something that I really like, something that I'm going to go with for the final version of this animation. So if you really want to get a good glimpse of this, see how it really looks, I recommend going to full screen, refreshing, and you can see exactly how that looks. So in my opinion, it looks really good. I like it a lot, and that is what I'm going to choose for the final version of this animation. So play around with the GSAP settings, see what kind of animations you can come up with. Up next, we're going to be doing the effect where if you click on the button right here, we create this little star bolt effect that takes our camera and goes into the galaxy. So I'll see you in the next episode right now. So we have our intro animation on load, but if we look at the example piece, how do we actually get this effect where when we click the button, our camera rotates down and then it begins to shoot towards all the stars until it fades into the next page? Well, let me show you. So the first thing we need to do, looking at our piece, is we need to make sure that this view work button activates some JavaScript code. So how do we make sure it activates JavaScript code instead of just simply going to a different website? Well, the very first thing we're going to do is select our button in JavaScript. So to select it in JavaScript, we're going to do document.query selector, and then what element do we want to select? Well, simply the element with the ID of view work button, because that pertains to our button over here. So we can simply select our ID of view work button, now that we have it selected with JavaScript, we can add an event listener. The first argument here is what event do we want to listen for? Well, this is simply going to be a click event. We want to listen for when a user clicks on the view work button. And then what code do we want to call once a user clicks on this? We need an arrow function. We're just going to console log some code. So with this console logged, let's go ahead and open up our console and then click the view work button. If you notice, for a short moment, our console log actually showed, but we're still redirected to our external link. Well, to prevent this, what we can do is within our callback function is we can pass through an event object. We can either call it event, or we can call it E if we want to be succinct, short, whatever you call it. And then we can call e.prevent default. We want to prevent the default action of whatever element this is. If we look at this element within index.html, scroll down a bit, it's going to be an anchor tag. What is the default action of an anchor tag? To go to whatever href is set to. So we click on anchor, and we're going to go to this link, but we don't want that because we want to make sure we're activating an animation first. So we're preventing the default event from occurring. If we go ahead and add this in and try clicking view work again, you're noticing we're not going to a different page, but we're still logging out our code inside the callback function right here. So that's taken care of. But now when we click this button, we actually want to fade out all of our text. So we can fade our text out in two ways essentially. We could either just grab all of our text animation right here, paste it within our callback function, and just set its opacity to 0. But that's a little sloppy because we're selecting each text element one by one. We're doing it right here to create a stagger effect. But if we just want one fade out animation for everything, we can go ahead and add an ID to the containing element of all of these. So we're going to go into index.html. And what is the containing element of all of our text and our button? It's going to be this div right here. So there's no ID on it just yet. We want to make sure we're selecting it specifically. So we're going to add on an ID. We're just going to call this container. Simple enough. So once we add an ID of container, we can go back to main.js. We're going to call gsap.to inside of our callback function. What elements do we want to select? Well, our containing element. So pound container. And then what properties do we want to animate? Well, simply our opacity. We're going to animate it down to 0. So just by adding this in and then clicking view work, you're going to see all of our text fades out. That is perfect for the effect we're going for. So what's up next over here on the example? We click the button, text fades out, and then our camera goes down and rotates, and then eventually it bolts into the stars. So what we want to do is we want to make sure after our text fades out that we are pushing in the camera closer to our plane. So to animate our camera position, let's go ahead and look where our camera position is right now. We're going to search for camera.position. By default, our camera is positioned at a Z of 50. So we're basically moving the camera back within our 3D space so we can view more of the plane over here. We want to make sure when you click the button, we're animating this Z to something like 20 or 30. That's going to push the camera closer to the plane and create some sort of movement effect. So we scroll back down to our callback function. We can add in another gsap2, but this time we're going to select our camera, specifically its position, and then of this position property, what property within it do we want to animate? It's going to be the Z position. What do we want to animate to? Probably something like 20, 30. We can even go 25 right in between those. So we're going from 50 to 25. If we click view work, you're going to see that we are indeed zooming in. This looks like a good distance to zoom in on. Let's go full screen it, click view work. We're zooming in, but it's not really much of a natural effect. It's kind of linear. When I click view work, the camera movement's kind of linear and it doesn't really add any acceleration, deceleration that we want when creating some sort of natural movement. If you want your piece to look as professional as possible, you got to make sure that these movements are looking natural. So what we want to do is add an effect of acceleration and then deceleration. So our camera's going to start off slow, start accelerating, and then once it reaches the end of its position, we're going to slow down, creates a natural movement effect. And to add that, we want to add an ease. We're just going to call expo again. And now by default, expo is an ease out. So basically we're starting off fast, slowing down. We don't want that. We want to make sure that we're starting off slow, accelerating, and then slowing down. So that is going to be a combination of ease in and ease out. And to specify that with gsap, we can add a dot in out property. So this is just accelerating and then decelerating near the end of the animation. If we add this in, click view work, text fades, and we zoom in really quickly, so it's kind of a little too quick at the moment. We can go ahead and slow this down by adding a duration of 1.5 seconds. Should slow it down pretty good. Click View Work. And that is looking pretty good, I think. If Expo is a little too harsh for you, you can go ahead and use an ease. That is a little toned it down. This is an ease that GSAP provides within the ease visualizer, Power 3. It's a little softer than Expo. If we click View Work, you're going to notice that it definitely has more of a soft effect. You can play around with the eases and durations to get something that you like. I like Power 3, it looks good to me. Let's go with that. So now that our camera is pushed closer to our plane, what we need to do now is rotate it upwards. So we're going to call another GSAP animation, GSAP 2, but instead of editing our camera's position, we're going to edit our camera's rotation. What axis do we want to edit for our camera rotation? Well, this is going to be the x-axis. We just want to rotate it upwards. So we're going to select x. Now, by what value do we want to rotate our camera by? You might think degrees, and putting 90 here would rotate it by 90 degrees, but this value is going to be in radians, so we have to do a little bit of math. So if we think to ourselves, what is 180 degrees equal to in radians? Well, that is going to be equal to 3.14. What number is that? Well, that is going to be pi. So if we divide 3.14 by 2, that is going to be equal to 90 degrees, but in radians. Let's do this math real quick. 180 divided by 2, 90. 3.14, which is equal to 180 degrees, divided by 2, 1.57. So we're going to rotate our camera rotation on the x-axis by 1.57 radians, and that should get it looking upwards on our plane towards the sky. Before we actually call this, we're going to add in the same ease and duration, because we want to make sure that these are occurring at exactly the same time. And when we add that in View Work, now we have our rotation animation paired with our position animation. So looking really good here. The very last thing we need to do is actually have our camera bolt towards the stars. So all we have to do is edit our camera's position one more time. So we're going to select this code, paste it beneath our other animations. We're editing our camera position, but this time we're not editing the z-axis because our camera would just go through the plane. We're now looking towards the y-axis, so we need to make sure we are increasing the value of y over time instead of z. And 25 is just going to move us a little bit across the plane. We really want this to bolt all the way across the stars to wherever they are spawned. So we're going to change this to 1000. That's going to send it super far over time. And you might think using an in out here makes sense because we need to make sure that we are accelerating, but it doesn't really make sense to decelerate if we want some sort of warp speed effect into the next page. So if you want to get rid of the deceleration, we're only going to call an ease in, which makes sure that we have the acceleration, but there's not going to be any deceleration at the end of the animation. So if we go ahead and save this and then click View Work, you're going to notice that animation looks close to what we want, but we don't really get any breathing room of actually being able to look at the stars. So to make sure that these two animations occur before this one right here, we want to make sure that we add in a delay. We're going to delay our animation by the time these two animations fire. This is going to be delayed by 1.5 seconds. We refresh just to make sure everything's loaded. Click View Work. That is looking a lot better. Let's watch that one more time. So we pause for a little bit down here, and we start off slow and we start getting really fast till we reach the end. Now something that I don't like that much is this animation is happening a little too fast, the rotation and the initial zoom in. So if you want to change that, you just simply change the value of duration right here. I'm going to slow it down a little bit, slow it down to 2. And if I slow this down to 2, I have to make sure I'm changing my delay to 2 as well to make sure that the animation finishes initially. So test this out one more time, View Work. We have that initial look down animation, and eventually we are bolting through the stars. We can even speed this one up a little bit because this occurs after the fact. Make sure we have some sort of warp speed effect. And that is something I think that's really good. So that's going to take care of the bolt animation. Next up, we need to make sure that we're actually changing our URL and going to a different page. That is going to come in the video after the next one. The next video, we're actually going to make sure that we take care of the mobile responsiveness right here. We need to make sure that this works on all browser sizes, mobile, or whenever a user edits their screen, or else they're just going to be like, what the heck is going on whenever we actually resize the browser. So we're going to be taking care of that, making sure your plane looks good across all scenes. And then, finally, when you click the View Work, We're going to transition you in the next page. I'm going to show you how to set up the exact framework for that to make sure you're getting a new URL and you're actually transitioning all your elements into a completely new scene. So stay tuned and I'll see you in the next episode right now. So looking real good with everything, but you might have noticed when we try resizing the browser, well, the scene doesn't actually resize with it and we get some weird resizing on our text. How do we actually fix this? Well, let's start off with the 3D scene first. So in order to make sure that our scene in the background is resizing with our browser, we're going to want to add an event listener into our main.js code. So at the very bottom of our file, what we're going to do is add in an event listener. And what event do we want to listen for? Well, this is being put on top of the window object whenever the window resizes. Just resize here. Whenever the window resizes, we want to call the following code inside of this arrow function. So if we console log out, resize right here, open up the console, and then begin resizing, you're going to see every instance in which we resize the browser, we're logging out the text resize. So perfect, but that is not achieving our goal. Though we have a listener for resize on the window, well, our Three.Js background still isn't resizing along with it. This is where we need to set the code to resize the background. So how do we do that? Well, if you look at the very top, we created a renderer, and basically the renderer is a representation of a canvas object. If we inspect our DOM over here, you're going to notice we have this canvas element in place, and this is what's rendering the Three.Js scene. And when we look at that in the JavaScript realm, well, the canvas element is really part of the renderer right here. So what we want to do is use renderer's setSize function to make sure we are resizing the function every time we actually resize the browser. So we can go ahead and take this line of code right here, renderer.setSize, inner width, inner height. Let's go ahead and copy that and go back down to our event listener, and we're just going to paste it in. So what's happening here, we are selecting our render, basically our canvas, and then we're setting its size equal to the window's inner width and inner height, and these are computed dynamically, so whenever we resize our window, we are getting a new inner width and inner height. So let's go ahead and save this and watch what happens. So now we have this resize code in place. When we begin resizing our browser, well, you'll see the canvas is resizing along with it, so looking like we solved the issue. But one issue here, if we go ahead and resize this to be a bit smaller and then we start expanding our screen, if you look really closely, you'll notice things start becoming stretched out. This isn't the same aspect ratio we had as when we first initialized this scene. So how do we make sure the aspect ratio is being updated along with the renderer's size? Well, let's go ahead and look where our aspect ratio is being set. I believe that was with our Three.Js perspective camera. You'll see our aspect ratio is being set right here. Whatever the inner width is divided by inner height, that is going to give us the correct ratio to render everything on the screen in the correct format to make sure it fits the window. But this aspect ratio is only declared once, and that is when we first create the perspective camera on load. So we need to make sure that we select our camera and then update its aspect ratio whenever we actually resize the screen. So back to our event listener. Before we actually set the size of our render, we're going to select our camera and select its aspect property. And let's go ahead and see what's inside of this, just so we know what we're dealing with here. If we go ahead and console log out, camera.aspect, open up our console, you're going to see that this is our current aspect ratio, but we need to make sure we are updating this whenever we actually resize the screen. So all of our resize code is happening right here. What is our new camera aspect going to be equal to? Well, the same thing we set it to initially, just with the new inner width and the new inner height code. So we can simply take our inner width divided by the new inner height, and this is going to give us the perfect aspect ratio to make sure everything on our scene is rendered correctly in the correct aspect ratio. So if we save this, start off small just so we can really see the effect. Let's see what happens. We start resizing, and it doesn't really look much different. It looks like we're still getting that long stretched out effect that we were trying to fix earlier, even though we definitely are updating our camera's aspect ratio. Well, even though we are updating the aspect ratio, we need to tell Three.Js that we actually updated a camera property. If we don't tell Three.Js that we updated camera property, it's just not going to take this into effect. So in order to tell Three.Js that we updated its camera property, we're going to select our camera. We're going to call a method called update projection matrix, and this is a function. Make sure you add the parentheses at the end. And if we save here, and we're going to start off small again, refresh, and start resizing, you're going to see now it's maintaining that perfect aspect ratio because we declared our camera aspect to be equal to the new inner width and inner height, and then we're making sure we are updating our camera to display the new ratio using this method, update projection matrix. And finally, we are setting the size of our render with the new inner width and the new inner height. And if we use all of those together, well, our scene is going to resize with the correct aspect ratio and with correct size no matter where we drag it to. This is going to work on mobile as well. It's going to look good on mobile because it's going to be on a smaller screen, and even if it changes, it's going to update along with you. Now, one more thing I want to do before ending this episode is, if you look at our text right here, this is a little sloppy, I would say, for typography purposes. Everything's just stacked on top of each other, and there's really no structure here. Let's go ahead and fix the HTML and CSS for this so that it's on 2 to 3 lines, maybe 4, rather than just stacking on top of each other. So in order to fix this, we're going to go into index.html, and we are going to look for our paragraph tag, which consists of all this text, and we need to inspect to see what is going on here. So if we inspect our paragraph text, let me go ahead and take this off in a separate window just so we can see things. So if we go ahead and inspect this, well, that is looking like it has a width of 250. Let's go ahead and inspect the container because that is what's going to determine the overall width of everything inside of it. If we look at the container has a width of 250 as well. But really, there's no max width or width value set here, so everything's just being compressed down into its smallest state. If we want to increase the width of this container, what we can do is add in a tailwind class that gives us a max width. So if we add in a class of max width, max-w, and then something like 2xl, that's an extra large max width times 2. Go ahead and add that in. Not going to see anything. We can't really see the max width taking effect. But now that we have this max width in place, we can go ahead and give our container a width of 100%, which means it's not going to take up 100% of the screen, but rather 100% of the max width, which is max width 2xl. And you can see right here that class is taking effect. We're giving our container a max width of 42 rem. You can't really see this taking effect here because it's still touching the side of the screen with a width of 100%, but if I go into full screen this, you'll see that our max width is preventing this text from just going from the left side of the screen to the right. So let's see what this looks like without the max width, just to help further clarify how this works. If we go ahead and take this class off, you're going to see our text expands to full width of the screen, essentially. We don't want that. That's just poor typography because it makes our eyes move a long distance from the left side of the screen to the right, rather than reading this like a book. You want to make sure that your typography is read like a book to prevent eye strain and annoyance on the user. So we know, let's go and refresh this so we start fresh. Within our code, we want to edit the container. Everything looks good right here, but as soon as we set it to width full, which is a width of 100%, well, our text now expands the full width of the screen. We want to prevent that from happening. So we're going to add in a max width of 2xl, which is going to be a max width of 42 rems. It's going to put it back to its original position where things are on 2 lines. But if we start to size down our screen now, you're going to see that since we added those 2 classes, we're not getting that big stack of text that we got initially. We need to make sure that our container is taking up the full width of the max width we actually set for it. Now, one last thing here is this text is touching the edges of the screen, and that's a little sloppy for any web development. You always want to make sure that you give your text breathing room. So this is really simple. We just want to make sure that we add some padding to this container on the left and right hand side. So we're going to add in a class of px, and typically I like doing px6. That typically gives me ample enough padding to where there's enough breathing room on left and right for both mobile and desktop. And you'll see right here, now we have a px of 6, so things are stacked, but we still have breathing room on the left and right when needed. So this is looking really, really good. I'm pretty happy with the mobile responsiveness of this. You can click the view work button. Everything still functions as expected. So it looks like all that's really next is making sure that when we get to this point right here, where we bolt into the stars, that we change the URL and we transition to the next page. So I'm going to show you how to do that next. It's going to be a little bit of a longer video, so I hope you're ready, but stay tuned, and I'll see you there right now. So to finish off the basics, when we click the View Work button and we delve into the stars, what happens next? How do we go to the next page? Well, let me show you. So to go to the next page, we're going to be inside main.js, of course, and where we just created all these GSAP animations, specifically for the camera to send it into the stars. This is where we're going to basically say, wait until these animations are done, and then switch the page URL using JavaScript. So to do this, within our final animation, we have a couple animations here. We know this is the last one. One, because it's last in line, and two, because it has the biggest delay property. We know this is the last animation that's going to occur. Our camera is going to be shooting into the stars. So when this animation completes, we want to run some sort of code. And we could say within GSAP, we can add in a property called onComplete and set this equal to a simple arrow function so that whenever this animation completes, we can run some code inside of this. You can test this out simply by console logging out whatever text you would like. We're just going to console log out to test. We open up the console and then, let me resize this for y'all. We click View Work. We're not seeing anything, but once we reach the very end of this animation, we're going to get the text test because we're calling console log when this animation completes. So here, to switch the URL to something else once we reach this point in time, we can simply call our window object and specifically its location. We want to set this equal to the URL we want to go to. So say this is my portfolio site or something like chriscourses.com, or I just want to lead you to chriscourses.com for whatever reason. I can simply go ahead, visit my URL, copy it directly from the browser. I'm just going to exit out of this now that I have it, and I'm going to set my window location equal to a string that is equal to the URL I want to go to. So https chriscourses.com. Now, if I save, and I try this again, hitting the View Work button, you're going to notice once we reach the very end, I am redirected to chriscourses.com. If you want to switch to URL, in JavaScript, all you have to do is set the property of window location to whatever URL you want to go to. So that's pretty much all there is to it for switching the URL, but there is one caveat here. Whenever you change window.location, you're going to be refreshing your entire page, which means you're reloading your JavaScript files, you're reloading any assets, any CSS associated with your site. So if you think about it, wouldn't it be better if we just didn't reload those things at all, and we just presented the content that we want to change, but we don't reload the JavaScript, and we don't reload the CSS? Well, it is possible using a single page framework like Nuxt or Next.js. So I'm going to be doing a little bit of a bonus series for you guys. This isn't going to be so much Three.Js, but I'm going to show you how to get this piece on a real world website. This is exactly how I would create this site for a client and how I would transition between pages to make things as performant as possible. So to show you all what exactly we're going to be building, this is a Nuxt.js version of the site we just developed. It allows you to do things such as transition to a different page URL without actually reloading all of your JavaScript and CSS assets. So when we click the View Work button, we're still going to go into the stars, but once we get there, we're going to create this really nice My Work transition. You'll see that we added in all these different work pieces that are supposed to represent our portfolio. And in addition, we are changing the URL. So if I were to visit this separately, just type in localhost 3000 work, you'll see we're still loading just this page. We're not actually going through that whole intro animation. Just so you guys see that one more time, we go back to localhost, our homepage, we hit View Work. We're going to activate our animation, and then we're going to activate the next page animation because we are using a single page framework like Nuxt.js. No full page refresh, just reloading exactly the content we need, which is going to be these images and any content associated with them. So I hope you guys are excited. Like I said, this is exactly the process I use to create client sites. So stay tuned, and I'll see you in the next episode right now.
It's break time. Do you like this video? Don't forget to subscribe to get new videos. Share this video to open new premium videos and ebooks. We'll be a Starfreelancer.
So to create this Nuxt.js website with this seamless transition, we need to do a few things. We already redirected our user with window location in the last episode, so we can check that off. But now we need to integrate seamless transition with Nuxt.js, right? So the first thing we need to do is scaffold Nuxt with a command called npx create Nuxt app. That's quite a mouthful. So we're going to start just with this, and we'll continue along this to-do list so I don't overwhelm you with everything that we need to do to actually get this working with Nuxt. So let's go ahead and open up our terminal. So we know our current project is inside a directory called 3. We list this out. It's inside of my portfolio. We're going to be referencing this later, but essentially we need to create a new project to house this Nuxt framework. If you're unfamiliar with what Nuxt is, it's a single page Vue.js framework which allows you to create single page apps where the page never actually refreshes, but the URL routing and everything is still there. It also enhances the development experience a lot. You'll see exactly what I mean as we go through this, but for the time being, since this is a Nuxt project, I don't want to put it inside of my 3 folder. This is more for just pure Three.js projects. So I'm actually going to go back to my home directory, which is indicated by this little squiggly. I can also cd into that squiggly and still be placed in the same spot. And I want to make a directory, mkdir, called Node. This is where all my Node projects go. Technically, Nuxt is a Node app, a Node and Vue.js app. So we're going to go ahead and make that Node directory. I already have mine made. Just go ahead and hit enter. You'll see mine already exists. And then we're going to cd inside of it. So you'll see I already have tons of different Node and Nuxt projects inside of here. We're going to be making our own using this command right here, npx create Nuxt app. So I'm going to go ahead and start typing that in, npx create Nuxt app. And if you're wondering what npx is, this is essentially something that comes with npm, which allows you to run certain commands that can actually scaffold full apps for you. So if you have npm in Node, by default you're going to have npx, no worries. So we're going to run npx create Nuxt app, and then we want to hit space and indicate what is the name of this app. Let's go ahead and name it the exact same thing we named it within our 3 folder. It's simply going to be named my-portfolio, but since it's inside Node, it's indicating it's a Node Nuxt project. So Nuxt is going to present us with a few different prompts here. We can just go ahead and hit enter for project name. Our programming language is going to be JavaScript. If you're familiar with TypeScript, go ahead and select that. Our package manager, just to continue being safe, usually everyone has NPM as long as you have Node. Yarn is a good package manager, but not everyone has that, so we're going to select NPM. Our UI framework, this is more like what CSS do you want to use within your project? Well, we are already using Tailwind. We can just go ahead and select Tailwind CSS. We're scaffolding it up with Tailwind, Nuxt.js modules. We don't really need anything here, so we can just go ahead and hit enter. Linting tools, don't need anything here either. Testing framework, still don't need anything. Rendering mode, just go ahead and select universal, it doesn't really matter. Your deployment target. Server also doesn't matter. There's a lot of stuff here, I know. Development tools, we don't need any of this stuff either. Just go ahead and enter your GitHub username. You should put your username in here by default. It doesn't really matter. Like I said, we're just going to hit enter through a lot of this. Version control system, it's typically Git. It doesn't matter. So we're just going to go through this whole prompt process to create this whole scaffolding that's going to house our whole website. And by doing so, we're going to be able to transition between pages without actually refreshing everything using Nuxt and using Vue. So once that is done loading, it should have Node modules already installed. We can simply go ahead and change our directory to my-portfolio. And you'll see it gives us a little bit of commands. To get started, we want to run npm run dev. If we want to build our site for production, meaning we want to put it live on the web, then we are going to run these commands before we actually push everything up. But since we are just developing, we want to run npm run dev. And that's going to launch our Nuxt server. So while that goes ahead and loads, if you look over here on our to-do list, we scaffolded a Nuxt app with npx create Nuxt app. We can go ahead and check that off. And we also included Tailwind within that process because we selected it as our default CSS framework. So let's go ahead and see what this actually looks like. This is saying for me, listening on localhost 49790, and that is simply because I still have our other app running on the background on localhost 3000 over here. If you cancel that and run Nuxt over here, it's going to run on localhost 3000 by default. But since something is already occupying this port, it's giving me a new port number. Yours is going to be different. Just make sure you're visiting whatever is prompted within the terminal over here. So if I go ahead and visit this URL, you're going to see this is the default scaffolding for Nuxt. Not too pretty, but it'll allow us to create what we have over here and then transition to our separate page as we finish our animation. That's exactly what it's going to allow us to do, and it's going to make our development experience a bit nicer because Nuxt provides a lot of really cool things for making JavaScript code clean. So this is what our Nuxt app looks like. We're going to go ahead and open this up in Sublime Text. So something I do to open this up in Sublime Text is I have an alias called subble dot, which just goes ahead and opens up my whole project within a Sublime Text window. But I know a lot of you don't have that since that is completely custom. So if you want to open this up really quickly within Sublime Text, one thing you can do is type open dot. This is more of a Mac thing. I'm sorry for your Windows users out there. I'm not really sure the main command for Windows on this. But if you do open dot, it's going to open it up within your Finder. And you can simply grab your folder right here and drag it on top of Sublime Text, and it's going to open up. And then you can begin developing. So now that we have this opened up in Sublime Text, if we want to edit the contents of our home page right here, we're going to go inside of this pages directory that was scaffolded for us by Nuxt. So index.view represents everything we see right here. We don't need any of this because we're going to be changing it to look like our Three.Js homepage over here. So if we start deleting stuff, such as our logo component, you're going to notice that this auto reloads and it gets rid of our logo. And we can just go ahead and delete everything in here until we have just one root div. So the nice thing about Nuxt.js is it includes your CSS, your JavaScript, and your style tags all in the same file. If you were taught classically, this is not the way you're probably taught. You're probably used to having your JavaScript and CSS in a separate file for a separation of concerns. As things begin to modernize, a lot of people found that that actually makes things a little more confusing to develop with because you have to keep jumping between files to really understand what is styling what HTML and what JavaScript is actually affecting which interactions. It just made things really confusing. So what people started doing was putting their HTML, JavaScript, and CSS in the same file to start making things a little more straightforward. You don't have to jump between anything. You can see your markup, your functionality, and your styling all in one place. So it's really nice. So you'll see right here, this is some default styling that Nuxt provided. We don't need any of this, mainly because we're going to be using Tailwind. We probably won't even need to write any styles in the first place. But if we just have a blank view file right here, this is exactly what a blank view file looks like, by the way, we can insert in some HTML, and you're going to notice that it begins showing on the top left. So this is what our app looks like so far. Let's go ahead and look at our to-do list. The next thing we need to do is transfer over our HTML. So if we look, we have a bunch of HTML associated with our project, but the only HTML we have in our Nuxt app is FDSFS, not what we want. So here's what we're going to want to do. I'm going to go to Terminal, and we have to make sure that we're going to the right My Portfolio project. Right now, if I ls this, you're going to see this is the Nuxt project because we have things like an assets folder, a layouts folder, a components folder, and so forth. I can even type pwd, I believe it stands for present working directory, not completely sure on that, but you're going to see this is inside of my node folder. I want this open, but I also want open our old project that has all of our Three.Js code so I can begin transferring it over. So if I cd into my home directory, go inside of our 3 directory, list this all out, and then cd into my portfolio, open this up using my little alias. You can always do the way I just taught you, such as open dot, and drag it on Sublime Text. I'm going to subble dot. This is our completed 3 project. So like I said, we want to start transferring over index.html over to index.view so we can begin creating our homepage but using Nuxt. So let's start with just the template tag. We know that this consists of HTML. What HTML do we need to grab? Well, specifically everything within this div with an ID of app. So what I'm going to do is I'm just going to select everything inside of that. I believe it ends right here. You can either cut it out or you can copy it. I'm just going to copy it to leave this intact. And then over here, I can go ahead and delete our root tag and our h2, and I'm going to paste in all the HTML. So now that I've done this, if I look in the browser, I'm not going to see anything because we have a lot of text white. And remember, Tailwind here is still going to work because we scaffolded Nuxt with it. If we look within package.json, we have Nuxt, Tailwind CSS. Tailwind is already integrated within our project. So all of these classes are still going to work. But if I want to test that this text is actually showing up within the browser, I can simply right-click, inspect. You'll see that the text is still there, but we just can't see it, 1, because it's white, and 2, because we have a class of an opacity 0. So if I go ahead and get rid of opacity 0, and then I change our text color to something like black, we're going to see our text, which is off to a great start, but we don't have our animations, we don't have our Three.Js background, so it's really hard to see everything in place. I think this is a good start, but I think it's time to actually get our Three.Js background in there. So if we look within To Do, we started to transfer over our HTML. We're going to actually get to Google Fonts a little later. So what I'm actually going to do here is I'm going to move this beneath some of our JavaScript work because we need to make sure that JavaScript work is in place. One, so we can see the text because we need a blue background or something darker to actually see it. And two, we have text animations which are run with JavaScript. So I'm actually going to put this after all of our JavaScript refactoring. So let's go ahead and start that now. If we look at the list, we need to start transferring over our JavaScript packages. What do I mean by that? Well, within our new project, our Nuxt.js project, if we look within package.json right here, it comes with a few dependencies and dev dependencies by default. But if we go back to our original Three.js project and look within package.json, you'll see that it has a few dependencies that aren't available over here. Some that we installed throughout the creation of this project. We have dat.gui, we have gsap, and we have Vite. Which of these packages do we actually want to transfer over so our app actually works? Well, it's going to be dat.gui and gsap. We don't need Vite anymore because Nuxt acts as its own server. We just want to make sure that we transfer these two over. So there are two ways to transfer these packages over. One, we can install them with npm install again, but one issue with that is it might change the version that we have right here and our code might break in the process because one of those version updates might be a breaking API change. We don't want that. We want to make sure that we're using the exact same packages we're using within our original project. So to make sure we're using the exact same packages, all we have to do is grab these two right here and then paste them within our Nuxt project's dependencies object. And if you want to be as stringent as possible with your code, you can go ahead and make sure that these are arranged in alphabetical order. So if I grab these two lines, paste them beneath core.js like so, reorganize things a little bit, make sure you add a comma after each line except the last. Now we are going to be good to go. We're specifying that our project needs dat.gui and gsap to work. But since we added these here, they're not actually going to be installed. All these are installed inside what's known as a node modules folder. We don't see it right here because I hid it from Sublime Text because whenever I search for stuff, sometimes I search inside of those folders and there's so much stuff in there, it finds something that I don't want to look for. So I hid it from Sublime Text. But if I open this up in Finder, this is my portfolio, the Nuxt version. And just so this doesn't confuse you guys, I'm actually going to rename this. I'm going to rename this my portfolio Nuxt, just so we have a difference between our Three project and our Nuxt project. So I'm going to reopen that after naming it. We have my portfolio Nuxt and my portfolio. So back to Finder. As I was saying, these dependencies right here are stored inside of a node modules folder, which contains everything that these modules need to actually function within our code. Mine are just hidden. So we're saying our project depends on dat.gui and gsap, but they're not actually installed within node modules because we haven't run npm install. We need to make sure that we're running npm install to install the new packages we listed out within this dependencies object. So what you want to make sure you do is make sure you are inside the right directory. I'm going to open up a new tab. I'm going to cd into node and go into my portfolio Nuxt. Here I want to run npm install, and by doing so we're going to install dat.gui and gsap to make sure that our code works within our new project. And you'll see right here we just added in two packages. That was gsap and dat.gui. So that takes care of adding in the dependencies. Looking at our to-do list, you can go ahead and check these off. Now I included Three.Js here as an npm package, and you're going to see why very shortly. Let's go ahead and start transferring over our JavaScript. So we have this main.js file. You might think, well, let's go ahead and select everything with Command A, Command C to copy it, go back within index.view, and scroll down to our script tag. Well, can't we just paste everything in within the script tag? Unfortunately, that's not really how Vue.js works. And you might be getting frustrated. Well, isn't that the simplest way? Why doesn't it work with Vue.js? I don't want to use Vue.js. Well, Vue.js has some lifecycle methods in place that, while abstracting a little bit, which isn't always the most fun, it does allow for more control over your project, launching certain portions of code as your page loads at certain times. So one of those lifecycle methods is called mounted. We're going to add this within export default and this empty object. This is going to be a function. And basically, when all of our HTML on the page loads, we're going to fire whatever code is within this mounted function. So if I console log out, mounted right here, and we go ahead and refresh, visit our console, you're going to see we're getting a little bit of an issue with our code not loading, and this is because I changed our project name to My Portfolio Nuxt, and so it's trying to run an old instance of our project. I'm just going to make sure that I exit out of that completely, exit out of any confusing tabs that might be there. So we have this new My Portfolio Nuxt tab. So I'm going to run npm run dev just like we did before, and I closed out of our Vite tab, so now our Nuxt project is available on localhost 3000. That is the typical dev URL you want to use for your projects and things that Nuxt and Vite give you by default. So now if we visit localhost 3000, we're on our new project. We can inspect. All of our stuff is there. And if we visit our console tab and reload, you're going to see we're console logging out mounted when all of our HTML is loaded. So we know that this is indeed working. But remember, we want to put our JavaScript code in here when everything is mounted. So if we look within My Portfolio again, this is the Three.Js version, we're going to copy all of our code, Command A, Command C. We're just going to start by pasting it in within mounted. So once that's in place, we're going to see a lot of errors occur, starting with our import statements. So let's go ahead and scroll to the top. We have these 4 import statements. Whenever you are using an import statement, it has to be within the root of the script. It can never be within a function or an object or anything like that. That is just the way JavaScript works. So we're going to move these out of the mounted function and we're going to put them within our script tag. And that is going to be our first step towards getting this working within Nuxt. Now the very next error we occur is cannot resolve this package, which looks like our Three.Js package right here. So one unfortunate thing about Nuxt is it does give quite a few issues with trying to import a module using an external CDN URL like we're doing right here and right here. So instead of importing a package like this, we're going to want to import 3 and orbit controls using an npm package. That is why within our to-do list right here, I am also including 3. We just haven't done this yet at all. So going to package.json in My Portfolio Nuxt, we need to make sure that Three.Js is listed within our dependencies object. Let's go ahead and do this. So I'm going to open up terminal, and we're already within My Portfolio Nuxt. If I want to open up a new tab in the exact same location, all I have to do is press Command T, and now I can install npm install 3. The Three.Js package within npm is just called 3, so it's not Three.Js, it's not 3.js, it's just 3. So make sure you're installing 3 and saving it. Make sure you include -- save so it automatically goes in this dependencies object. We're going to wait for that to load. And once it's done, you're going to see package.json updates. And now we have Three.js installed. One thing you might notice though is this version is different than the version we are importing within our code. Like I said, versions are updating over time as authors update the packaging. And that might cause our code to break over time as well. So since our code is already all developed, we want to make sure that we're using the exact package we used to develop that code initially, which is going to be 0.126.1. We're going to go ahead and grab this version. We can go back to package.json. There are 2 things you can do here. You can either replace this version with the version that we copied from over here, so 0.126.1, or if you want to be super safe, you can go back to terminal and run npm install. We're going to install 3. At which version do we want to install? We're going to paste in the version 0.126.1 and make sure you include save in there, so we are saving it as a dependency. This is going to install. We look within package.json and now we have the correct version of 3, so off to a great start. So we no longer want to import 3 from this URL. We want to import it from simply our 3 npm package. And same thing for our orbit controls down here. You'll see that we are still importing from unpackage. We want to get rid of this initial URL and install from our 3 directory, which is inside node modules. We want to go inside of examples, JSM controls, and then get our orbit controls stored inside of this orbit controls object. Things should still work as expected. But if we hit save, our page is going to refresh and we're still getting some sort of error. So when you're using the NPM version of 3, it's going to expect that you import things in a very specific way. So more refactoring, but this is indeed the best way to do things if you want to be as strict as possible with your code to make sure things don't break over time. So we're no longer going to be using this big 3 object that contains all these methods and properties like we were doing earlier. We're actually going to be importing in each of those methods and properties manually as we begin using them. So to do this, we can go ahead and hit Command F and search for 3. This is the big 3 object that we're currently using to call things such as a plane geometry. Well, we no longer can use 3. By importing things this way, so we need to call plane geometry directly, but we can only do this by importing it through our 3 library directly by indicating we want to use this plane geometry method right here. So it's a little cumbersome and tiring to have to refactor our code like this, but now our plane geometry method is definitely going to work. We want to make sure we're doing this for pretty much everything that has a 3 associated with it. So to speed this up, what I like doing is I like opening up a new tab. I'm going to create just an empty object, and I'm going to start searching for 3. Anything that has 3 in front of it, I want to make sure I delete the 3. I grab the method or the object instantiator, and I'm just going to paste it within this empty object. So we have buffer attribute. We see another 3 right here. We're going to grab the raycaster, add it in, make sure you add a comma after each of these. We have a scene, and then we have a perspective camera. So we're going to put that in there as well. Let's keep going. We have a 3 WebGL render. And as I do this, you'll notice our code is beginning to clean up because we're getting rid of these duplicate 3 It does clean up your code a little bit if you want to take some sort of solace in doing this annoying refactoring. So we have our plane geometry. We know we imported it at the very top of index.view, but we don't have it within this empty object. So I'm going to add it to the beginning, plane geometry. Make sure we add a comma to the end. Now we have a mesh falling material. We don't have that. Let's add it to the end of our object. We have a double side property. We're going to add that in. A 3.flat shading property. We have a 3 mesh. We don't have that. Let's add it in. And then we have a directional light. So comma directional light. We know we already imported directional light up here, so we don't need to do it again. We'll just get rid of 3. Do we have a buffer geometry? Well, let's check. Command C, Command F, buffer geometry. Nope, does not look like we have a buffer geometry within this object over here, so we can simply get rid of 3. Copy buffer geometry, comma, buffer geometry. Do we have a points material? I don't believe we do, so we're going to go ahead and take this, comma, points material, and I think we're getting near the end. I know we don't have a float32 buffer attribute, so we're going to go ahead, put that in there too. We can get rid of any console logs while we're at it, clean up our code as we go, make things look really nice. We don't have any points, we just have points material, but points is separate, so we're going to add this in as well. And it looks like that is it. So these are all of the Three.js methods, objects, instantiators that we're using within our code. So since we created this object, we can go ahead and cut this out of place, and we are going to make sure that we are importing all of these from Three.js. So we're going to get rid of what we had initially and just paste in this new object. It should look something like this. So these are all of the things we're importing from 3. So that's going to take care of one of the errors, but we still have the syntax error over here. If we refresh, cannot use the import statement outside a module. So let's start debugging and see where this error is coming from. Let's go ahead and comment out orbit controls. We save. You might have to refresh manually since we have an error right here. And it does look like that is where the error is coming from, at least for that. So let's focus on orbit controls first. If you're still getting this error, it's because we're trying to import a JavaScript module using Nuxt.js. Unfortunately, sometimes it gives you issues like we are seeing right here. So to use orbit controls with something like Nuxt.js, we're going to use a different NPM package. We're going to actually Google this one so I can show you the process of finding these packages and installing them. This package is going to be called orbit controls ES6. We're just going to go ahead and Google that. And it's going to be the very first result at npmjs.com. So to install this package, we're going to run this simple install code right here, go back to our terminal, and just paste it in. Make sure you run that. So by importing orbit controls this way, we're importing them in a very specific format, ES6, which allows us to use things such as this import statement, because the old way of importing packages is using something called require, which looks a little something like this. So if we were to import orbit controls using require, we'd have to create a constant called orbit controls and set it equal to require, and then something like orbit controls. This is the older way of importing things, but as JavaScript continues to improve, there are new syntaxes in place to make our code cleaner and easier to read, including the import statement. So this ES6 indicator indicates we should be able to import orbit controls using the import syntax. So we're no longer importing orbit controls this way. If we look within package.json, that code just ran and we installed orbit controls ES6. So we can just follow this example over here. We just simply import orbit controls from this new package. We're going to replace our old import right there with this. We save, we go back to our project and refresh, and that got rid of that annoying error. Thank God. So we're slowly closing in on getting this thing to work within Nuxt.js, a real world app. The very last error we have to deal with is window is not defined. So some of these packages require the window object in order for them to work, and Nuxt.js is a server-side framework, which means it is actually rendering all of our content server-side and then presenting it to the front end. So things like SEO, Google, and all the search engines can get all of our data without requiring any async loading. That's a whole nother topic for another course, but just to give you a heads up, this is why Windows not defined, is because we're trying to import dat.gui on the server side. We want to make sure that we are importing this on the client side, and to do that, we can go ahead and use that old require import method that I was talking about. So we're no longer going to import dat.gui like this. We're going to go ahead and delete this line of code, but inside of mounted, we can create a constant called dat, and this is going to be equal to require. What package do we want to require? Well, dat.gui. We save, we refresh, dat.gui works, and what do you know? It looks like our background is now working, and we are in good shape right now. We finally got all that refactoring done, and this is working within Nuxt.js. So to summarize, we refactored 1 to appease to Nuxt.js's module importing style. As you can see right here, we're importing everything separately, and that's actually going to lead to good code because we're not accidentally going to put anything in here that we might not use. This gives us a nice list of all the things we're using from Three.js, and it cleans up our code a bit so we're not just spouting 3 dots all over our project. We added orbit controls using an ES6 module so we can continue to use this nice import syntax. And since dat.gui actually requires a window object, we want to make sure we are running it client side. And to do so, we have to run it within this mounted function. And we have to use the require statement here because you can never use an import statement inside of another function. It's just not going to work within the JavaScript realm. So looking at to do, we refactored our JS import statements. We did it with 3, we did it with orbit controls, and we did it with require dat.gui. So we're going to have to do a few more things with our JavaScript. Specifically, we're going to have to declare exactly what canvas do we want our renderer placed on. You'll see right now we are just appending a renderer to our document body, but that's not really going to work if we want to add in those nice seamless page transitions. So we need to make sure that we change that up. But once again, my ordering is a little out of place. This really doesn't matter until we actually create the transition to the next page. So I'm going to put this after we create our work page down here. The very next thing we're going to do is continue transferring over our HTML, specifically our Google fonts, to make sure that this matches up with exactly what we had within our initial Vite project. So let's go ahead and take a break, and I'll see you in the next episode right now. So our piece is working in Nuxt, but obviously our fonts don't match what we originally had. Why is that? Well, it's simply because we haven't transferred over the actual Google fonts. Those are pulled in through a URL, specifically from Google. We need to make sure that we include this within our Nuxt project. So we are going to continue to transfer over HTML, specifically Google fonts. And I'm going to show you how to do so with an NPM module, specifically a Nuxt plugin called Google Fonts. So if we go back to our project, to import fonts with Nuxt, well, how do you do that? If we look around here, there's no real section that acts as a header for our site, the place where we would normally paste in CSS files, JavaScript files, and so forth. So since Nuxt doesn't really use a header, they use a Nuxt config instead. And inside of here is where you can declare things that go inside the head of your file. you'll see right here we have a simple JavaScript object that specifies what our site's title should be, what its metadata should be, what its links should be, and we can also add in another property here for script tags, or we can also begin inserting style tags as well. All that would go within this head object. So obviously it's a little different than what you're probably used to with pasting these within the head tags of an HTML file. But the reason I want to go over this with Nuxt.js Google Fonts is because it creates a way for us to pull in Google Fonts that is much easier than having to visit the Google Fonts website, see what font we want to use, and then declare that through some long URL within a link tag. So let's go ahead and make sure that our fonts work using this npm package. So same deal as before, if we ever want to use some sort of npm package and we don't really know the documentation, how to use the package in the first place, what we want to do is we just want to select the package name. So Nuxt.js/Google Fonts, and we're just going to paste that into Google. Hit enter, and typically this is going to be the first result. So here it is. This is the package we want to use. It's made by the Nuxt.js community, as you see right here, indicated by @Nuxt.js. If we begin scrolling down, we're going to see how to implement this module. So if we want to add this to Nuxt, the very first thing we need to do is run this command. So we aren't using yarn, because yarn you need to do a little extra installation. We already know we have npm installed, so thankfully they give us a script for that. We're just going to simply copy this, open up a terminal window, and here we are inside our project, remember, and we just want to go ahead and run this. And while that loads, let's go ahead and check out the rest of this installation setup. So step 2, we need to add Nuxt.js Google Fonts to the build module section of nuxt.config.js. So if we look within our project, we know we have a nuxt.config.js file, and this is what I was just going over. Within this, we can set some configuration for build modules. We scroll on down, and this is our build modules section. These are basically plugins that are supposed to work in both development and the production side of things. So when you're ready to go live, that is called production. This module is also supposed to work there as long as our development server. So this is where we're going to say we want to use the Nuxt.js Google Fonts package. So if we want to make use of this, we're simply going to paste it in. You'll see we already have one for Nuxt.js tail and CSS, and that package was scaffolded for us as we went through the Nuxt setup process. So it's already there, already in use, but now we're just declaring we also want to use Google Fonts. So let's go ahead and paste it there. We're going to save this. Let's check on our terminal tab. Looks like that finished running, and we can always check to see if a package successfully installed by checking package.json and looking for that package. So in this case, the package was not installed. We didn't find it. And if there's ever an instance in which your package is not here, even though you just ran some sort of command, you need to make sure you are in the right directory, and I probably was not. So let's go ahead and check terminal. You'll see I'm actually in the My Portfolio Complete directory, which is the project in which I actually completed this whole thing for some sort of example. So this is not the right directory, not the one we want to be in. I'm going to exit out of this, and it looks like this one is the correct one, My Portfolio Nuxt. If I look over here, our project name is My Portfolio Nuxt. So looks like this is the right one. This is where we want to actually run the command. So if you need to run the command again, we're just going to select the code right here, plop it into our terminal, run it again, and we should be good to go. And remember, anytime you need to check to make sure that this was successfully installed, make sure you are checking package.json. You'll see as that just loaded in, it installed our dev dependency of Google Fonts at version 1.3.0. So now that this is in our package.json file, we can make use of it within Nuxt config, which means we can begin using Google Fonts within our site. Well, how do we choose which fonts we actually use? To understand this, we need to keep going within the documentation right here to see how this actually works. So we're going to go down to this options section, and this options section shows us how to import different font families into our website. So here you'll see they have a couple of examples. They're importing Roboto, Josephine Sands, Lotto, Railway at different weights and different italic weights. So it's a really nice way to specify what kind of fonts you actually want in your project, what weight you want them to be, and whether or not you want them to be italic. So if we want to make use of this options object, you'll see if we scroll back up, there's going to be some documentation to show you how to import Google Fonts with options. So we are doing the simple usage right now, which just consists of importing the simple string within the build modules array. Well, really what we want to do is we want to select with options. So we're going to select this array that has 2 items inside of it. It's going to have the first string, and then it's going to have this object, which basically specifies what kind of module options do we want. So if we're going to use the options version, we're going to get rid of this initial string, and we're going to paste in the array instead, and make sure you add a comma at the end of this. So now we have a place to put these module options. We can scroll back down to the options section, specifically families. Let's go ahead and just copy this whole families object. We're going to paste it right inside of this empty options object we just created. So if we were to restart our server, we should be able to use all the font families within here. But we know none of these font families actually exist within our project. What were the names of the initial fonts that we wanted to use? The things that we had originally within our Vite project. Well, if you ever forget, you can just go back to your old code and reference the font names. So let's go ahead and do that. I'm going to go ahead and open up a new tab, and I'm going to cd into my home directory and go into the bare Three.Js folder, and inside of here we have my portfolio. This is just the Vite Three.Js version we did originally before switching over to Nuxt. And inside of here within index.html we have a link tag which references all of our Google fonts that we are using. So if we look closely, family is equal to exo plus 2. That is going to be the first font we want to import. I believe that was the font for our paragraph text. So what I want to do here is I just want to copy this name, including the plus 2. And then if you ever have some sort of plus within a font name and you need to specify it as a JavaScript property, you need to make sure you wrap it in quotes like you see right here for Josephine Sand. So I'm going to go ahead and get rid of that and replace it with exo2. Now looking at exo2, we know that it's going to be italic at a weight of 700. So how do we specify that exo2 should be italic with a weight of 700? Well, thankfully, they gave us some examples to see how to do this. Let's look at Railway. It gives us a weight and an italic. So I'm going to go ahead and copy that. And instead of setting exo2 to true, I'm going to create an empty object and then paste in the weight and italic properties. Just to make this a little more clear, let's go ahead and get rid of the other fonts now that we have these in place. So I'm only really using the italic version of this font. So we don't really need this weight property because we're going to specify the weight of the italic version right here. What is the weight of that? Well, it's going to be 700. So instead of 100, we're going to put in 700. So now we should be able to make use of the font exo plus 2. Let's go ahead and see if that works. So I'm going to go ahead and minimize this for the time being, and I'm going to go back to our project. And now if I refresh, well, it looks like we just need to restart our server. So over here in my portfolio Nuxt, the first tab we had open originally, if I run npm run dev, the classic run command, we're going to restart our server and make sure you save Nuxt config so that these changes take effect. We definitely want to make sure that we are running our build module section with the new Nuxt.js Google Fonts module. So once that loads, we'll go ahead and refresh at localhost 3000. Still not seeing anything, unfortunately. So why is that? Well, I can tell you right now, we definitely have Nuxt.js Google Fonts installed, and we're definitely pulling in exo plus 2. But if we go ahead and inspect our font that actually uses exo2, remember, we created a class with font-exo, which puts in the font family styling, which actually changes this to the correct Google font. But if we look at the styles being applied, there's no style being applied for this class of font-exo. Let's go ahead and check out our old project real quick. If we look at my portfolio and look within our style tags, well, we created two classes which specify the styles of our new Google fonts. We have one for font.exo and one for font_mono, but we never actually transferred this over to our Nuxt project. So if we want to transfer this over, we're simply going to grab these two classes. Now, where do we put these? Well, if you go inside of Pages and then index.view, and you start to scroll down to the very bottom, there's going to be a section for style tags. You could technically put these right inside of here. And if we refresh our page, you're going to see our font is now being applied. But why would I recommend against putting these styles right here within index.view? Well, these styles are only going to be loaded for this specific page. If we want these fonts to be available across other pages, we need to put them in some sort of base layout. Now, where is a layout file for Nuxt.js? Well, if we look within this layouts directory, there's going to be something called default.view. And if we look inside of here, we have our template tags, and then there is a Nuxt object. This Nuxt object basically represents any page we are currently visiting within our pages directory. So Nuxt right here is just a representation of index.view. Everything inside of default.view is just a main wrapper for our entire site. You can see this in action. If I go ahead and put in an h2 tag right here, you're going to see our h2 tag is at the very top of our page because this default template is acting as a wrapper for all of our pages. It's basically a place to put global styles and global HTML, such as like a header or a footer. So we're going to go ahead and get rid of the h2, and we just want to make sure back in index.view we take these font styles, we're going to go ahead and cut it out, go back to default.view, and we're going to use these within our default.view template so that way they are available globally and we can use them on other pages if needed. So you'll see that it's scaffolded a few styles for us by default. We don't need anything below these little stars right here, so we're going to go ahead and get rid of those. And then we just simply paste in font exo, font space mono, and now our font is back and it's being read because we told Nuxt config that we want to use exo plus 2. So we have exo 2 working, but why up here is space mono working even though we never actually imported it within our Nuxt config using our Google Fonts module? Well, this is simply because, let's go ahead and inspect this just so I can show you exactly what's happening. If I go ahead and close out of controls and inspect my name, which has the class of font space mono, you see that we are calling for the space mono font. Why is it being applied even though we never specified over here? Well, it's simply because I have this font on my local computer. If we were to push this live and some random visitor visits your site and doesn't have that font on their computer, they're just going to default to the monospace font. So if I go ahead and get rid of space mono, this is what your text would look like instead. Still looks kind of cool and techy, but not really the kind of font that we want. I do like space mono better. So even though mine is working, it's not going to work if you push this live and someone doesn't have the font on their computer. So let's go ahead and make sure that we're adding it in with the Google Fonts module. How do we do that? Well, we need to make sure we are looking at what font we want to bring in. So back in our original project, we're going to look for space mono. This is the name of the font. We want that first. That is going to be our second family, and since this has a plus in it, we need to make sure that we're putting this inside of quotations. And since this doesn't have any weight really associated with it, we can just go ahead and set this equal to true, and it's going to pull in the font exactly as we need. So by including that, the Google Fonts module is going to make sure that you have both the XO2 and the space mono font involved in your project. So now this is looking very similar to what we had before. Our fonts are in place, and we're getting closer and closer to the point where we can create that seamless transition. Let's go ahead and see what this looks like one more time. Once we get right here, we're still redirecting to chriscourses.com because we have that old transition in place, but that is where we're going to transition into a different page within our pages directory. I'm going to show you how to do that next, so stay tuned and I'll see you in the next video right now. Alright, so looking at to do, we transferred over HTML with Google Fonts and we imported them using the Next.js Google Fonts module. Next up, we are going to create the work page, and that is going to occur after we click the View Work button and we do the little star bolt effect. So let's go ahead and do that now. Let's go back to index.view so that when we click on our button, we go into the stars. We're no longer redirecting to chriscourses.com. We're going to redirect to a new page within our Nuxt project. So within index.view, if you scroll to the very bottom of the page, remember we are redirecting our user on complete of our camera animation, and we are doing so by setting our window location equal to whatever URL we want to visit. In this case, for me, it is chriscourses.com. We are going to go ahead and get rid of that code completely because we are using Nuxt.js now. So let's go ahead and just get rid of it. We're going to save it, but we're going to create a new page first. So within our pages directory, we're going to create a new page. So I do this a quick way. I hit Command Option N within Sublime Text, and it allows me to enter a path for a new file. Typically, I would just hit /, and I would go ahead and add in the name I want to call this file. So in this case, I would call it work.view, and it would create this file right here within my pages directory. But I know a lot of people don't have Sublime Text, or they aren't able to use that creation option. So let's go ahead and create this file a different way. We're going to go to our Sublime Text menu and hit New File. So inside of here, we don't really need to put anything inside of here just yet. We can just go ahead and hit Command S. It's going to prompt us to say, where do we want to save this file? So for me, it's already defaulting to this pages directory, but probably not for you unless you selected pages. So you're probably going to be within your My Portfolio Nuxt project. So once you're here, you just want to go ahead and hit pages, and then we're going to call this file work.view. This right here is going to be the URL you're going to visit to view this page. So if we go to localhost 3000/work, because we created a work.view file, well, it's going to render the contents of this file. So if we go ahead and save that, then work.view, we need to create a template tag because this is a view file. Anything within this template tag is just going to be HTML. And whenever you want to render HTML within a view template tag, you need to make sure you have one root element, which is typically just a div. And then inside of here, you can go wild with your HTML. You can put pretty much any HTML you want inside of this and it'll be rendered correctly. So I put in an H2 and just type in work. Well, now Nuxt already creates the routing for us so that if we go to localhost 3000/work, well, we are rendering out the H2 of work. So this is looking perfect. And the cool thing about Nuxt is we can actually hit the back button here to go back to our original URL. If I go ahead and hit back, well, now we're back to localhost 3000. But if I want to go to our work page, I just add in the URL and all the routing is taken care of. We're only rendering the exact content we want on the page. So really what we need to do is when we click that button over localhost 3000, when we click this, we need to redirect to that work page. So let's go back to index.view right here within our onComplete listener. This is where we were setting our window location. We're not going to do that anymore. We're going to select what's known as a router. So Nuxt comes with what's known as a router object. We can go ahead and see what this looks like by console logging out this $$router. If I do this and I open up our console, hit view work, on complete of this animation, we should see the contents of this .router, and there it is. So this is a view router, and basically it contains things such as the history of where we actually navigated to throughout our app. It also contains a few methods that allow us to change the URL without actually refreshing the page. So we're just going to be pulling in the content on that page, but not loading any new scripts, not loading any new link tags or anything like that. So one of those methods is going to be, let's go ahead and get rid of this console log before we call it. This router has a method called push. And basically we're just pushing in a new URL that we want to visit when this is called. So what URL do we want to visit? Well, it's going to be /work. So if we push in a URL /work, we reload our page, we hit view work. At the very end of our animation, we're going to go to the work page. So now you'll see we're at the URL /work and we're displaying the contents of our work page, but we do have the issue of our scene still being rendered in the background. Now this is going to bring me back to our to-do list over here. We created our work page, which is great, but this is going to bring us to the task refactor canvas to index page element. What does that even mean? Well, the thing is, within our current code, within our current Three.Js code, if we look for .append child, we are currently appending our render, our canvas, onto our document body. So if we start looking through our elements over here, specifically our HTML and everything, you're going to see that our canvas isn't actually within our Nuxt tag divs. It's at the very bottom, appended, because we are adding it onto our document body. We want to make sure that this canvas is only available within our index.view page. We don't want to append it on the document body because that means it's basically going to be within our default layout. It's going to be available globally across our site. That's not what we want because it's inefficient, it's wasteful. We want to make sure we get rid of this canvas as soon as we go to this new page. How do we solve this? Well, the first thing we're going to do is we are going to get rid of this line of code completely. We are no longer going to be appending on our canvas element, our render, onto our index page. We're going to get rid of this. And let's go back to index to see what this looks like. So we're not seeing anything because we don't have a canvas to render our Three.Js project on anymore. Well, to make sure we still have a canvas here, we need to supply one to our new WebGL renderer. So this actually takes an argument, which is going to be an object. This is like an options object where you can declare specific options for the WebGL renderer. What is the option we want to declare? Well, it's going to be a canvas property, and we need to supply this an HTML element, specifically a canvas element. So we can't really do that just yet because we haven't created a canvas within our HTML, but we can do so really easily. To create a canvas within our HTML, specifically within our index.view page, we can go ahead and scroll to the very top within our template tags. Now, where within here should we actually place a canvas? Well, This container is more so for our text, and we know our canvas should be behind it. So it doesn't really make sense to put the canvas inside of this container. As a result, we're going to go ahead and create a canvas element right above it. So just an opening and closing canvas tag. But since we just put canvas right next to this div, and there isn't any wrapping element, we need to make sure, like always when using Vue, that we have one singular root element within our template tag. So right now we have two. We have canvas and div. We can easily fix that by wrapping these two in one div element. So I'm going to put an opening div right here at the top. At the very bottom, I'm going to add in a closing div. And now we won't have any bugs with rendering or anything like that from Vue. But we are getting a bug over here specifying that we have an issue with our WebGL render that we were just editing earlier to insert a canvas property. Well, we're going to fix that really quickly to specify what canvas element do we want to use for our WebGL render. So Vue has this really cool thing where within your HTML elements, you can specify what's known as a ref. If I go ahead and add on a ref attribute and set it equal to a name, such as just canvas, this is arbitrarily named, by the way. This name can be anything you want. Well, now I can go ahead and reference this element directly within our code without having to run something like document.querySelector. Those can get really bulky, really annoying to use, and they don't always select the right thing. But if we want to select just this one specific canvas element with a ref of canvas, well, we can do exactly that. So let's go ahead and find where we want to supply a canvas to our WebGL render. We can easily do that by hitting Command F and then just searching for WebGL render. Hit enter, and here it is. So how do we select our canvas element right here? Well, we're going to do so with this dot refs. All the refs on our page, we only have one, but if we ever want to select something else, well, they're all going to be available within this refs object. What is the name of the ref we want to select? Well, we called it canvas, and that's it. By selecting our canvas with refs right here, that's all we have to do to supply a canvas to our WebGL render, and you see it renders, no problem. Really cool things that Vue and Nuxt provide, which is why I love using them so much within all my personal and client projects. So let's go ahead and see how this works now, because if we look closely, canvas right here is now within our Nuxt project. It's no longer appended to the very end of our body. It's no longer global. So theoretically, if we hit the View Work button and we do the router push into the work page, well, we're no longer going to have the content from index.view. We're going to have the content from work.view. And as a result, we're going to be deleting our canvas off the screen. So we hit View Work. We bolt into the stars. And now the canvas is completely gone. It's no longer rendered. And we have just our work page. We can focus on exactly that. So that transition was a little jarring. How do we make this completely seamless? Well, I'm going to show you how to do just that in the next episode. So I'll see you there right now. So we refactored our canvas to a canvas element. I'm going to go ahead and check that off. And we created our work page, but I mean, how far did we really create it? We just created a page in which we can go to /work. So I'm going to add in one task here that says add work page content /seamless transition. This is what we're going to do next. So for this, I'm referencing the complete piece just so we have something to work off of, know exactly what we want to develop. So bringing this to the side, we have our work page over here, but when we hit View Work on the actual complete piece, we go into the stars, and then it's so seamless. Why is it so seamless? Well, basically, we are transitioning to a page with a black background. So we're going from a completely black environment right now to a completely white background. But if we were to make this black, when we do the animation right here, well, we're going to go into the black stars, and then we're going to be presented with a black background. We're basically feigning the transition. So let's go ahead and start with that. Let's go ahead and make this background black. To do that, we know we need to go inside of our work.view page. This is all the content being displayed right now. We have one root div that acts as the container for everything. If we go ahead and give this a class of bg_black, which comes from Tailwind, you're going to see that part of our background turns black, but not everything. So right now, this background that is black, the height of it is determined by the content inside of it, which is just this work h2. If we want this to take up the full screen, we need to specify manually. So we're going to add on another class of h-screen. This is going to make sure that this one div takes up the entire height of the screen, no matter what height it is. Simply by adding this, you're going to see now we have a completely black background, which is perfect. But we can no longer see our text. We want to make sure we see that. So with an h2, we'll add a simple class. This is going to be text dash white. Obviously that's going to contrast with black, and there it is. So now, just by adding in the simple black background, if we go ahead and test this transition again, we hit view work, we go into the stars. Well, that is already looking a lot better. It's not quite seamless because this text just kind of appears jarringly, but we're going to fix that. Let's go ahead and fix that next. So looking at our example piece, my work is bold, it has our font, and is much better arranged than what we have up here with just work being in the top left hand corner. So let's make work look like this over here. How do we go ahead and do that? Well, something I like doing when I develop is making sure that I have both of these open and visible right next to each other, and that way I can make sure that I'm matching this up exactly with what my design is. So looking at this, how do we make work look like this over here? Well, the first thing is the text over here is my work, not work. It kind of makes sense to add in the text of my work. This is how I develop sites for real clients, by the way. It's just going off a design and making sure that I match it up as close as possible. So we have my work in place. We know this font is using font exos. We created a font exos class that is in default.view right here. So we can just specify that h2 should be font exo. And that is already looking pretty close to what we have over here. So we probably want to make the text a little bigger because this is presenting the content of the page. It's just a simple headline, and when you have a headline, you typically want it to be big instead of small. So we're just going to make sure that this is bigger with a tailwind class of text-2xl. We'll go ahead and see what that looks like. Not quite there. Let's go ahead and try 4xl, bump it up a little bit. And it looks pretty close, but maybe not exact. Let's go ahead and try 5. And I think that is exact, maybe even a little bigger, but that looks pretty good to me. So the very next thing is, this has breathing room within the example piece. A lot of breathing room at the top and a lot of breathing room on the side. Breathing room is very important for readability. You want to make sure that things aren't cramped so people know exactly where they should begin reading your text. As a result, we're going to go to our root div and start adding some padding in here. So if we want to affect just the left-hand side padding, we're going to add in PL dash. And by what increment do we want to increase it by? Well, typically for my left and right hand side paddings, I usually do something like 8 within tailwind, which I believe is about 2 rounds. Let's go ahead and see what that looks like. Bring up the example. I'd say that's pretty close, maybe a little less. We can probably go to 6. This is actually what I use for pretty much every project, is 6 on the sides of the left and the right. But one thing here is, if you go ahead and shrink this screen down, we can't really see it right here because Chrome doesn't allow you to shrink it that much, but I'm going to go ahead and open up a little emulator, which you can do by clicking on this toggle device toolbar right here. It's not really a big deal. I just want to go ahead and show you this example real quick. If I go ahead and start resizing my screen down to something really small, you're going to see there's no padding on the right hand side of the screen. This doesn't break down until I actually touch the text. That's not what we want. We want to make sure we have padding on both the left and the right hand side. So instead of just adding padding left 6 right here, I'm going to call this px6 instead, which just means we're putting padding on the x-axis on the left and also the right. And by doing that, you can see that this breaks down. Before I even touch it, we have the breathing room in place, which is great for design and readability purposes. So looking at this, we want to add a little bit of padding to the top. And whenever you add padding to the top, well, you kind of want to add padding to the bottom as well. So we're going to add in a py, which is padding for the top and bottom. Let's just go ahead and double px6, so py12, get a little bit of extra padding on top, and I would say that is pretty darn exact. It even lines up perfectly, so cool. So now we need to create this little portfolio of images right here. So I'm going to show you how to do this in a really cool, efficient way with Nuxt.js. So what do we need? What do these images actually represent? What HTML tags? Well, I think obviously we need some sort of image tag. So I'm going to create an image tag. And now we need some sort of image to use within our project. So if you ever need some sort of stock image that's free to use in your projects, well, you can simply open up a new Chrome window and search for Unsplash. So Unsplash is a free stock photo site. They have some of the best images I've ever seen for free that you can use pretty much on any website you like. I highly recommend it. And here you can just begin searching for images you'd like to use within your portfolio project. So for me, when I was doing the example, I simply just searched for tech, I believe it was, and you'll see this is one of the ones I used. You can go ahead and select any of these. I really like the bright colors here because they contrast really well with the background and make your stuff stand out. So this was one of the ones I used. If I want to go ahead and download this, I simply just click on it. And then you can go ahead and click download free. So right now I'm probably downloading the full resolution version of this because I just simply clicked on this download free button. But if you click on the arrow next to it, you're going to see we have a couple of sizes that we can use. So for our project dimensions, we might just want to use the small version because it doesn't look like the image is going to be much bigger than these dimensions at 640 by 966. So let's go ahead and see what that looks like even on my Retina display. If it looks a little pixelated, we'll go a little higher, but we'll start off with small just to see what this looks like. So we just downloaded that, which is perfect. We can go ahead and minimize this window, go back to our projects, and now we want to open up Finder. I'm going to open up two windows. The first one is going to be my downloads directory, and you'll see my image was downloaded right here, and it has a 1 next to it because this is a small version. You'll see it's very small at 106 kilobytes. So I just want to keep this window open, and then I want to find my project within my second window. So if I go ahead and search within my node directory, which I put right here by default, yours is probably not here. If you want to find your node directory that has your portfolio project in it, you need to click on your home directory and scroll on down until you find node where you initially created this folder. So inside of here, I have quite a few projects, but we know ours is called My Portfolio Nuxt. I'm going to go there, and then I want to go inside of my assets directory. So any images you want to use within your project, you just simply put within this assets folder. So we want to just go ahead and drag this on over. And this file name is quite long. This is not something I want to reference within my code, so I'm simply going to rename it. And let's rename this iPhone. And that's quite succinct. It's going to make our code a lot cleaner because the text size is smaller. So how do I reference this iPhone image right here within our image tag using Nuxt? Nuxt makes it so freaking simple. So all we need to do is specify we want to go from the root of our project with this little squiggly. So starting right here. And then we want to go into our assets folder. What do we want to reference? Well, simply our iPhone.jpg. You can add an alt tag here if you really want. For accessibility, we're just going to call this iPhone. And just by doing that with Nuxt, it automatically knows to load this image from this assets directory, and it's going to put a few optimizations on it as well because we're loading this through Webpack. So really nice stuff from Nuxt.js. So we have this one image here, but what if we want multiple images to display all of our work? Well, let's start off with this one image, and then we can begin varying things as we go. So if I go ahead and copy and paste this line, we have 3 images then. Things refresh, but why do we only see one image right here? Well, all of our images are placed beneath it. If you ever want images to be placed next to each other by default instead of stacked on top of each other, well, you need to wrap them in a containing div. So we're going to go ahead and do that. We're going to put all 3 images within a div, and then we need to give this containing div a class of flex. We're going to put this in a flex layout. So just by putting this in a flex layout, the images are no longer beneath each other, but rather they are at the side, which is a great start for what we want. But of course, this isn't the exact look we need. We need to make sure that these images are responsive, specifically within responsive containers, so they only take up the section of the screen we're actually looking at. So what I'm going to do next is I'm going to wrap each of these images within a div tag. And this div tag is what's going to serve as our responsive container for each of these images. And just by doing that, if we go ahead and inspect our page and inspect one of these images right here, you're going to see we have our containing div, which takes up this amount of space, but by adding a div, Flex by default resizes it down to the containing space. And then inside of that, the image is now only taking up the full width of this containing space. So by putting the image inside of a div, the image size is no longer dependent on itself, it's dependent on the parent div. And since those divs are inside of a flex element, well, they're automatically resized to fit the container. Hopefully that makes a little sense. It's a little confusing when you're first learning Flex, but this is exactly how you want to do things to achieve the same layout right here. And using Flex, I mean, it's really cool. We can just go ahead and add on more and more projects right here, and it's automatically going to resize it to fit the containing div. Now, obviously, these aren't the correct height. We could do a few things here. For our image, we can go ahead and add in a style tag and add in a custom height of something like 200, 400, 300 pixels. Let's go ahead and just do 400 to see what this looks like. We go ahead and add this in, and that reaches near the bottom of our screen. But the thing is, if we were to view this on a larger display, well, this isn't responsive and it would probably go off the screen at some point. We want to make sure that the height for this is responsive, just like our background black container is with height screen. So instead of specifying our height should be 400 pixels within the style tag, what I want to do is specify a view height instead. The view height property is going to determine the height of the element based on the height of your browser window. So if we go ahead and say that the height of this should be 50% of our browser window, that goes to about right there, which looks okay. And if I start resizing this, you're going to see, as I begin to bring the height up, that the height decreases for that one image right there. Let's go ahead and get our image down to right about here. And to get this down there, we just want to go ahead and start guessing the height we want to use. So 60 is getting pretty close. Let's try 70. I think 70 is pretty close to what I want. So I'm going to go ahead and keep the height for this at 70 view height. Now, how do we change the height for all our other images as well? It's kind of tiresome and annoying to have to grab the style tag and paste it on top of everything else. So let me show you something real cool with Vue. We're going to go ahead and get rid of every other image that we are currently using within this Flex container. So we only have one, that's perfect. But if we want to go ahead and use multiple of the same HTML tag, we can add in a v4. This is going to be equal to 2 double quotations, and then we're going to specify n in how many times do we want to run this piece of code? How many times do we want to show this HTML element? Well, let's say we want to display it 1, 2, 3, 4, 5, 6 times. We're just going to say n and 6. All that does is say to render this piece of code 6 times. We can specify as many as we want using Vue. We don't need to copy over anything annoying such as the style tag and put it in all those different divs. We just do it in one spot instead. So a big time saver, and it makes your code super clean in the process because now we're only focusing on one div instead of 6 to 20. So this is looking good, but we obviously have the issue of, well, our image aspect ratio is definitely off. This is stretched completely, and it just looks quite terrible, to be honest. To make sure that the image always has the correct aspect ratio, we can go ahead and add a class onto our image tag. And one of the classes we're going to add on here is going to be object cover. And just by adding object cover, it's going to make sure that our image has the correct aspect ratio at all times, no matter how much we resize our height or how much we resize our width. It's just going to make sure that it always fills up the container perfectly using the correct aspect ratio, but obviously we're just not going to be able to see all of the image because that's just the way an image would actually work in this container. So this is looking good, but it's a little funky because right now we don't have any padding in between any of these elements. So one thing you might be thinking is, well, for each div that we are currently looping through, can we add on a class of like mx2 to give some spacing here? And you'll see that did indeed gives it spacing, but there's going to be spacing on the very left-hand side element, some margin right here. We don't really want that. We want to make sure our image lines up perfectly with our text above. So we're not going to use any mx2, we're not going to use any padding or anything. Tailwind 2 has a really cool class that we can put on the parent element. And this is going to be a class of space x-2. And what this is going to do is it's going to apply some very specific margin to make sure that there is spacing in between each of these elements, but it's not going to place any on the left or right hand side. This is such an awesome way to put spacing in between your elements. I love it so much because it makes things so simple compared to what it used to be. So you'll see right now this lines up perfectly with our text up here, and we still have spacing in between these so we can differentiate our images to where they're supposed to go. But there's a little more padding right here in the example piece, so if we want to match that exactly, we'll go ahead and add a little more spacing right there, and that looks to be pretty darn close to what we have over here. So now you'll see each of these projects has text associated with it. This is the project name. If we want to go ahead and add that, well, right beneath our image, we can simply add in a p tag and then add in the project name. So actually this is called iPhone, so I'm going to call it iPhone right here. It's going to refresh. We can't see anything because our text is black by default. We want to make sure this text is white, so we're going to add a class of text white. And now we see our text, but it doesn't really look as good as we have over here. This has that high-tech look because it has the font of what? The font of space mono. We're going to go ahead and add that class on. And And that gives us that nice font, but this font doesn't look that great at the default text size of 16 pixels. So typically when I have some sort of like secondary text like this, I like to make it smaller to de-emphasize it. When you de-emphasize things, that shouldn't be the main focus. By default, they're just going to look better. So if we shrink that down, well, that definitely looks better than it did before. And I would say that's pretty close to what we have right here. So I'm going to go ahead and keep that for our project title. So obviously all these images are the same and our text is the same. Not very good if we want a portfolio. We don't want to show the same thing over and over again. We're supposed to display all of our work here. So if we want to display more photos, what we want to do is go back to Unsplash, which I have, I believe, right here. I minimize that. We just want to find more photos that we'd like to use within our site. So based on our layout, it makes sense to try to look for images that are more of a portrait aspect ratio compared to landscape. So if I go ahead and look through this one looks good to me. I'm just going to go ahead and take this, download the small version. That's one. Let's say I want just one more. You guys can grab as many as you'd like. This one looks cool. I'll grab that. I like the hamburger. So we're going to go ahead and get the small version of that too. We have all of the extra images we want to use. And remember, we just want to drag these back into our assets directory right here, which I kept open. I'm going to go ahead and take those additional images from my downloads folder. So it looks like it's these two. Put them on over here. These names are way too long because we need to reference these directly within our code. So we're going to go ahead and call this one person. That makes sense. And then this one is just going to be laptop. So once your images are there, you'll see that they show up within your assets directory. Well, if we're using a loop like this, how do we make sure that we're referencing one of these new images instead? Well, we're going to do so programmatically using more view magic. So view files also have a script tag associated with them. This is where we run all of our JavaScript and programming. And by default, in order to run specific view code, we need to export a default object. And now we can begin using view code. So what I'm going to do is I'm going to create a data function just like that. And this is going to return an empty object. So the data we're going to put in here is going to be representative of each of our images and each of the titles we're using for these images. By putting data here, we are able to separate our data from our HTML layout. And by doing so, our code is going to stay completely clean. But if we ever just want to look at our data separately, we have a spot in which we can do that. That's going to be right here. So let's look at this over here. This represents our data. What kind of data is this? Well, each of these is a project. So if we think about it, let's go ahead and create a property called projects. What should this be equal to? Well, it's going to be equal to an array because we have a grouping of projects. So inside of here, we're going to have one object, and this object is going to represent just one of these projects. So what properties does one of these projects have? Well, it's going to have an image. We're going to create an image, and that's going to be equal to an empty object. And what does an image have? Well, it has a URL. We're going to set that equal to an empty string. Make sure you format things correctly so it looks good. And what other data does one project have? We have our image URL right here. It also has a title. So next to our image object, we're going to add a title property and set this equal to an empty string. So if we want our first project to be equal to a title of iPhone, we're going to go ahead and grab this and set our title equal to iPhone. And what is the URL of our image? Well, it's going to be this right here. So we're going to go ahead and grab that and put it within our image URL. So instead of saying we just want this to run 6 times, what we're going to do is we're going to delete everything within the quotations here for v4. We want to say for each project in our projects array. This right here references this one project array, and one project here references one object within this array. So we're going to be looping through all of the projects within this project array, and now we can make use of the properties within them. So if we reference this one project right here, it has an image property. We're going to grab that one project and replace our source with project image and then the URL, so we reference this directly. If we save this, it's going to refresh. Our image is going to be broken by default. Let's go ahead and inspect it. You'll see the source for our image is project.image.url. It never actually rendered this right here. This is what we actually want to reference there instead. So if you ever want to reference some sort of variable from Vue, such as your project variable, well, you need to make sure that you bind it to the attribute. And to bind it, we are going to be using a : before the source tag. And you'll see this instantly lit up, specifying that this is a variable we can reference. So if you add in the colon, we're going to be referencing the project image URL instead of just the string, and we inspect. And now we are referencing that directly, but we don't see anything within our actual page. So this little magic with squiggly / assets in which view loads images is only going to work within your template tag. If you want to go ahead and load this directly within your code, well, you need to import it just like you would an ES6 module. So we're going to use an import statement that says iPhone image should be imported from that exact URL. And if we do things this way, and we replace our URL with this variable right here of iPhone image, you're going to see our image now shows correctly. And if we inspect this, we're referencing the static URL which Nuxt creates for the specific image, which allows it to show. So we have our image showing, but now we want to replace the static text with the title within our one project object. So to do so, we know we want to reference our one project, and we're going to render out this one project with double opening and closing curly brackets. We're going to render out what from this one object? Well, specifically, its title. This is going to go in between our paragraph tags. So we're getting the issue of cannot read property title undefined. Well, I want to make sure I'm referencing our project that we're looping through, not our iPhone image. That wouldn't make sense. And if I reference project.title instead and refresh, let's go ahead and full screen this. Well, now this is equal to iPhone. Everything is still kind of the same, but you can see that if I were to change this right here, that this updates accordingly. So now we're rendering our HTML based off of our data rather than having to create multiple HTML tags to reference different things. So if I want to go ahead and add in one of these second images, all I have to do is duplicate this one object. Make sure you add a comma to the end of it. So what is the title for this project going to be? Well, we have one for laptop. Let's go ahead and call our title laptop. And then we want to make sure we are referencing our laptop image, not the iPhone. So right here, we're importing our iPhone image using this import statement. I'm just going to duplicate this. And I want to call this variable laptop image. And we want to import our laptop. So I'm going to change iPhone to laptop right there. And then we want to make sure that for our laptop project, which is this object right here, we're going to change the URL from iPhone image to laptop image. And now we are rendering that instead, and we have a lot of variety. This is looking really cool to me. So I'm going to challenge you to do the third project on your own. Go ahead and pause the video, see if you can do it. So to import the third project here, I'm simply going to duplicate this object. I'm going to change our title to person. And then our URL is going to be equal to not the laptop image, but a person image instead. And this references person from our assets directory. So now that this is available to us, I'm simply going to go to our image object and set the URL equal to person image. And now we have the person in there. So looking really cool. We have a lot of variety. You can add as many as you want. But for my purpose, I want this to go pretty quickly as a tutorial. So I'm just going to copy these three projects and simply paste them beneath each other. Now this is looking pretty cool. You might notice one issue is that the width of these is not exactly the same. So if I want each of these images to have the same exact width, all I have to do is add in a class of width full. It's going to set the width equal to width 100. And when you do that inside of a parent container of flex, it's just going to make sure that all the child elements are sized equally. And as you can see, now each of these is perfectly sized, looking very good and very close to our example P's. So we have the layout in place. Let's go ahead and go back to our index over here. We hit view work. We go into the stars. And now we have our complete my work page. Now we just need to make sure that this is completely seamless with animation. So to animate this, we're going to animate it very similar to what we did with our text within the first couple of episodes. We're going to start by setting our text to its initial default state. So our text is going to have an opacity of 0. And each of our projects is going to have this as well. We're just not going to show anything, even though it's all there behind the scenes. We just want to make sure we animate this onto the screen. So we want to run some sort of animation text whenever we first visit this page. Well, we want to go down to our view object, and right below our data object, we're just going to be the second curly bracket from the bottom right here. We're going to add in that lifecycle method mounted, which is going to be called whenever everything is loaded on the page. And we're going to start running some GSAP code. So if I go ahead and call GSAP to, well, what element do we want to animate? Well, we can go ahead and specify this with a class or something along the lines of that, but there's a cooler, more specific way to do it with Vue, and that is using another ref attribute. So within our H2 right here, if I go ahead and add a ref of title to this, I can go back down to my GSAP code and specify I want to reference my refs within this one work view file. What ref do I want to reference? Well, we call this title. This is what I want to animate. And what do I want to animate? Well, I want to animate its opacity back to 1 whenever this page is first loaded. So if I go ahead and refresh, we're getting the error GSAP is not defined. Within Nuxt, you need to make sure that you are importing this in order to make use of it. So we're going to go ahead and import within the script tag right here within work.view. We're going to import GSAP from the library GSAP. And if we do that, now we can use it within our mounted function. And you'll see that animation just occurred. My work just faded in. Let's go ahead and make this a little slower. We're going to change our duration to 1. This should slow it down a little bit. Let's go ahead and make it 2. Slow it down even more. Okay, I like that a lot. I'm going to keep that where it is for now. So just by doing this, if we go back to our index right here, we hit view work, we start scrolling into the stars. Once we hit this page, now it animates in. We have that seamless transition from black to black, and then we call our animation code to fade in our text. So all we really have to do now is make sure we animate in our projects. And if you noticed over here, whenever we load this in, it has a nice little stagger effect. So how do we create that stagger effect for all of our projects? Well, we are going to call another GSAP2. Now, instead of referencing just one element here, we want to reference multiple projects. So let's go back up to our template. We're going to look for where we're looping through all of our projects. This is what we want to select. So here I'm going to add on a ref, and I'm going to call this projects. So since this is being placed on something that is being looped through about 6 times, well, this is going to basically be equal to 6 project elements instead of just 1. So by putting that right there, we can call GSAP2 and then reference this .refs.projects. So we basically have this grouping of elements that we can now animate their opacity back to 1. So we do that and we refresh. Now you'll see that these are animating in. Let's go ahead and change their duration to 2, make it a little slower. And that is looking good, but it's not very interesting. It doesn't have that stagger effect that I showed in the example. Now the thing with GSAP is it makes this so freaking easy to do. To add in a stagger effect, we're simply going to add in a property of stagger. And this is going to be equal to a duration. By how much time should each of these opacity animations be staggered by? Well, you're going to want it to be something small, such as 0.1 seconds. So that way they don't take too long to actually fade in the screen. Just by adding that, you'll see that we just created that stagger-like animation. This is already looking really cool. But we can take this even further by using some translate styles. So by default, let's go ahead for our H2, add on a style tag that's going to be equal to transform, translate, y. I'm going to start this by pushing it down. So I'm going to translate it by 30 pixels downwards. You'll see that is now down. That is perfect. I'm going to copy the style attribute and place it within our tag that has the ref of projects. Each of these is going to have their X translated by 30 to the right instead, because I want these to translate in from that side. It's going to create for a really cool animation. So it looks kind of goofy right now, but if we scroll back down to our animation, we can simply translate our titles Y back to 0. And then for each of our projects, we're going to translate their X back to 0. And now we have translates in there as well, but it's still looking a little jank, not as clean as it could be. If you want to make sure that these look as good as possible, you need to make sure you're adding in easing effects and the right one. So we're going to specify an ease property. My favorite is always going to be expo. Whenever you have an element that's appearing, I typically always put an ease out on it so that it decelerates into place. It creates a natural movement. And each of these eases by default is an ease out. So we just need to specify we want the expo curve. It's going to make this look a little quicker. I'm going to do the same thing for our projects. And that is already looking so much quicker and so much cleaner than what we had earlier. So let's go ahead and test this out from the very beginning. You always want to make sure you're testing to make sure this transition looks good. We're going to bolt into the stars. And I think that all looks great, but one thing is my work. Looks like it's kind of animating over our images. So what I'm going to do is I'm going to add a delay to when we start to actually animate all of our images. This is just going to be 0.2, give it ample amount of time. So now my work goes into place, and then our images come in after, and we can even delay this by a little more, tune it to your taste. I'm going to do 0.3, make sure this goes all the way into place, and maybe even speed that up. This is just to taste at some point, so don't take all this to heart, all the little changes that I'm doing right now. I'm also going to speed up our image animation as well. And that looks super, super clean to me. So let's go ahead and watch that one more time. We go from our main page. We begin to go into the stars. Our URL changes, and we have this really nice animation in place. So what would be a next step from here? Well, you'd probably want to go in to one of these projects, but right now you can't actually click on anything. So to get these to link to another page without actually refreshing everything, we're going to use what's known as a Nuxt link. And this is going to be rendered out as an anchor tag. You just want to make sure that you're wrapping your image and your paragraph tag here with this Nuxt link tag. And this is going to have a to attribute. You need to make sure that you set this, otherwise you're going to get this error on the left-hand side. We're just going to set this equal to our homepage so we can kind of jump back and forth between the two. If we set to equal to that, save and refresh, you're going to see our animations occur, and now our cursor is a pointer. If we hover over these in the bottom left-hand corner, you can see we're going to go back to our home page. So if I were to click on one of these, we go back to the home page, and now we can kind of jump between the two pages that we have. Ideally, you would create a different page for your projects over here using slugs. That is kind of a whole nother tutorial in itself that I think should go along with a Nuxt course. So I'm not going to go too far into that, but I hope this provided a really good introduction to Nuxt.js, why you'd want to use it, and how it really helps create those seamless transitions that are efficient and that don't load every asset, every script, every link on the page over and over again as you visit something new. But this is, like I said, exactly how I'd code this for a client. I'd probably add in a little bit of database control, but whole nother course in its whole self. So I hope you guys enjoyed learning how to take your Three.Js project and put it in a real world piece to create seamless transitions within your work. As a little spoiler for you guys, a little preview for the next course, I'm going to be doing an intermediate Three.Js course that teaches you how to code the GitHub globe over here. It's not going to be exact. I'm not going to be adding in the whole Git poll server thing and everything like that, but I will be doing some data associated with the globe and show you how to create an effect that is very similar to this. It's going to be more advanced for sure, but I hope you guys are ready to learn more. Hope you guys enjoy this tutorial. I'll see you there. Thanks. Peace.
It's break time. Do you like this video? Don't forget to subscribe to get new videos. Share this video to open new premium videos and ebooks. We'll be a star freelancer.
This video is over. Go to starfreelance.eu to download these videos, materials, and sources. Watch more videos to get premium videos and ebooks. We'll be a star freelancer.